repeat this process over and over and over. But what you really want to do is you want to go as fast as you can without a capacitor, for the simple fact is you want to put a lot of this radiant energy to the source.
I can't find my way back to you until you make amends with the demons you've been through. And I can't regret leaving you alone until you find your way back home.
Come on. Do it! Do it!
Do it. Do it.
Do it!
He's doing it. Do it. Do it. All of it.
Come on! Do it now!
That would be the best.
Until you find your way back home. Don't let me drown. Don't let me drown. Don't let me drown.
Oh, these cookies! Put that cookie down! Now!
Until you find your way back home. I can't regret leaving you alone until you find your way back home.
You want to repeat this process over and over and over. But what you really want to do is you want to go as fast as you can without a capacitor, for the simple fact is you want to put a lot of this radiant energy to the source.
Well, let me explain it on the drawing here since I drew it out anyway. Okay, so right now you can see the battery charging a coil, right?
Yep.
With the switch, right?
Okay, I see the switch.
And I got the diode here blocking a positive from shorting out. This would be, which positive is that? That's this positive here. You see that?
Got it?
That's why that diode's there, right? Makes sense?
Okay.
You don't want to short the battery out to itself, do you?
No, hold on. I'm just looking at what you got.
Here's the plus from the battery.
Yeah.
It connects through here. Oh, let me explain something first. This is the plus from the battery hitting the coil. This is the minus from the battery hitting the coil. This is the minus of the flyback event when the coil drops its charge and flies back. And this is the plus flyback. Okay? That's why I do that there for better, easier to follow. So you got to have this diode here when you do the single battery thing, flyback. So because if you don't, the plus from your battery shorts out to the minus like so without the diode.
Okay.
When you switch it, correct?
All right.
Right?
Path of least resistance. Got it.
Just drain the battery like that. No good, right? So you put the diode there and you can switch now without draining your battery, right?
Okay.
Because the plus is not going to be able to go there anymore. Stops. Correct? But that's a high voltage diode, and it still will block the low voltage 12 volts, and that's why I'm using it. And I think it's done it before. I've seen it done. So it's also high voltage for the negative flow portion, which is required to, okay, so now the negative flyback, or the positive flyback is here, right? And it's going to go out the diode into the battery, right? And the negative flyback is going to go through the diode into the battery. I messed up here. I should have drew another channel going down this way.
Yeah,
Okay.
there's actually an easier way to do this.
You get that though, right? That's the channel I should have added. And the negative flyback can get to the battery, and you could still switch.
So know how you can do it a little bit easier so it's not so confusing wiring wise?
This system doesn't work, Mike, so it's not no point going on with it. This system doesn't work. I'll tell you why. Because the flyback shorts out to itself. You can see the black arrows that I already drew.
Yeah.
Now, this negative from the flyback. Now, forget about the battery charge. We're talking about the flyback polarity. That negative is going to touch through here, well, through the other channel that we created. Oh man, where did it go? Where is it? The positive flyback goes to this terminal, touches here,
Okay.
and this negative. Oh, there it is. Sorry. It's right here.
Okay.
See it? That's the negative flyback channel touching the positive terminal, and there's the positive flyback channel touching the same terminal, shorting itself out. Flyback, goodbye. Not going into battery. Thank you. Good night.
Okay.
This system doesn't work. This is why Bedini added the second battery, because the flyback shorts itself out.
There is a different way of doing it. The way I got around that without shorting it out.
That's all I wanted to say.
The flyback, when you take the flyback, all right, you dump it into a full wave bridge rectifier. The DC coming off the rectifier, you put it into a capacitor, okay? So now you've changed the symmetry because it's gone through a capacitor.
Yeah, but he also says
Hold
do
on.
it as fast as possible without a capacitor.
No, but the reason for it is you can still do it. When you put it into the capacitor, you're now changing it from electric charge state into an electrostatic state. Now, right there, the symmetry has been broken. Okay? So now the power coming off the capacitor now, I put it through another full wave bridge rectifier again, and then I can take that back and feed it right back into the same battery. And it doesn't short it out, and it does charge.
I would agree with that, yes. But I still think it would be better if you could keep the radiant going, like the what do you call that? The inductive reactance.
Repeat this process over and over and over. But what you really want to do is you want to go as fast as you can without a capacitor, for the simple fact is you want to put a lot of this radiant energy to the source.
that game with you. It's interesting. 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 Interesting.
A lot of this radiant energy to the source. For the simple fact is, you want
Do it. Do it.
Do it. Do it.
Do it.
Who's doing it? Do it. All of it.
Come on. Do it now.
Now we do the rest.
dependent upon marijuana that makes the unreal seem beautiful.
in that 1,000 years, when your vibrational resonance and the Phoenix frequency will have uplifted you, and you will know the malleability and flexibility of space-time, time.
desire, a warm-blooded beast with a beautiful smile. All through my body runs something exciting. 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 How something exciting. All through my body. Of desire, a warm-blooded beast with a beautiful smile. All through my body runs something exciting. 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 All through my body.
Hoje eu tô feliz, tô sem nada na cabeça, eu não vou sair daqui. Hoje eu tô feliz, tô sem nada na cabeça, eu não vou sair daqui até que amanheça. Eu não vou sair daqui, eu não vou sair daqui. Até que amanheça. Eu não vou sair daqui. Eu não vou sair daqui. Hoje eu tô feliz, tô sem nada na cabeça, eu não vou sair daqui até que amanheça. Hoje eu tô feliz, tô sem nada na cabeça, eu não vou sair daqui até que amanheça. Hoje eu tô feliz, tô sem nada na cabeça, eu não vou sair daqui.
dreams we have, the love we share. This is what we're waiting for. And in my mind, in my head, this is where we all came from. The dreams we have, the love we share. This is what we're waiting for. And in my mind, and in my mind, and in my mind, and in my This is where we all came
dreams we had, the love we shared. This is what we're. And in my mind, in my head, this is where we all came from. The dreams we had, the love we shared. This is what we're waiting for. And in my mind, in my head, this is where we all came from. The dreams we had, the love we shared. This is what we're.
sky.
You criticize, but all your bullets ricochet. You shoot me down, but I know I'm bulletproof, nothing to lose. Fire away, ricochet. You take your aim, fire away, fire away. Shoot me down, but I won't blow. I am titanium. Shoot me down, but I won't blow. I am
What's going on?
Ding, ding. Bam, bam. Ding, ding. Bam, bam.
Ding, ding. Ding, ding. Bam, bam. 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 Ding, ding. Bam, bam.
All you people in the house, get up and scream and shout. Say hey, 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 all you people in the house. Say hey, hey, hey. All you people in the house. Say hey, hey, hey. All you people in the house. Hey, hey, hey. Say hey, hey, hey.
Pink Panther is simplicity and identification. simplicity and identification. You want me. You want me. The Pink Panther is simplicity and identification. Pink Panther is simplicity and identification.
도착할 수가 있어서 널 위해 사랑을 나는 아파도 도착할 수가 있어서 사랑이 사랑을 더 완벽하게 널 원하는 점들은 다 숨겨지게 이루어지지 않는 꿈 속에서 피할 수 없는 지켜볼 수 없는 I'm sick of this freaking love freaking love freaking love
사랑한 가슴도 기쁜 척할 수가 있었어. 사랑한 가슴도 기쁜 척할 수가 있었어.
Una mattina mi sono alzato e ho entrato lì in basso.
E le genti che passeranno, oh bella ciao, bella ciao, bella ciao, 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 delle genti che passeranno, mi diranno che...
Una mattina mi sono alzato, bella ciao, bella ciao, bella ciao, ciao, ciao. Una mattina mi sono alzato e ho trovato un vaso.
Again, you see,
Ciao, 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 una mattina mi sono alzato e ho trovato l'invaso. Una mattina mi sono alzato, oh bella ciao, bella ciao, bella ciao, ciao. Una mattina mi sono alzato e ho trovato l'invaso. Una mattina mi sono alzato, oh bella ciao, bella ciao, bella ciao, ciao, ciao. Una mattina
Testing 1, 2. So, you talk a little bit about the what I mean by double source, double pole, double throw. In a double pole, double throw relay, I don't know if I'm audio. Can you guys hear me good? Okay. Can you hear me? Where is it? Testing 1, 2. Oh. So can you hear me though? Yeah. All right.
Ciao, ciao, una
was going to talk a little bit about. Gotcha, Anthony. I'm going to talk a little bit about it anyway until you get here. So, this switching circuit requires a double pole throw relay this circuit requires a double pole relay. You need to switch both poles of the source to the coil. The problem is each source, there's two sources, okay? And when you buy a double pole, double throw relay, it only has two terminals for one source battery, plus and minus. So that doesn't work for this circuit because I cannot connect these two batteries together on the same terminal. Otherwise, it defeats the purpose of the circuit, and the purpose of the circuit is to avoid any shorts of the load coils to anything else other than the battery that's supposed to load it, as well as avoiding dead shorting the flyback within the circuitry. Now that angle is covered by the extra 3 poles that are being switched compared to a single pole being switched in the Bedini SG, where he switches the negative of the battery source to the coil, and the positive of the coil is hooked up to the battery's positive permanently. That's called single pole switching. If you wanted to double pole switch a single coil into a single battery, that can be done with double pole switching. If you did it with single pole switching, you're going to short out the flyback to itself within the wiring of the circuit. Remember, current takes the path of least resistance. So I'll continue with this in a little bit.
Parece em ascensão, afoguem aqueles que se opõem a mim. Em frente, maré destruidora!
While we wait for Anthony, I'll play one quick video to explain why single pole switching with a single battery does not work. Now, that's why Bedini had 2 batteries, but I'm going to show a video here that explains why single pole switching will short out the flyback. And cancel the flyback, and it will never hit the single battery in the single battery flyback system. Where is that? Here it is.
Repeat this process over and over and over. But what radiant energy to you want to repeat this process over and over and over. But what you really want to do is you want to go as fast as you can without a capacitor, for the simple fact is you want to put a lot of this radiant energy to the source.
Well, let me explain it on the drawing here since I drew it out anyway. Okay, so Right now, you can see the battery charging a coil, right?
Yep.
With the switch, right?
Okay, see the switch?
And I got the diode here blocking a positive from shorting out. This would be, which positive is that? That's this positive here. You see that?
Got it?
That's why that diode's there, right? Makes sense?
Okay.
You don't want to short the battery out to itself, do you?
No, hold on. I'm just looking at what you got.
Here's the plus from the battery.
Yeah.
It connects through here. Oh, let me explain something first. This is the plus from the battery hitting the coil. This is the minus from the battery hitting the coil. This is the minus of the flyback event when the coil drops its charge and flies back. And this is the plus flyback. Okay? That's why I do that there for better, easier to follow. So you got to have this diode here when you do the single battery thing, flyback. So because if you don't, the plus from your battery shorts out to the minus like so without the diode.
Okay.
When you switch it, correct?
All right. Path of least resistance. Got it.
Just drain the battery like that. No good, right? So you put the diode there and you can switch now without draining your battery, right?
Okay.
Because the plus is not going to be able to go there anymore. Stops. Correct? But that's a high voltage diode, and it still will block the low voltage 12 volts, and that's why I'm using it. And I think it's done it before. I've seen it done. So it's also high voltage for the negative flow portion, which is required to, okay, so now the negative flyback, or the positive flyback is here, right? And it's going to go out the diode into the battery, right? And the negative flyback is going to go through the diode into the battery. I messed up here. I should have drew another channel going down this way.
Yeah,
okay?
There's actually an easier way to do this.
You get that though, right? That's the channel I should have added. And the negative flyback can get to the battery, and you could still switch.
So know how you can do it a little bit easier so it's not so confusing wiring-wise?
This system doesn't work, Mike, so it's no point going on with it. This system doesn't work. I'll tell you why. Because the flyback shorts out to itself. You can see the black arrows that I already drew.
Yeah.
Now, this negative from the flyback. Now, forget about the battery charge. We're talking about the flyback polarity. That negative is going to touch through here, well, through the other channel that we created. Oh man, where did it go? Where is it? The positive flyback goes to this terminal, touches here.
Okay.
And this negative, oh, there it is, sorry. It's right here.
Okay.
See it? That's the negative flyback channel, touching the positive terminal. And there's the positive flyback channel, touching the same terminal, shorting itself out. Flyback, goodbye. Not going into battery. Thank you, good night.
Okay.
This system doesn't work. This is why, Bedini, I added the second battery. Because the flyback shorts itself out.
There is a different way of doing it. The way I got around that without shorting it out.
That's all I wanted to say.
The flyback, when you take the flyback, all right, you dump it into a full weight bridge rectifier. The DC coming off the rectifier, you put it into a capacitor. Okay. So now you've changed.
So, and there you can see how the flyback shorts out to itself on a single battery flyback system when you only switch one pole of the source to that coil.
symmetry because of
voltage for the, and here you can see the negative is being switched, only the negative. But if you add a switch to the positive terminal there, then you're double pole switching now. And you disconnect the positive terminal, which is the location where the positive and the flyback and the positive and the negative of the flyback meet. They meet there on the positive terminal of that battery. But if you switch that positive terminal when the flyback happens and you open up the gate so it's not connected to the circuit anymore, and you only have the diode. Let's see what the diode is on the same channel there. Right, and then you would disconnect where the diode is, the positive flyback diode is pointing towards the plus of the 12-volt battery. You would put the switch above there and run another channel to the positive to capture the channel. Well, you would do it the way it's seen here in this circuit instead. So yeah, that other circuit's not quite accurate. I drew that up on the fly just to explain an issue with a single battery system. If we go back to here with this circuit, you can see how when the flyback happens, it's isolated from shorting itself out in any way or shape or form. There is, other than shorting itself out to the source battery. It doesn't short itself out to the circuitry anywhere. It's tricky, but it's there.
Liberty Ukraine! Enfrente, maré destruidora! Qual o problema? Não consegue ficar de cabeça para água?
Hey, what's going on? Are you there, or are we stuck in the video? Uh-oh.
Just plugging my camera in here. Yes. Okay.
Repeat this process over and over and over. But what you really want to do is you want to go as fast as you can without a capacitor, for the simple fact is you want to put a lot of this radiant energy to the source.
Well, let me explain it on the drawing here since I drew it out anyway. Okay, so right now you can see the battery charging a coil, right?
Yep.
Right, I gotta load that up. That is, let's see here. Right. I'm bringing up a something real quick. Share screen application window. There it is. Can you see my thing moving around? You can see that, all that? You there, Anthony?
Yeah.
I
It
hear
looks
you.
like YouTube's on a delay, though, I guess. Or maybe it's just me. Okay. There we go. I think.
So, in this image, there was a small error in the circuit, right?
Okay, there we go. Yeah, I hit the wrong button.
Let me change this. I got
Okay,
added
I think I got it straightened out.
to the coil. And then give me a second to think about this. I made an error drawing this the other day, but nonetheless, it still shows how the flyback shorts out to itself with without the extra switch. And when you single pole switch, it ends up doing that.
If you could really get some really fast MOSFETs, that would work even better.
Yeah. So let me delete this here. Oh, wait a minute. Keep that there.
There was some guy's name with the toroidal motor. I can't think of his name, but well, the only one that I know that's ever made a toroidal motor that he talks about. He was recapturing the flyback. He said it wasn't until recently that he could get it fast enough without constantly blowing transistors.
Because he's not switching like this. Okay.
Well, the back EMF's pretty strong too. Like where I said that transformer.
Yeah, but when I switch like this, the back EMF is disconnected from the circuit entirely, and it's only touching the battery. That's why you switch like this.
Oh, it'll jump that contact.
No. There's nothing to jump. The circuit disconnects from the battery. And only thing that's left connected to the battery is the coil flying back into it.
Right. That's what I'm saying. You have to be careful because the back EMF will jump that contact.
Into where? It's only connected to the battery. Where is it going to jump?
Right.
It's not connected to the circuit anymore.
But how
All
is it
you have
connected? How is it connected to the battery though? Through the relay, right? The relay
It's
switching on and
connected
off.
to the circuit and the
That's
battery
only
through the relay.
maybe that's only maybe a 1/16 of an inch.
Oh, I
If
see
that,
what you're
if that
saying,
diode
but
stops working,
yeah,
it'll cut that contact. No problem.
I see what you're saying, but
I mean,
I'm not
as long
even there yet.
as the diode's working, you should be okay. But it depends on how fast it is too, because when it initially, it's like a lightning strike. It's like nothing, and then all of a sudden, just unbelievably strong,
Well,
and then back to nothing.
Well, the thing is, yes, but you're right. So, yes, it can jump the gap of the switch and all that, but if it has a load to go to instead, that's less resistance than an air gap, is it not?
I would definitely go with Schottky diodes.
You know what I'm saying, though,
You
right?
know,
An
the
air
regular
gap
diodes are like 1 or
compared
2
to a
cents.
battery
The
load,
Schottkys are like
that's
3 cents. So nothing that really matters unless you're going to make thousands of them.
So,
And,
do you
it'll be
understand
way
this
more
at all?
efficient
What you
that
see
way.
here? Does this make any sense to you?
Yeah.
So, with the single switch, it would short out before. Right now, this is the negative flyback. This is the positive flyback. This is the positive charging the coil from the battery, and that's the negative from the battery charging the coil when the two switches close, right? So when they're closed, they are charging the coil.
You can eliminate one of those.
No, you cannot.
Yeah.
Because then the flyback shorts out to itself within the circuit, within a piece of wire in the circuit.
Well, the negative pulse when you drop power is where the vast majority of the energy is. The positive pulse will go back to the power supply where it originally is without a diode.
I'm not familiar with what you're referring to there, but
okay, if you just let's just say nothing's switched, both those diodes are gone, and you turn off power to the coil, it's going to instantly reverse the polarity of the coil.
Right. I see what you're saying, and go into the battery anyway. Yeah.
Right.
You're right, but you need the diodes for other reasons. They're there for other reasons.
Right. But I'm saying that's it. You don't need the positive.
Here's one reason.
It's already
Here's the one reason you need the diodes. Here's the one reason you need the diode.
Oh, you definitely need the back EMF diode. I'm saying you don't need the positive.
No, forget about
that.
This is not a back EMF reason. This is not a back EMF reason that you need the diode. These are back EMF diodes, but I'm using it for both back EMF, and I'm using them for low voltage blocking. And you can see I just drew the path of the blocking of the low voltage. You need that diode there, or you're going to drain your battery like so. Okay, when the switch closes, it's not going to charge the coil. It's going to just drain the battery without the diode. Without that diode, you close that switch on the right, the one on the bottom right on the negative terminal, assuming the other switch is closed also and the coil's trying to charge, it will not charge. It will, without the diode, it will just drain the battery. Let's delete the diode.
Yeah, I'm trying to follow the circuit here.
I'm deleting the diode. I can undo all this. It's a photo editor. So watch this. I deleted the diode, and you're going to see. Hold on.
Oh, okay. I finally see it now. Yeah, I didn't. The way that's crossing, I didn't follow it first.
Okay, what happens when you close the switch now without the diode?
Yeah, if you didn't have, it looks like you're just shorting the coil out.
No, you're not even getting to the coil because the current has a path of least resistance, and it's right here. I'll draw it. When the switch closes, the current does not go through the coil. It goes this way, the path of least resistance. No coil.
Yeah, but keep following
it
up.
No coil, piece of wire.
Yeah, keep following
it up. A lot less
up.
resistance, right?
Yeah, keep following it up, though. You're also shorting the coil at the same time.
Yeah, I saw that too in another circuit, right? The same circuit, but yeah.
Yeah, right across there. Yeah. I missed that the
Shorting
first time.
it to what? To not the negative.
Yeah, but it's the same voltage, so really all you would
It
have
hits
is
the negative the
the
wrong
reverse
way.
diode, so the coil would be off.
It hits the negative. It does. It keeps going this way when the switch is closed. And no, it never hits the negative. Sorry.
Yeah.
It never hits the negative. It doesn't go to the negative. Never gets there.
That's why it's so much easier with 2 batteries, 2 circuits.
Well, that's why Bedini added the second battery. That's why he added the second battery, because without it, you'd be shorting out. But he didn't know that you can add a diode and double pole throw a single battery. Now, this you can do. What you see here, yes, you can do this. There will be no shorting out. Oh, I got to go back. Not this, but this you can do.
Oh, I don't know if you know this, but the reed switches he used in there, they're okay.
Well, these switches move together. They don't move separately. They move together.
But when they switch with magnets, they can switch kind of slow. So
it doesn't matter how fast or slow you switch it. This is just a concept model. This is
you're
not
dealing
any
with the back
finite
EMF, so
thing.
your
You can
switching
switch
time
any
really
RPM
matters.
you want.
Yeah.
You could use any coil impedance you want. There's
Yeah,
no.
no, I was just telling you in general, because with the back EMF, the switching time is extremely important. Just
right,
turning
I
the
agree with
circuit on
that.
and off
I'm
slow
not at that
is
stage
fine,
yet. I haven't
but
even
if you're
built
trying to
this
catch the back
yet.
EMF, then you need a high speed.
Right, I agree. That's why if you're going to go with a high speed frequency and you don't want to draw a lot of current, you keep your duty cycle as low as possible and you raise the impedance on your coil as a current limiter. Use the coil. Don't use a resistor. Screw that.
I would go with a higher voltage circuit and Schottky diodes.
But when you
that the resistance, the higher the voltage you go, the less the resistance matters.
Well, yes, because with the higher resistance you go, the more voltage you got to give it, but you could still limit the current at the same time.
Yeah, oh yeah.
So you can, I guess, the more resistance your coil has, and the more higher voltage you can give it, the more range you have of tuning your oscillation or your pulse. It's not an oscillation now. I used to think it was. AC oscillates. Oscillations don't have an off cycle. Let's clear that up for the community that wants to debate that. Feel free to get with me anytime on that. I'm pretty sure I'm right that oscillations do not have an off portion. They have a negative portion, but it's not an off portion. It's a negative signal. It's got
that's what the zero crossing is called.
Yeah, the negative below the zero line.
Yeah, the coil will do that a few times too. But since you already have it connected to the power supply.
Right, so you could do a single battery flyback without shorting out the flyback to itself by adding a second switch and a second diode, like so. Because that diode, let me continue a little bit here with this diode. This one, it blocks not only the low voltage 12 volts from the battery, like, when you close the switch, you don't want it to go there. By the way, there's supposed to be a channel here that I didn't put in there. I'll explain that now. That is because when the flyback happens, this negative here is, sorry, wrong one. This negative flyback signal is that's the negative flyback. It goes through the diode. And the switch will be open, so it can't go that way. They have to go this way, right? So you need that second channel there, like that. That's the only thing I didn't put in there. But yeah, this is where this is the way to do the single battery flyback thing. And
you gotta put that in multi-sim or something like that. One of those simulator circuits. They have.
I'm simulating it all day long, in my head.
Yeah.
It's done. I've even built it, and it didn't cause me any shorts. I built this. That was the last video I made with the Newman type motor. This is the circuit I used. I had it running like this, and then I added capacitors later, but it was running without the capacitors. I added the capacitors and changed the didn't change any of the circuitry. Just added a capacitor to a timing circuit to separate the battery for a portion of time and allow the capacitor bank to run the flyback signal, and the battery would be isolated while the capacitor was generating flyback. The battery would receive the flyback on its own. I did that also with the same Newman motor, but before I did it like that with the capacitors added, I had it running with just the one battery with these diodes, and it didn't create any shorts that I know of. I mean, I could have been shorting out the flyback, but from what I remember, the efficiency, wasn't having any problems getting the motor starting in both modes, so I don't think I was shorting out the flyback. But
hey, have you seen the Magnetic Motor Secrets video
with Peter Linderman?
Yeah, that's the guy. I couldn't think of his name.
Yeah, it's very good video to watch. Teaches you a lot about the fundamentals of all this stuff. Yeah, motors.
I know they've got
generators, stators, all that stuff.
At least most of the what's it called? Man, I can't think today. The free energy or energy from the vacuum series. That's it. Energy from the vacuum. That's on Rumble now.
Yeah. It's on Rumble.
Yeah, I'd say download it while you got a chance.
Yeah, I have a Rumble account, but I rarely use it. It's not so active.
Yeah, I don't know a whole lot either.
Also made an error to the commutator, which
repeat this process,
which was for the same system here. Let me bring it up.
Here's one of the pages.
In this image here, you can take a look at it. Do you see any shorts out now? Right now, the battery is charging the coil. Do you see any shorts happening between the one battery on the right and the battery on the left? Do you see any problems going on there? Any issues? Other than the battery on the right, in a weird way.
Fine, I'll put on my glasses.
Sending a positive to the battery on the left through the coil it's charging. I don't know if you see that.
I can see it, but just a couple of places, it looks like he had a circuit that something was removed where it goes like this.
Do you see the battery on the right?
Crossing the other places, but right in the middle there.
Oh no, don't worry. That's an image error. I didn't put the line, finish the line there, but that's connected. The reason that's there is I was fading out two images from each other.
If you build that circuit and all those switches are closed, it's going to explode that.
Yeah, no crap. That's why they don't switch. They don't all close.
Oh, okay.
They never all close. They're not supposed to.
Okay.
I see that.
Whole difference.
Good observation. See how they're all open right now?
Right. Okay.
Watch only one side.
So either the right or the left set, then, right?
Right, at a time.
Okay.
Never all at once. Because then it just starts glasses. Yeah, I didn't realize this for a while, but it was bugging my head. It was like an idea that I knew would work, but I couldn't lock down what I was thinking. I had built a double pole, double throw. I bought a double pole, double throw relay to build a homemade mixing stirrer thing for making, chemical water solutions from like colloidal water or whatever.
Right.
And you need a mixer, and I didn't want to buy one, so I took an old DC fan, and I wanted to turn it one way for a little bit and turn it the other way for a little bit to avoid any buildup on the probes, on the leads.
I was wanting to do the same thing. I made some too.
and that required a double pole, double throw relay on a timer. And it was after I did that, I started messing with the Bedini circuit, and in the middle of realizing what the flyback, how he was channeling the flyback, it just flashed in my head the double pole, double throw concept for some reason. It just bing. It's like for some reason that had the answer, but it didn't. It had half the answer because a double pole, double throw relay only throws one source power. You need to throw two source powers, not one. So you need a double source, double pole, double throw.
Well, the contacts are reversible. You know, you can take.
Yeah, but they don't sell you a relay that you can connect two individual source powers to it. And again, you need two.
Yeah, it works either way.
You need not.
You
don't need one.
Separated from the coil, it makes no difference which way you connect it.
But you don't need one pair of relays going left and right connecting two pairs of contacts.
Yeah, but I mean, let's say you had double pole fourth row.
They don't exist.
Yeah, they do.
Well,
I'll give you an example of one that's double pole 10th row. Remember the old telephones? Stick your finger in, turn it, it'd go click, 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 click.
Oh yeah.
Click, 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 click. Yeah, double pole 10th row.
10th row.
Yeah.
Nice.
One digit, and then the operator
throws 10 relays.
Hmm? Yeah, you can actually see old videos of them when you dial. You see that the phone thing going chick, chick.
Oh
chick,
wait,
chick,
you're saying you could
resets,
double pole,
and it goes
double
chick,
throw.
chick, 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 for each digit that they dial.
That old phone can double pole, double throw either 10 contacts or 9 or 8 or 7 or 6 or 5 or 3 or 2 or 1.
It's whatever.
Is that what you're telling me?
Yeah, I mean of course the telephone company had their own made, I'm sure, because it's that's not a common thing to have 10 loads. But
you see, that was just specially designed for that phone, though. They didn't make it for anything else.
Yeah, I'm sure it was. It's like I've got some that are like it's double pole 5 pole double throw.
Okay, I need.
I don't know what they came with, but it was
but I need
like
two sources. I need to throw two different sources and keep them isolated. That's the tricky part.
I wish I had my relay box in front of me. I could show you. But it's like you look there, and it's like instead of the regular 2 coils and then the the 6 coils for the contacts, it's like 2 coils, and then you've got like 40 contacts in there.
And that's from the phone device.
No, this one I'm not sure what it's from. It's
from
something industrial. I'm guessing, but yeah, I don't know where it came from. I just seen it.
Yeah, but most of those relays are getting their power from one source.
Yeah, the contacts are, but you can switch a lot of things. So especially like industrial, let's say you want to turn on one motor here, one pump there, maybe a signal light, and you want to keep the circuit separate. So you would have each contact separate. One might be the 120 volt circuit for the motor, the other might be the 24 volt circuit for just lighting the lamp to say this is working. If you ever look at industrial stuff with ladder logic, they can get really complicated sometimes.
I've heard of that ladder logic. Is that what that is?
Ladder logic is another. Well, now it's done by a ladder logic controller. There'll be a box about like that big. That's basically it's just done on a computer, a little microprocessor. But it used to be, it was all relays. And some had like timer relays in them. So let's say you'd press a switch, it would count to 3 or count to whatever number you wanted, and then it would engage, or that's how it did its cycle timing and everything. Oh, look at a refrigerator. That's a lot of them are drawn with ladder logic symbols still.
Oh, right, because they got all those things they got to switch in there, but they all draw the power for all those things that they're switching from one source.
Yep. Relay for the compressor, one for the defrost coil, one for the little inside light.
Right, but they're all that stuff, all that power they're switching is coming from one battery.
Yeah,
or one power source.
AC in this case, yeah. Well,
They all do
power
that.
supplies, but yeah, so some places, it'll give you like a 12 volt or 24 volt line, and then the rest is like 120 volts. If you want to hear something dumb, I got another refrigerator, and it's got this little ice thing on the front door, and I was having problems. Turned out to be a bad ground, but because I was getting shocked. But turns out I finally got in the door, and I thought, okay, that has to be it, the door. Turns out they're sending 120 volts to light an LED in the door instead of just like a regular 24 volts. It's like, that was stupid. But when they could have used like 12 volts or 24 volts, but just goes to show you that they're not always the smartest people who make some of these things or the most safe, especially on something that's going to be dispensing water. You don't really want 120 volts in that, anywhere near it. There's supposed to be safety regulations on this. So, you want to keep water the hell away from any circuit, any voltage if possible. But one of those things.
I'm trying to find this one video.
My cable company was screwing me. I guess my ground isn't good enough because somewhere where they disconnected it, and then my cable company is sending me 75 volts AC on the coax, which is connected to my house ground. So made my whole house ground at 75 volts. And I was wondering why I was getting shocked. It's like, oh, thanks a lot.
Look at this one. Oh, okay. Here you have the same thing that we were just looking at over here.
Oh, by the way, that works for switches or relays. The double pull, double throw, same exact wording, I guess you'd say. The abbreviations.
You see this one? You see the diodes? And yeah, it totally prevents any shorting. This is the same circuit, but it's connected to the relay. Yeah, it's the same circuit. But yeah, it's the same circuit, but showing the relay circuit for you instead of this image, which is
it's a little easier to follow.
Yeah, this is the same circuit, imagining the relays doing the switching there,
I like doing the same thing on my circuits, blowing up as much as possible.
Because of the diodes, the extra 2 diodes, you can do this with one.
I even got a special printer for that. If you ever get like that, print out schematics, get one of those 11 by 17 printers and print things out instead. Makes things a whole lot easier.
Yeah, you mean the laser, the 3D printer?
Yeah.
I'm heading there. I'm not.
Yeah,
I'm gonna get that. It's
like
to make the relay.
Pounds. Got it in my Grand Am somehow.
I'm gonna get a printer just to make this relay.
Yeah.
Which relay? Let me show you.
They've got some of the desk jets that are like that too. But I prefer lasers, but whatever you can get.
I'm gonna do some research before I buy anything big time, because I might even wait a little bit because they're improving the technology. Where is it?
Yeah, I'd like to see that with a circuit that's not just switched like that. I'd like to see one where you can vary the timing.
Vary the timing?
Mm-hmm.
That's done with the double throw relay. You hook a PWM up to it, and you switch the 12 volts to it with the PWM.
Well, yeah, but I'm talking about much better than that.
Look at this guy. This is
the
also the same thing.
Relays are great for isolation, but they're not good as far as every time that switch closes, it's doing this, like that.
Which switch are you talking about?
Every mechanical switch. That's called contact bounce.
Oh, you think so?
Yeah,
well, this won't do that. Because this
the
is
switch
not,
on your wall.
This switch won't do that.
Relays.
This is different. This will not do that because you have iron cores on 2 sides, preventing that. I know what you're talking about.
That's a relay at will or a reed switch.
A reed switch will, because it doesn't have an iron core on two sides, eliminating that from happening.
Now, the iron core doesn't stop that.
Well, it does if you have it on two sides. It brings the switch back from doing that.
No, that thing in the center will move. Okay, but when you look at it, Dave on EE blog did a great demonstration. Check him out.
I think you should explain what you're seeing here to me.
Well, just mechanically, okay. Any
What do you
time
see
you
here?
hit, okay, just say two objects come together. They don't just come together perfectly. They all have elasticity and hardness. You know, they actually bounce. You know, if you got soft object, let's say both are jelly, they might do this and then bounce like that where you can see them. If you got two hard objects, say they're both like diamond.
Yeah, but you got a magnet.
It might go pretty quick, but you could even hear it go like zzz, zzz, zzz. Not from the electricity, but from the vibration.
Right.
And
that's the vibration of the material.
Switch bounces.
Right, but Anthony, there's nothing vibrating here. The magnet is floating in air. It never touches the core.
No, the magnet is, but the contacts, the electrical contacts.
No, I don't plan on making these contacts touch very much surface. They're going to be like right on the edge, like brushing by without even brushing, but close enough to.
Yeah, it's still going to do it, but.
They're going to be real close, but not touching. But touching, but real close. You know, not touching too much.
Capacitors across the contact to stop the arcing too, because where it does that, and the touching, like you say, what you're going to end up doing is you're going to end up wearing your contacts down.
The arcing is going to get channeled through the high voltage diodes back to the other battery.
Yeah, but it's still going through the circuit. It's still part of the circuit.
It's going to go through the contacts.
Mm-hmm. And each time it
is
does
that what you mean by the circuit?
Eat at the contact a little bit.
You think so?
If you keep the lower you keep the current, the less it will do it, but it will do it.
Well, you don't see the wiring here, but there's extra wiring that's not. Let me see this.
Yeah, it all. I mean,
okay, you don't see any diodes here, do you? Well, that's because
the diodes don't matter in this case. It's
well, the diodes isolate.
Well, this is just a mechanical thing.
Right, but the flyback will go through this coil into the other coil, which has the diode, and from there into this battery. Mm-hmm. That's what the part of the circuit you're not seeing here. That's why you're assuming the flyback's going to go through the contacts. But
no, I'm saying I'm just saying when it's switched. Now, what you could do with that, which
you see here, this is the other circuit. This is a circuit that you tie to that relay. This is you tie that relay to this circuit.
Okay, well, check this out. This is what I was saying to vary the timing.
Those four poles being switched on that relay are the same four poles you see here on top of the two batteries. The same four switches. That's all it is. So once that's connected, you have this circuit involved with it to handle the flyback from going through the relay, instead going to the battery. It's not going to go to the relay. The relay is only there to charge the coil, and then the relay disconnects when the flyback happens. And when it disconnects, the flyback happens through the diode into the battery, not through the relay, not through the terminals of the relay. Nope.
Right. Your disconnect isn't going to, well.
No.
Actually, your disconnect will cause you a problem too, but.
No, going back to the relay. Go back to the relay now. Watch it disconnect. Look at the relay, and it disconnects here. Watch.
Right. Every time you disconnect is when you're going to get the back EMF.
There. You're disconnected, right?
Right.
Right there. Now you take the 4 out poles, the 4 out ports, the 4 out terminals on the right there, and you.
Okay, now
look at it here now.
At that instance, you just disconnected. You may have 10,000.
Right, I disconnected the source. I disconnected the source from the coil. Now the coil flies back, but not through the relay terminals. It flies back through the coil into the battery through other sets of wires, which is the circuit tree and the diode.
Do you have an oscilloscope?
Yeah. Not on me. It's in another.
No, but I mean, watch that circuit when it disconnects. And put it.
Oh, it's going to fly back every time you disconnect the
right.
battery from the coil. It's supposed to fly
right.
back.
But I'm just saying, before you start it, don't put it on the 5-volt range. Put it on the highest range you have, probably like 40 volts a division, 50 volts a division. Put it on there and see how much is actually making it to the coil, and how much is involved in arcing. How high a voltage is that's building up before it starts transferring.
I get you. You mean check out the voltage drop, right?
Mm-hmm. Well, that's
say that again.
Well, see,
check out the voltage drop with a high division setting so that I can see.
Well, you want it on the highest voltage.
Let's say I'm giving it 12. Let's say I give it 12 the coil, and I see a drop. I see 9 volts or something. What do you? So I'm dropping 3 volts.
That's at your operating voltage, but as soon as you disconnect, you might get a few thousand volts or more.
Disconnect by opening the gates, you mean?
By turning off the coil.
By disconnecting the coil.
Anytime you turn off that coil, you're going to get a back EMF pulse.
Right, and when that happens, you can see it's directly connected to the battery. There's no waiting. There's no switching that. It's already connected. You don't need to switch the back EMF channels. They're already hardwired to the other battery. Hardwired permanently. I'm trying to get through to you here. I see your concerns, and I'm getting them.
I see what you're saying there, but there's
no way for the flyback to go through air. The battery gets disconnected from the circuit.
No, I see what you're saying there, but there's a turn on time too.
The one battery that charged the coil gets disconnected.
But here's the one part you're missing though. The diodes aren't instantaneous.
You can use whatever diodes you want there. I mean,
no, you can't.
You got to use the diodes.
You're actually using a really bad diode for that application.
It's a concept model. You could use any diode you want.
Well, you're wanting this to work in the real world, though.
I would say Schottky diode is probably better. I'm just going with what Bedini chose for his.
Yeah. The Schottky is much better.
I agree. It's higher frequency.
To give you an idea of the difference,
you're saying high frequency Schottky because the flyback is such a high frequency. That's why, huh? Because it's a super fast event. It's not because you're running at a higher frequency, but because let's say you're pulsing at 5 RPMs. Well, the flyback is moving at a much higher frequency. So using anything other than a high frequency diode, you're probably not going to get the most out of that flyback. I get you. It's a super high voltage,
I just pulled up the
high speed or whatever transfer. Mm-hmm.
I'll pass this on so you can see it too, if I can get here. I'm pulling up the page to look for the.
Oh, I see. There's
a turn on time. Okay.
What you got here?
Let's see. Where's turn on time?
Is this video from the? Oh, is it copyrighted or something?
That's just a data sheet from Vishay.
It's 1 hour and 20 minutes. Energy from the vacuum in Series 23.
Oh no, that's that's the other.
Will I get a strike if I play it?
Oh, the energy from the vacuum series.
Will I get a strike if I play it? I don't know.
You might,
because Lieutenant Colonel's Thomas.
Because
the
follow
Beard in here.
Europeans Bill did it, and they took out all of his videos like that, so they probably will. That's the reason I put it in private chat and not the public chat too.
Oh, gotcha.
Because they might not like putting the link in there even.
What's that other link?
Yeah, YouTube's a real pain at times. Let's see, where's the? I don't see the time on here. That's unusual. Oh, see, usually when you talk about the,
is that
like a regular 1N4001 series, you're usually talking about 60 hertz AC, not for like high speed blocking.
Right.
Yeah, this data sheet didn't even either it didn't show it or I missed it.
Hold on, I'll bring it up. Oh, you can present it, can't you? You can't present it?
See if I can find it here first, but
I see the link you sent here.
No, it wasn't listed on this one. Figures.
Where did it go? There it is.
Oh, okay. Well, I didn't find it from the data sheet, but I found it from the
is this what you're talking
AI
about?
answering. It says typical turn-on times 2 microseconds, or typical reverse recovery time is 2 microseconds.
You're looking at the 4001 series diodes here?
Yeah, yeah. Now, a Schottky will be maybe 30 to 50 nanoseconds, not microseconds. So we're talking, close to 1,000 times faster.
Right, and that's more suited for the capturing the flyback frequency.
Right. And that that time it takes to turn on makes a big difference, because this is all of a sudden a really fast pulse. And also the breakdown voltage makes a big difference too, because the 1N4001 series will have a 0.7 volt voltage drop, whereas a Schottky will be about 0.35. So it's more efficient that way too.
Right, less of a voltage drop. I heard about that. Germanium too, right?
Germanium's lower, but they're slower. Well, they can be faster, but germanium's not usually high current. They're like, you'll find them in like old radio receivers, that kind of thing. But I actually have an old battery charger that had some in it, and I was looking at it, and I was like, holy crap, I didn't think this thing was that old. It just like pressed discs together. But
was that germanium, you said?
It works great. What's that?
You were talking about germanium just now? Diodes?
Yeah. Well, back before they had the silicon ones that were popular, they used them, but they could have been better, put it that way. They worked, but the silicon ones were much more reliable.
Which one? D04 to 001. Yeah, this is low voltage, 50 volts, 100 volts, 200 volts, 400 volts. It depends on which one is it. These things are so confusing to read, these charts, but this is the chart for all of these diodes.
If you go, oh, okay. Found a Mouser. Okay, here we go. Mouser, they should show that.
Oh, there you go. See, the 1N4001 is 50 volts.
Right. Yeah, each time you go up the number, the voltage.
And then the 4002 is 1,000. So then how do I get to the right there?
Yeah, 1, 2, 4, 600, 800, 4007 is 1,000 volts.
So there's the 1,000 volter. I've never seen a flyback more than 900 volts. And the standard Pedini coil.
Oh, this is way over 900 volts.
You mean the Schottky?
The Flyback.
Well, it depends on the coil you make. I've never made a coil that would do that. Do more than 900 volts is what I'm saying. None of my coils did anyway. I'm sure
you probably did, but
you
didn't
a lot
know it.
more turns and give it more voltage. And
If you just take a little reed relay and just make a series circuit out of it so it vibrates, you're getting a couple thousand across that easy.
A reed
doesn't seem like it, but it's
well, that's a manual.
You can see the little
I was using a transistor, not a relay, to do.
Oh, okay. Well, that makes a big difference.
Yeah, I never measured anything with the oscilloscope with any standard relays on the flyback regards yet, but I do believe you're right on that. The relays, a real relay contact should produce a higher.
You can always just go low check.
Even with the same
every
coil.
tenth of an inch is about 1,000 volts.
Every what?
Every tenth of an inch, it's 1,000 volts.
A tenth of an inch of copper?
Of space. So let's say you have two contacts 1 inch apart.
Oh, air
That's
gap, you
10,000
mean?
volts.
Yeah, it can withstand 1,000 volts, right?
Yeah. So if you have like 5 inches apart, that's 50,000 volts. So that'll take to jump that.
50,000 volts can jump 5 inches.
I guess humidity doesn't affect it as much as I thought it would. It's actually fairly accurate.
Oh, really? Even the humidity?
It makes static harder to build up, but the gap, I guess, is still fairly accurate within a few percent.
And so in a humid environment, 50,000 volts still has to jump 5 inches. I didn't think that would be the case.
Yeah, I didn't either. It's harder to build up, but but once you have it,
it sounds like the water has no factor in the.
Yeah, I think it's something
not the water in the air anyway. There's no electrolytes in the air.
Right.
No
I think it's something like 3 or 5% accuracy, something like that. It was way better than I thought it was. But I mean, what it
the
was.
Water in the air is technically distilled water, right? It's got no minerals, no conductivity. The humidity, the H2O in the air, it's got no salt or sodium or to conduct anything. So adding humidity is not going to increase conductivity in the air gap unless that humidity has sodium added to it.
Yeah, when I look it up, it says it's accurate to about 3%. At least that's what the AI says. And that's what it's saying in the wiki, too.
I'm trying to find this other. Well, I know where it's at.
All these people that say, it's the tires that stop the lightning from hitting the ground in a car. It's like, no, I just made it from one end of the sky to the other, but you think those last 6 inches is going to stop it? It's like, no, not a chance.
That's true. I never thought of it like that. But I like, just for our own comfort levels, we keep thinking of it like that's not the case.
Yeah.
But yeah.
It's that metal that gives it an easier path that you're sitting in.
Might as well get close to a tree when you're in the car, huh?
Yeah, I know. One of those things that I always, I seen some of these demonstrations that with really high voltage circuits, and they put in a Faraday cage like that, but some of them have openings that are about like this big. And
check this out.
If you've ever seen it, there's like even pictures of like, here's the Empire State Building, and here's a lightning bolt that comes along and like that and hits the ground. Doesn't touch the Empire State Building. It's like sometimes it just does what it wants. So you might actually have a cage there and it might actually go through the hole, but
so look at this.
Not very often, but it happens.
Let's watch this quick video. 2 battery, 1 coil flyback driver, flyback capture with a double pole, double throw relay.
Oh man, I wish they wouldn't have drawn it this way. It makes it hard to follow. Oh, okay. I see what they're doing now. Okay. Wait, what?
You want me to pause it?
Just trying to figure it out with the way the contacts are wired.
Yeah, look at that for a while. It's a good one. You'll like it. But
Yeah,
this one is.
It's easier to draw it as like the switch diagram.
This is the same relay, double pole, double throw relay, but instead of.
Yeah. Well,
you see where the coil is? The battery was there before, and you see where the 2 batteries are at the top. I don't even know how I came up with this.
This arrangement isn't a standard.
No,
You know,
none of them
on
are,
some
man.
relays you might have 7 and 8 be in the coil, and that'll be
Yeah, no, I see what you're saying. Yeah,
that'll be
but
most of
it's the
the
only image
time.
I can use.
But the relays where it says 1, 3, and 5, 1 and 3 would be the switch contacts, and then 5 would be the throw.
So, well,
Which
seven
that's
and
what it
eight
looks
is
like
where
it's
you
drawn. And,
7 and
okay,
8.
I see the point where it's drawn now.
7
Okay,
and
that's
8.
what it looks like.
Look at 7 and 8. It's where you give power to
Yeah.
activate the
Okay.
relay.
Yeah, I see. That's how it's drawn now.
And then 5 and 6 is connected to the channels to feed the batteries. Flyback, and for 2 reasons, but
Yeah, I'm gonna have to
it's
make
so
everything
confusing
bigger.
to explain. And even to, I don't know how I came up with it, dude. Honestly, I don't know. It just came up with it and did it when I came up with it. Otherwise, I would forget about it, right? But here it is, and yeah. See if you can follow it. And I forgot what I came up with here, but can you see the coil at the bottom is receiving charge from only one battery at a time. There are 2 batteries on the top left and right, source batteries and charged batteries. But the coil is only receiving charge from one battery at a time. Now, the coil flies back into both batteries at the same time. But neither one of those batteries are giving a charge at that moment. I had to just say that because it's part of the.
Yeah, it's a pain when you have circuits like that where it's loops around.
No, yeah. I'm also explaining this too here, but let me go.
I like it drawn better like as nodes, to where you'll have it like
nodes.
Yeah, well, yeah, like for example, like where you just put like plus 5 volts for a circuit, or you say relay contact 1, and everything that connects to that would be relay contact 1.
I don't put the voltage on the batteries.
Then you don't have to cross the things around as much. It makes it a whole lot easier to understand.
So red is when the coil's getting charged, and when the battery looks red, the battery's giving charge. When the battery looks green, it's receiving flyback. When the coil is green, it's giving flyback.
If it was me, the way I would try the timing is I would have the relay, or better yet, a MOSFET switched an instant before the coil is turned off. Because there's a transition time. Of course, you have to be careful when you do that to make sure it's not too much, but otherwise you shorten things. But
well, this will work without any shorts. You can't find any shorts here if you look at it. There will be no shorts. You have 4 diodes, not 4 high voltage diodes.
Give me a second. I want to grab this thing to show you.
I want to do this one too. It's an easy one to do. Only thing is, those double pole, double throw relays, you got to give them power and to run them, and that's right there is a loss of energy, You have to feed power to the relay to run it. It's not a whole lot of energy. You could turn down the energy you use to trigger the relay, and the contacts that it makes will be lighter, not so heavy, so it'll be like less of a duty cycle kind of. But when you get too low on the voltage, the relay don't turn at all. You need a certain amount of voltage to get it to move at all. I was explaining how this system is great and all, and it works without any shorts, and it's a great flyback system, but you have to power the relay with power that you're going to throw away, To get that relay to activate, you have to feed the coil in there a small amount of voltage. And that's the only thing I don't like about using the relay, that the magnetic relay here is that's the difference. When you use this relay, the power that you're taking from those two batteries is the same power that you're taking from these two batteries. And those two batteries are going to receive the flyback. So it's like you're using power to trigger a relay right here that's going to end up in, you're going to wire these two relay coils, one of each, in series with your drive coil seen here. Your drive coils are seen here. Each battery has a drive coil, a charge coil, and you're going to wire.
For a second.
When you wire one of these,
shorted.
When you wire one of these relay coils,
okay, I see it now.
In series with the drive coil, and that you see here, you wire the other of the two relay coils to the other drive coil in this circuit. Now you have two series pairs of coils, one smaller coil just to trigger the relay, and one bigger coil to generate the flyback. But they're in series, so together they'll generate flyback. Not only will the relay coil be in series with your bigger coil that's making the flyback, but the smaller coil's flyback will be going the same direction as the bigger coil's flyback. And you'll be recycling the flyback from the relay energy that you put into the relay. Unlike using a standard relay here that you buy at the store, if you don't open it up and put a diode in there, a flyback diode, to capture the flyback off that coil that you're charging up to power and trigger that relay, then you end up wasting the energy you put into it, at least a good portion of it, when you could recover some of it at least. So that's one option with these standard relays, double pole, double throw relays. You can open it up and attach a flyback diode to the coil that you're inducing voltage to trigger it with, so that you don't waste that energy for not just to make a trigger. At least you can recover some of that trigger energy that you're using. And not only that, you should be able to wire the coil inside the relay in series with the coil that you see here, which would cover your needs of recycling the power you give it to trigger it. I don't know if anybody followed that.
Timing's off. That's opposite timing.
Say again?
The pulse is going to come at a different time.
The flyback? Yeah.
The pulse will come when your relay is turned off.
The flyback, right. And
so basically when you do that, you might make the relay
you can't energize the relay coil.
Turn it off and it'll go off on.
You're right. That won't work. But that's why you need to use this relay. You can't use a single source throw relay. This relay is only a single source. You can't give it two sources. This relay, you can give it two sources. That's the difference. See?
You can use several relays, but then you're making the whole circuit less efficient. But
say again? No, so you can use it.
You can use several relays, because I was going to suggest you could use some car relays, but most of the car relays are SPST.
And all the car relays only take one power source. You see two power sources here on the left, not one. This relay is triggering two different power sources, not one power source.
Yeah, I'm trying to think of where.
It's a mind twister, Anthony. I don't expect you to get it right away.
Even though they didn't actually use it, but most of the relays were actually DP-DT inside.
Yeah, but single power source, not double power source. They can only throw power
they were
from one source.
They were DP-DTs, two sources, two drains. But
no, double pole, not double source.
That means the same thing.
No, it doesn't. A double pole, double throw relay accepts one source power to it, not two. You can only give it one source power. You can see it right here.
Well, you're not powering the coil. That's the switch.
This is the double pole, double throw relay. It only accepts pins 7 and 8, one source power.
That's not what the wiring means.
pin 7 and 8 is one source power, not two.
That's not what it means. Here, I'll show you.
I'm sorry, not pin 7 and 8. Pin 3 and... Well, you know, I'm using pins...
Well, that didn't work. Went to pull a pin out of my pocket, and I got half a pin.
Well, here I'm using the source power is connected to pin...
Figures.
2 and 1. One of the source powers, you see, here in this video, you see one of the source powers connected to pins 2 and 1, and the other source power is connected to pins 4. Oh my God, and 3. Yeah, and it all, yeah. It's a mind twist. Even for, you know, anyone who's familiar with switching circuits, it's still a mind twist.
If you look at a relay like that one that I originally sent from DigiKey, let's see if I still have that.
Anthony, listen to me explain this circuit. And
I see what you mean with the coil.
Listen to what I'm saying here.
But
I go through the whole setup. When I came up with it, I made this video with an explanation.
Yeah, pretty much all the relays are going to have one.
Well, hear this out. It's 7 minutes. Hear this out, and then hit me up with your questions. You know, ask me anything, or debate me on this. But first, hear this out and try to follow everything I'm doing here, so you can see what's going on.
Oh, I see what you're doing there.
No, you don't. I'm sure of it. Because I don't even see it right now, and I came up with this. There's no way you could see this. I still...
You must be talking about something different then.
Fully.
I think they called it the relay nomenclature, but I don't see that now. That's what they called it in school, I think.
I'm going to draw out the lines now and all the paths of everything.
Oh, damn. I thought I could find, they used to have some videos from the old phone companies. You know, see all those, the custom switches and everything. I can't find it now. It was something to look at, though. Kind of like watching an old Frankenstein movie or something like that with all the voices going everywhere. There are special relays called bistable relays that have 2 coils, but they're used, but not very often. They're usually pretty expensive too. I wanted to get one to replace for test equipment card and needed 8 of them, and it was something like $12 or $20 each, depending on where you looked. So I was like, okay, that's gonna have to wait.
It's going to flip now and get power from the other battery. I'm going to that part now. You see those two diodes pointing up?
Hold on. I seem to. Oh, there we go. I lost the tab for a second.
The two diodes pointing up is the positive flyback.
What's driving the
relay?
Switching of the coil. Yeah, the switching of the relays.
A separate power supply.
It was like a reed switch, wasn't it?
You just trigger 7 and 8 with a separate 12-volt source to trigger the relay.
Yeah, if I remember right, it was a reed switch that Bedini used.
Yeah. Right, but that's a single pole to read.
Yeah, just one series.
That's plus flyback. Green is flyback. What? Oh, no, I'm sorry.
I was thinking he was using the flyback effect from the motor driving coil, not the relay coil. Where's the motor driving coil in this?
Now this is the flyback.
Yeah, where's the motor driving coil, though?
The one at the bottom. Only one coil. 2 batteries.
You have 2 coils in that circuit.
Oh, the other circuit had 2
you have
coils.
A motor driving coil in inside the relay from 7 and 8.
That's different circuit. That's a different circuit.
Okay, I didn't know which. I was thinking he was just using the one for the back EMF from the. Okay, right. Okay, I see it.
I think you see it now, right?
Yeah, I see. I see what you're talking about now.
Yeah, this is just a different circuit. It's not related to this at all.
Just a different way of looking at it. I'd definitely like to see that with capacitors, though. I'm wondering. I'm wondering if we're not going to get a different effect too.
That circuit you just saw has nothing to do with this. It's nothing to do with this. It's just a double pole, double throw relay. How to use the double
idea,
pole.
Basically, but yeah, I know what you mean.
That's just how to use the double pole, double throw relay different ways using the flyback. But it's got nothing to do with this.
I'm wondering how much difference we would get using capacitors instead of batteries. Because
I mean, you could do that too. The batteries could be capacitors. Like I said, this is a concept model. You don't have to use batteries.
Well, they are different though. The capacitors, the more they're charged up, the less they're going to seem like a lower resistance.
Right. That's right.
Whereas the batteries,
will they even take the flyback?
Their voltage goes up, but it's going to be way, way slower.
I think you really got to have a load going on at all times. You got to use the power.
Yeah.
You can't.
Well, that, and also I've heard from a lot of places that they said that I don't know if this is correct, but this is what I've heard in a bunch of places, that the electrons themselves are not moving in the battery, and it's making the surface charge in the battery, building that up. That's what Bedini had said. He said that it wasn't just less current, there was no current.
Right, it was just potential on the terminals.
Yeah, but he was charging it up, but with no current. That doesn't make a lot of sense, at least not conventionally.
Right. Right, he's using the high potential to polarize the chemical in the battery in one direction.
Yeah, for lack of a better description.
Without current.
Yeah.
Which you can do, because it's not just the current that does that.
But yeah.
It's not just the current that does that. It's mostly the voltage that does that. But the current helps speed it up, or quicken the process.
Really little of both. The whole physics way that it talks about that isn't great.
Bedini also says it's not. You don't want to go faster than nature's speed. It's not something you can't rush this.
Yeah. But I think too much of this. I know I've heard of a few like very smart people talk about that we shouldn't be using voltage and EMF as being the same thing. That they said in the highest level physics books, they don't use the term voltage, they only use EMF.
Voltage and EMF are different. I mean, you got the EMF is generated by the current that the voltage pushed.
Well, the EMF is supposed.
I mean, you could have voltage with
the EMF is basically
very little current.
Voltage, but they're saying that the EMF is caused by the voltage, but I don't get the differences. I don't get the difference.
The strength of the EMF field is regulated by the current amount that you have to offer behind that voltage.
The guy that with the Toyota motor,
you could have a 10-gallon bucket or a 100-gallon bucket of amps. It depends how many amps you got behind that bucket. You can still have the same voltage, but let's say you have all the amps.
He was saying there's a difference though, but I don't know. I don't get the physics of it. But that's what the guy.
Let's say you have all the amps in the universe, and you got 100 volts to work with. And you got 100 volts to work with, and you got a coil that needs 101 volts to get the amps through it. Well, all the amps in the universe are not going to go through that coil now, because that coil has a high enough resistance to resist 100 volts or anything under 101 volts. As soon as you go over the voltage that the coil can resist against, then all of a sudden the amps are going through it.
Yeah, that
means as much amps as the coil can handle, as well as much amps as you got to offer behind the coil. So if the coil can handle infinite amount of amps, because it's some kind of superconductor or whatever, and it has a resistance to limit the amount of voltage, to increase the amount of voltage that you need to put behind it to get any amps to go through. What I'm saying is, if the coil requires 101 volts and you give it 100 volts, no amps is going to go through it. You need to give it 101 volts.
Hey, check this out. When I Googled EMF versus voltage,
you're not going to get any EMF until the amps goes through the coil, and
that's not what this says.
Well, you're going to have some kind of amps. You're going to have at least 1 milliamp go through that coil to generate.
There's no amps at all in this circuit. This is what it's saying. It says EMF and voltage are both measured in volts, but they have different meanings.
What's the link?
EMF is the force that causes the difference in electrical states, such as the potential difference that's generated by a battery or solar cell.
Show me what you're reading, man.
Applied to each coulomb of charge that passes through it. Now, voltage, it says, is the difference in the electrical states between the 2 points of the electrical field. The voltage is the result of the source's internal resistance and the magnitude of resistance of the current. So basically, they're saying the EMF.
Right. The magnitude of the current is based on how big is your lake. You know, how much water you got in there.
Well, what they're saying is here is the EMF causes the voltage, and then the voltage can cause.
Nah. The voltage causes the amps to move.
No, there's
and then the EMF is generated.
There's no.
No. I don't believe that. I got to see the paper first. Maybe you're reading it wrong. That's not possible. Where's this paper? Link me. You got a link? Let me see.
Yeah,
this.
I'm trying to remember how I did it last time.
The private chat. That's not possible. You're telling me that the EMF, well, hold on. EMF will induce voltage in a stator coil when you're receiving power, not the other way around. When you're giving that coil power, it's a different story. Of course, EMF will induce voltage in a stator coil. That's correct. But I didn't think you were talking in that direction. I thought you were talking in the direction of giving power to the coil, not receiving EMF fields.
I've got it on share as far as whether it's working. I don't know, but I've got it on share.
Oh, I didn't see nothing pop up. Oh, there it is.
Okay, maybe that's why. Maybe it just takes several seconds to start working.
No, I didn't see it. I got to scroll down.
Yeah, every time I do it, it like takes a while.
What do we got here?
Yeah, this is just where I just Googled EMF versus voltage at the top.
Right, I think they're referring to the EMF hitting a stator coil.
Yeah,
not the voltage going into the coil. That's the other direction.
Well, there's no coils in this. There's
what
no
are they talking about
yet.
then?
There's no circuit yet.
Electromotive force and voltage are both measured in volts, but they have different meanings. Yeah, EMF, the force that causes difference in electrical states, such as potential difference generated by a battery or a solar cell. EMF is I can't see any glasses. But somewhere in there, they must be talking about the difference between receiving EMF and generating EMF, which is two different things.
How's that? I made it a whole lot bigger.
Yeah.
I know the feeling. Need some
Electrical
glasses.
states between 2 points of electric field voltage is the result of the source's internal resistance.
So the last
and the magnitude of the resistance of the current. EMF is the cause of potential difference.
EMF is the cause of the potential difference, but voltage is a more general term that includes EMF.
For example, in a circuit with a voltage source and a resistor, the voltage source provides the EMF, like I just said, while the resistor only provides the voltage, because the resistor is the load. And it's going to store the voltage on the two ends of the resistor. And it's going to store the positive and the negative on the two ends of the resistor.
Resistors don't store.
No, not store. I mean, the voltage is going to collect on the two sides of the resistor. Not through the resistor, but on the two ends of the resistor where the potentials are trying to meet, but they can't because there's resistance in between them, but not enough resistance to where nothing can get through.
I've seen a few videos on this, and it boils down to like a lot of calculus.
This is very accurate. EMF is a cause of potential difference, but voltage. For example, the circuit of voltage source. For example, in a circuit with a voltage source and a resistor.
Force, not electromagnetic force.
When you apply voltage to a resistor, that voltage is now on the two sides of that resistor.
And this is one of these things I've never seen in electronics. I mean, in the engineering text, but in physics, you got people arguing over this.
Okay, yeah, okay. So what they're saying is when you put the plus and minus on the two ends of the resistor, now that voltage source is going to generate the EMF through that resistor because it's a load. It could be a coil or a resistor. It doesn't matter.
Yeah, but it's
You're
not
still going to have a load. The resistor is a load, and so is a coil. It's going to allow plus and minus to meet and each other at that point to some degree based on the resistance value, which regulates the amount of current that meets the amount of current that meet at the plus and minus junction of that resistor. The resistance of the resistor determines how much current of that potential is delivered to the two junctions of the resistor.
This almost looks like a circular argument.
Well, no, it's correct. Everything here makes perfect sense to me. I mean,
Well, it does on the bottom, but then you go on the top and
the
it says
resistor is causing a voltage drop based on the resistance. The voltage drop
except the
across
beginning.
Except
the beginning, EMF.
You're gonna have to clear that up. I'm
voltage.
not getting what you're going at here.
But both are measured in voltage. The very first title, electromotive force and voltage, are both measured in volts.
Of course, because the EMF saturation level is the potential of that field or the voltage. And if you put that EMF field over a stator coil, and that EMF field has a potential value of 10 volts,
that would
the
be a
coil
voltage
is going to
drop.
pick up 10 volts, assuming
that would be a voltage
right
drop.
coil. Huh?
That would be a voltage drop. This is
the voltage drop would be based on the resistance of the coil, so you would have some voltage drop.
All I know is in physics books they were like arguing over
What
this.
does it say without no voltage drop? I didn't see that. Where'd you see that? There's got to be a voltage drop.
No, there doesn't.
It doesn't say anything about no voltage dropping here in this text. Nowhere in here does it say that there's no voltage drop.
At the beginning, it doesn't mention a load.
It implies that through the resistor. The resistor is the load.
Yeah, but you don't have to have a load.
Well, they put one in this topic. In this conversation here that they created, they put a load.
Well, they did when they're measuring voltage and the last thing, but not when they're measuring EMF.
Well, you can't use a resistor to measure voltage unless it's a very low resistance or something.
Yeah, this is one of those things that messes with your head the way they describe it.
When they measure, I'm thinking when they measure resistance with a meter, that it's like a 1 ohm thing, and then they calculate out the 1 ohm to give you the accurate reading.
Well, just for example,
you got to create some kind of a load to get the measurement.
Yeah, but here, what's the load? Nothing's connected to it.
It's at the bottom. It says with a voltage source and a resistor. The voltage source and a resistor. The load.
Right. That's for the bottom when you're calling them in two separate things. But engineering doesn't usually say that. It's only in physics. It's
electromotive force and voltage are both measured in volts.
Yeah.
But they have
so right at the beginning it's saying you can measure them in volts, but it doesn't say they have to have a load or resistance. And not only that,
to get the reading, you need the load.
Yeah, but even in EMF, they're leaving out any kind of a load. It says generated by the potential difference of a battery or solar cell. What's the load?
Right.
There isn't a battery or there isn't a load there.
Well, to generate the EMF, you need to put it into a coil, right?
No.
The voltage?
Are
you saying that the battery terminals are generating EMF?
That's a magnetic, like electromagnetic field. This is an electromotive field or a motive force.
Yeah, but the battery terminals are not generating EMF by themselves. You have to drain the energy into
no. They are generating EMF.
They are.
Yeah. Right now, if
well, then that's kind of hard to believe because of a 12-volt battery. How's a 12-volt battery going to cut across 6 inches of air and create a load?
It won't.
It won't.
But let's say, for example, I'll turn my other part off.
So you're saying if you take an EMF meter to a battery terminals, you're going to read something?
Let's
pick up EMF.
Let's say this is a 300-volt battery, and I'm using a real-world application here. You ever heard of the chart recorders? That's when you'd have like an experiment. It would make a graph on a piece of paper.
Oh, okay, yeah.
Move across it, it would go like that.
Yeah.
Well, how chart recorders work is you take a piece of paper, you set it down on it, and then you hit this button to hold the paper down. Now, so some are a little air vacuum kind, but some are a high voltage kind where they have a circuit board underneath that just has lines of traces, and the 300 volts will hold the paper down. There isn't any real current flowing, but it's holding the paper down, so it is doing some work. If you see what I'm saying, the electrostatic attraction.
That's interesting. So that device is actually moving stuff without current.
Mm-hmm.
That's what you're saying. Can you say that explain that one more time? How that thing operates?
Well, it's the electrostatic attraction from the high voltage. Same for within copiers. I used to work on copiers, so you could have the high voltage charge.
Oh, electrostatic,
where
right?
they transfer true. The paper comes in, and here's a roller charged with 10,000 volts.
You're getting. You see, when you talk about electrostatic, I am not filled in on that. I don't really understand that. I understand that it's there.
I mean,
but I don't understand that it's. I don't see it. I mean, maybe it is EMF, the electrostatic thing. Maybe that is EMF.
Yeah.
Well, I don't see why it wouldn't be.
Yeah, there's like an extremely small current going on because of it's not perfect, but
it's still EMF nonetheless.
Is just the electrostatic attraction. There's you're not going to pick up any magnetic fields there.
What's EMF then?
No, that's what I was saying was the difference. It's just the static force field between the two.
Of the
voltage
of the two potentials. Static force.
Oh, well, okay. But maybe this is what they're trying to say. The way they said it was, I don't like the way they said it, put that way. But maybe this is what they're talking about.
I don't know if static energy is
I think this
moving
is what they're saying. The voltage, okay, right here, I've got, let's say, I'm not going to get into the Coulomb numbers, but let's say I have 9 million more electrons on this side than this side. That's a voltage or potential difference.
Right.
But the force is if I put, let's say 2 little plates right here, they would have an attraction between each other because of that force. If I made it, like two big pieces of paper, if that was 2 separate ones, it would pull them together.
Yeah, that's the static energy doing all that.
Yeah, that's what I'm saying. The static is the EMF, I believe, is what they're saying.
Well, it must be EMF force, because it's static.
Not the static voltage.
Static energy has to be EMF because it demonstrates electromotive force. In other words, it moves stuff. I mean, it's moving paper, right? It moves the balloon.
Yeah.
So it has motive force.
Yeah, it's got a force. But if you look at it,
so it has to be also classified as EMF because it's moving stuff.
Well, yeah. There's 2 different EMFs. There's electromotive force, the voltage, and there's electromagnetic forces, which is what most.
Yeah, but it's the magnetic force that does the motive force.
Yeah, that's the vast majority of when people's going to be talking about it. So
electromagnetic force is the motive force. It's what's creating the magnetic differential is the same thing as the voltage differential, because your magnetic increases with the voltage because the current also increases with the voltage. So therefore everything increases with the voltage. Whatever's going on, I think voltage is just people are trying to understand how is it possible to
the magnetic field comes from the current. No current moving, no magnetic field.
Right, but how is it possible to have pure potential?
Have a voltage field.
That's pure potential. You can have that without any flow, like a battery sitting on the ground. Mm-hmm. It's just pure potential. There's nothing.
Yeah.
It's not being loaded until you connect something.
And according to physics, it's not doing any work, but it actually does do work in some places. Well, I mean, technically it does. Okay, for example, like a fluorescent bulb. There's very little current there, but it's clearly lighting up.
Yeah, it lights up more than the current you would think it.
Right.
Than the current, right? Because that's the gases getting excited by the.
Yeah.
The frequency, not so much the current, but the frequency.
It's like very little. Yeah.
The current just establishes the
bulb. If you ever feel a neon bulb, it's like very little current there, but you put your fingers on it and it's pretty much cold. Maybe just slightly warm.
That's the
I don't
efficiency of
even-
transferring the electron from
People
one
even
end to the
remember neon
other.
bulbs? Does anybody even remember neon bulbs now?
Neon bulbs.
They used to light up orange.
Neon. I know the gas neon bulbs.
Yeah, that's what I'm talking about. Yeah. Oh, like the signs. Yeah, those two.
Yeah,
Well,
those are
there's the other
no
kind
way.
that's like
Those
a
are
little
just
bitty.
too cool. Those are too cool. You'll never be able to replace that with LEDs. The LEDs look cool too, but not as cool as a glass tube. There's no disconnected points of lights. There's no gaps in the lighting at all. You can't get any better than that. Maybe one day LED will figure something out to do that, to simulate that. But
They do have some pretty cool looking, what they call a
Tesla came. Didn't Tesla come up with the fluorescent bulb? Wasn't that his thing? Who invented that?
I don't know if he invented it, but he used it.
Somebody did.
I think he might have. I think he did, but I'm not positive on that, but I think so.
Using what kind of gases did they put in there other than argon or whatever? Argon to control.
I don't know what he put in there back then.
Helium or whatever. They use some kind of gas that lights up when you excite it with high voltage.
Yeah, that's kind of wonder where they got a lot of the stuff from back then too, because it's like way harder to get back then. Oh,
well, I know Tesla invented because I bought one of his inventions for $200. It's a fluorescent bulb with two ring. It's one bulb that's completely round like a donut, and it has two solenoid rings, iron cores around the glass that are pulsed with the coil.
Some kind of induction circuit?
Yeah, it's an induction bulb. Right. And he lights up the fluorescent bulb. I don't even know if there's gas in there or not, but it's super bright. White is not like the white you see from an LED. The LED white disturbs your sleep. This white is
I don't like different. It
either. This is called the induction Tesla bulb. It's a one tube fluorescent tube, and it's got two iron core rings around the tube on two ends, and each iron core has a coil wrapped around it, and it's being pulsed at a higher frequency, just like a standard fluorescent system works. I think.
Yeah,
but Tesla invented that. What I'm saying is that's Tesla's invention. That way of doing the fluorescent lighting with the two iron rings around the two ends of the donut tube of the glass.
He was the one that really came up with
That's not how they do it today with fluorescent bulbs. They just put the high voltage in one end of the tube and it goes out the other. He didn't even connect. There's no connecting any pins into the tube. It's just a magnetic ring around the glass. The glass is completely sealed. There's no electrical connection to it at all. Just the iron core ring being pulsed is stimulating the.
I wonder what frequency he was running at for that World's Fair that he had.
This bulb, the induction fluorescent bulb that Tesla invented, is super bright. It uses 300 watts, but it puts out it consumes 300 watts, but it doesn't consume 300 watts. It consumes like 180, but it's doing what a 300 watt system would do as far as lighting is concerned. And he doesn't excite the gas the same way we do today. He uses an iron core with a coil wrapped around it, two iron cores that are around the tube, the donut tube, glass tube. It's a donut. So you have two iron cores around two ends of the donut glass tube filled with whatever gas. And there's no connecting any pins in there like they do with modern tubes.
Did you know many of the LEDs are also fluorescent bulbs?
No, they're diodes. There's no gas. Maybe
there's no
gas diode. I don't know.
There's no gas, but they don't put out white light. They put out ultraviolet light, and then that has a fluorescent coating on top of it, and the fluorescent coating lights up.
Oh yeah, I saw that.
For like the fluorescent bulbs,
right? They simulate.
It's mercury vapor, and it actually makes UV in the outside of the bulb. Well, the inside of the bulb is inside surface is coated with the phosphor. Yeah, some of those. I think some of those put off more UV than others because it's like I've seen some it's not too bad, and others it's like you turn on the light and it's like, oh man, it kills my eyes after like a minute or two. Just makes your eyes feel tired. You ever get that with the LED bulbs?
Yeah, no, I don't like these LEDs. I have this Tesla bulb. I ran it before, used it before. I remember how pleasant the white light was to me. It was not bothering me at all. I actually enjoyed it very much. When I turn on a LED white light, it's just not giving me that same pleasantries, you know.
Right.
As far as the lighting goes, you know. And it seems like the same
I'm
light.
I'm up the halogen ones now because I don't like them.
Halogens, yeah.
Halogens,
they're
way easier on your eyes.
I don't know why, but yeah. I think the LEDs are flashing on and off. That's why.
Yeah, they are.
At an inappropriate frequency, maybe. I don't know.
So some of the newer ones are actually putting out red, green, and blue. Not that fluorescent coating, but they're
halogens don't pulse. They're oscillating. That's
man, I got this TV I was working on, and 70-inch TV I got that it didn't work for my neighbor, and I got a UV light to check fluorescence and stuff, and I had a cat smell somewhere that I couldn't figure out where it was coming, so I thought I could find like urine stuff. Never actually worked for that, but I got near the TV and like all the LEDs just like lit up really bright when I got near it. I was like, damn, I didn't expect that. I expected a little bit, but it was like you couldn't tell.
What's that now again? You were running away. What were you doing again?
I had some places where I had a cat that got sick and peed, and I was trying to find where it was coming from.
With what?
The light was supposed to show, you know.
You had a black light.
Black light.
And what happened?
Well, it didn't work. Didn't work very good at all for the urine. But when I got near like certain plastics or the LEDs, those things lit up like the 4th of July.
Yeah, that is weird. I did see that before too. I don't have a black light now, but I used to have one. And they seem to light up plastics. There must be fluorescent materials in the plastics.
What do I do with the LEDs?
I like this.
Oh, there you go.
This soundtrack from this heavy metal.
This is the UV. Boy, it shows up kind of purple on the screen. Little paper.
Yeah.
That's like almost all the paper now has a fluorescent dye in it. This kind of surprised me though. The LED light. Well, looks like the batteries keep out of it, but the border lights up more. The light's off.
Oh yeah, I see that.
But when I shine the other light on it.
Well, an LED is also like a photo cell.
When I'm looking at it, the center isn't lighting up very much, but the border around it is really lighting up. It's showing up different on camera for some reason.
Because it's an LED, you could use that to absorb light and make power. That same light there, you put it in the sun and you put a diode the other direction to a battery, it will charge like a solar cell. LEDs have the same kind of circuitry as a solar cell. You know? They even have they're a diode.
Pretty impressive for a battery powered circuit.
Yeah. I bought one of those. It didn't last too long for me. Something went wrong with it.
It's actually lasted like almost 2 hours, surprisingly, and it's still working. It's not as bright as it was at first, but still working.
I didn't like that they didn't last very long. The battery on them.
Yeah, it's like at least like as much light as like a 60-watt bulb, roughly. Great for working on a car. Oh yeah. That's one thing the LED ones really came in handy for. Is I got one of those little work lights that hang in there. instead of the regular bulb, I put one of those. Now they got the plastic bulbs in there, so they're way more durable. I put that in there instead.
Yeah, I mean, LEDs are useful. They seem to grow plants even, but unless they get the color figured out,
yeah, the
eventually
colors
people are going to get sick and tired of this. Like, even the yellow sucks. The yellow sucks. The white sucks.
Yep.
I mean, compared to the halogens or the old-fashioned incandescent lighting, it's just, they got to get the pulse rate correct, because it's either the wrong frequency, or maybe it's not fast enough, the pulse rate. But they don't want to bring up the pulse rate, because then they'll just use more power and you won't buy it. You'll just say, oh, it guzzles power, like an incandescent would. They'll figure it out someday, how to get LEDs to emit like an incandescent does,
Yeah. Yeah, that's just my kitchen LED.
I think the
That's really
LED lighting
this.
technology is in its infant stages. It's like it's baby stepping right now. It's going to blow up maybe in a few more years. They haven't done enough research, but they have done improvements, but not enough research.
Yeah, I was pretty impressed when they first came out, and I never thought they would have something like this. The flashlight.
Look at the handheld flashlights. That's where a lot of the improvements
now are really
happening
great.
right now.
Surprised me.
Did you see some of these handheld LED flashlights? How the beams are like so awesome.
Yeah, this one's actually I've got this is the UV version of it, but it's got.
I actually think the light coming out of the LED flashlights is better than the light that they sell you at the store for your.
Yeah, this has got that little telescoping thing on it. It was 2 for $5.
You know what I think they're going to end up doing with these LEDs? They're going to create a nice focused beam LED and put it into a glass light spreader, like a piece of glass, a bulb that spreads the light evenly, and that's what's going to end up happening.
Well,
they're already doing that.
They already do that.
They do that with flashlights,
Yeah,
and that's more appealing. It's more pleasant to look at too.
Yeah, they have that for the other bulbs too.
Right, but they're not. They're not really doing that much for the LED.
The little circuit board, the little squares.
Yeah, but they don't put that on your standard LED bulb that you plug in your house. They don't give you that for your house. They give you that for your flashlight, but not your house bulb. You gotta make your own LED light for your house with a glass lens on it to do that. They don't sell that for houses. They sell that for flashlights though. Watch though, they're gonna be making bulbs, LED bulbs with glass lenses to spread the light. You're gonna pay more for it, but it's gonna last. They're gonna make sure it lasts longer too, But it's gonna be a much better light than what we have now as far as house lighting concerning LEDs.
There you have them. I'll show you.
I'm busy working on the house, and when I'm done with this house, I got nothing to do but build a lab, and it's going to happen, man. And I'm going to replicate that relay and this circuit and nicely, and just work on the using different impedance coils to limit the current. I'm not going to use any resistors.
I'm having a hell of a time trying to get my toilet to seal. I've resealed it many times. Finally I put it on several times. Went in there. I finally went in with a heat gun because I thought I even used a whole tube of RTV to seal it. I thought
at the bottom you're talking about
the seal where your toilet fits onto
the seat,
or
the bottom, or at the bottom where the wax flange.
Yeah,
you got to unscrew those two bolts, take it off, and put a new flange, a wax flange.
Oh yeah, I did that like 7-8 times already.
Well, how is the?
Finally got the guy across the street that used to be a plumber to help me, and he's like, "Yep, fits perfectly."
They sell these other. They sell these fern coat. They call it. It's a fern coat flange. It's not wax. It's plastic, and it's more permanent.
I tried one like that and it still leaked from somewhere. Can't figure out where. Even after using like
So your toilet
half a
flange,
tube of RTV to like put around it.
the toilet flange that connects to the floor is probably cracked or damaged. You got to change that. Or if it's a rental, then the landlord can change it.
Yeah, it's my house, but I looked all over for damage. I can't find it. And what's worse is
when you take this toilet off, look at the toilet flange and make sure it's level and not cracked.
Yeah,
or,
it's slightly off, but I can't see what I can do about it. It's like an 1/8
if
inch.
it's slightly off, that'll happen.
Yeah,
You have to
like
take
an
it off
1/8
and
inch
put a new one.
from right to left. Front to back, it's nice and level, but right to left, it's like an 1/8 inch off.
Is it a plywood floor or a concrete floor?
That's concrete.
Maybe you might end up having to change that flange and make it level with a new flange. That's the
Yeah,
only way.
I'm wondering that. I don't know. It's got where it looks like
When they put that
used
flange
lead
in, they
on
didn't
it.
put it level.
Yeah, it looks like they used lead on it to solder to it, because you can still see what looks like a little lead there. But
How big is the tilt on it? Minor or major? On the flange, on the floor. Is it slightly off level or majorly off level?
With the level setting here, I got about an 1/8 inch difference right to
1/8 inch.
left.
That's not enough. A fern coat will fix that. A fern coat seal. It replaces a wax seal. You know that wax ring you put down there?
Yeah, I've got one.
You don't need that. You get it's a plastic black piece that sticks to the bottom of the toilet. It has a ring of glue that you peel off and it sticks to it. And then you put the toilet back down. On the bottom of the fern coat flange, it sticks out a plastic flexible 3-inch tube that sits right into the toilet flange in the floor, the hole in the floor. Trust me, I used to use fern coat flanges to fix those problems with toilets leaking all the time like that. I used to manage property.
Is that the same as this stuff?
No, let me hold on. No, that's just no. Hold on, let me max it up. Let me see this. Better than what? Yeah, that's it. Did you put it on yet?
Yeah, it still leaked. I've got another one on there where.
Did it have glue on it? Did it have a ring of glue to stick to the toilet when you put it on?
Well, it didn't have a part that peeled off. It just worked by compression.
And you.
So I got one like that. That's a different brand to put them together, and I'm hoping that's
that's not the one I use. That's not all the brands are equal. That's not the great. Get the one that's black, not blue. The plastic that's black.
The only ones I've seen were that one, and I'll show you the other one.
There's another brand. It's not a blue plastic material. It's black, and it has a ring of sticky material that goes where you stick it to the bottom of the toilet.
Actually, you should see. I wasn't messing around this time. I got that one, and then I got this one here. It's similar to it. I don't know if that's.
Yeah, that's no good. You're getting the wrong ones. Fern coat. Let me look it up. Hold on.
Yeah. I got
you're getting all the wrong. All those things suck. All those manufacturers, that stuff crap. Right?
I didn't see any with that name you're talking about though.
I'm gonna find it right now. It's called Fern.
I got these at Lowe's.
Give me a second. I'll find it.
Yeah, I finally put that the blue one, and I put some RTV around that, and then I held it on with. I bought another flange and put it on top, and put some weights and let it sit for a day on there to seal it, and then I put some on the little lip to seal it. And then I put some glue gun a little bit on the outside to hold it in place too, just in case. If I had my way, it would be PVC to PVC, and it would be a nice permanent mount.
That don't work. Yeah.
You know what I mean? So something that's nice and solid. Oh, did you see the LED there? Did that ever show up?
Huh?
Did that ever show up the LED that I got right here? Oh, it's showing up as two screens here. I don't know if that's
that one.
Yeah. Yeah, I got a few of those. They're like 30 and 50 watts. Some of them's already got the glass and stuff with it. I used it to replace one of the Torshare lights, and it worked, but not as good as I thought it would. It wasn't as bright as I'd hoped. Had to put it on a big heatsink too.
Toilet flange.
Oh, there's those glasses. Yeah, see the lens thing?
Yeah, how much is that LED?
That one says, let's see.
The better they look, the more expensive they are.
It's like $4, $3-4.
How many watts? Lumens?
Okay, $3 for that, but it's not saying. Usually they show the watts next to it. This is a weird listing. Yeah, this listing didn't even show the watts next to it. Usually when I've seen it, it was usually like the module was like $1.50 to $3. And then the little plastic thing in the lens was like another $3 or $4. Yeah, because this is what I got, just the module itself, and I put it on a heat sink. You just have the 120 volts on each
This
side.
is what I'm talking about. Fernco wax-free toilet. There it is. This is the one I ended up using that solved my problems. The same one you're dealing with. It's at Home Depot, and
Yeah, let me see which one you're talking about here, because that was the only two that were there besides the one that was just wax. And
it's in the private chat. Check it out. That sticks to the bottom of the toilet, and then the thinner part goes in the hole.
I've never seen one like that.
Yeah, that's the thing right there. I'm telling you, that solved me so many problems with.
How do you get it to fit on the toilet part, though?
See the thinner part, the ribbed part, that goes in the hole in your floor.
Right, I see that ceiling there, but
you see the top, that's gluey. That's glue, that sticks.
Oh.
You got to push it into the toilet part, the hole in the toilet. The toilet itself, you turn it upside down when you put this on it, and you push that on that hole and make sure it sticks with that glue good. And then you turn the toilet around and land it into the hole, and you're done.
I think part of the problem I've got is because the toilet seal wasn't flat. It's like it's round, but then underneath of it, part of it goes like this and then back down. I don't know if it'll let me show you on the phone, but I think you know what I'm talking about. So I can show you how it's set up if you want me to.
You see the top part, how it looks like glue, sticky stuff?
Yeah.
That sticks to the bottom of your toilet.
Oh, shit. This item's discontinued.
Well, you can find it at Bond Plumbing Supply or other places, or Lowe's or online, Amazon. Just, you want to get this right here.
I took the other, the better than wax one on that.
Wax-free toilet seal.
Yeah, I put a bunch of RTV around that. Kind of do the same
thing.
Yeah,
I've done all that stuff too, Anthony. It's a waste of time. You're going to end up coming back to it. It's going to leak again. This is what solved my problem.
Yeah, I put some hot glue on it. That stuck good. The RTV didn't stick very well like I thought it would.
Just get this thing right here, man.
Yeah.
Be done with it. You know, it's a $10 item.
Hey, if it was me, I would have like 2 bolts at the top holding that thing on, and then way to bolt it to the bottom.
Well, even if the bolts aren't down, even if the bolts,
there wouldn't be any of this stupid little wax.
I have this on a toilet that I use every day, and the toilet shakes, and I have this on there. It doesn't leak because it's stuck to the toilet, and there's no way to leak. It's glue. The glue at the top there, it seals, and the bottom ribbed part is shoved in the drain line. So a little bit of wiggling, it's not going to cause a leak because you have that ribbed section there.
Yeah, I don't know if that would work with mine, with the way mine's got the.
It worked for me.
Well, I'll just show you how it's. Okay.
That's it right there. That's what I recommend. Get that thing. That's the only thing I use. I don't even bother with wax seals anymore. They're handy. They're $5 instead of 10, but you'll kind of come back to it.
Check this out. This is how mine looks right now. It's got the seal right here, just like usual, but then it's got this part right here and here that's like a good 1/4 inch up, that's raised from the background here. So if you put something on to seal it,
right. If you don't want to have to replace the flange, you're talking about the floor flange, right?
This is the toilet itself.
Oh, the toilet itself?
Yeah.
Show me that again. I thought you were talking about the floor part. Yeah. Okay. Yeah, that's where you stick that thing in there, right in that hole.
The raised ceramic, and then they've got like some writing across here, so it's not completely flat too. So
right. You should have a ring that's coming out. It's protruding, so that you can shove the plastic thing over that ring.
I tried several different of the other rings, and I bought like a PVC flange and put it on there just to test it.
You have to get this one I showed you is a 3.5 inch. That should fit your toilet, because they don't make 4-inch drains on toilets, but they do make 4-inch drains on flanges, toilet flanges on the floor part.
Yeah, that's what mine is. The toilet's 3 inches and the flange.
The link I sent you is a 3.5 inch hole, so that's more than big enough for any toilet. They don't get any bigger than that.
Yeah, the hole fits fine. I think that's what the problem is, but I can't actually tell. I even got one of these little camera endoscope type things to see, but I tried getting it in there, and I could kind of see. But it's, for $10, not bad. Just on a little.
Well, you paid $10 for that one?
Yep, for this little camera thing.
To see what? Inside what?
To see in the toilet, to make sure it was compressing, and when I turned it on, to see if there was water coming out of it. But
that's a toilet cam?
Well, it's just general.
Just a regular camera. Huh? That's a good find there for $10.
It's just a little thing that you plug into, either a laptop or a camera.
That's pretty
or
cheap
phone.
for that thing.
I think it was like $11, $10.
That's cheap. Those things used to cost more. Those are like spy cameras. You used to have to pay like $100 for that.
Yeah.
Or more. The cops used to use them to stick under doors and stuff, right? When it first came out. Yeah, you can use that. The plumbers use those cameras too. And plumbers would used to pay a lot for those too, because I used to know plumbers, and they had that also, and they were like $1,000 instruments, but they weren't that small. They had like 100-foot length on this camera,
Right.
Go inside the drain and stuff. But yeah, I mean, if your flange is a 1/4 inch off level, I wouldn't worry about that. The fern coat will take care of that. And if it doesn't, then you got to change the flange. There's no other way. You got to chip it out and cut the. If it's PVC, I don't know. Is it cast iron? Oh, yeah.
And cast iron on a concrete floor, so I don't know if
then if you end up changing that flange, you can sometimes salvage the cast iron, cut it back some, and attach a PVC flange, but you might as well just do the full cast iron 90, get rid of it, and replace the 90 with PVC up to your floor with a new PVC flange if you're going to do that. But it depends what's involved in getting under the floor there, how hard it is, and if the cast iron is rusted through and you see that it is, you probably want to change that. You want to.
Yeah.
I had that issue at my house.
That again doesn't work, but but
I just replaced my sewer line at my house. I had like 6 foot of rusted through sewer line. It was.
That's what I'm worried about. That I hope it's not in there. What's worse is the air vent is
not working.
Well, here's a slab. Here's the toilet, and here's the air vent. So if the toilet leaks, it goes in the air vent. The air vent's part of the slab.
Leaks.
Whose bright idea to do that is? I'd like to get
the toilet would only leak if you're not getting good drainage. So maybe you have a rusted out drain line, and you're getting clogged.
That's what I'm hoping I don't. But
I think it sounds like it because that's exactly what I had here.
Well, I know it was at least leaking a little bit on the top because
Yeah,
because
that happens when you don't have a good drainage because the water fills
the
up.
water was coming out on my floor. That's how I knew it was leaking.
Yes, that happens when you don't have drainage because the water fills up the drain line and comes up the top.
That's the thing I can't figure out because I went and I got my garden hose.
Are you on septic? Are you on septic or on sewer line?
I got my garden hose, put it on full blast in there, ran it for 10 minutes.
And it's draining.
Drain great.
Oh, then you just have a leak when you flush it. When you
Must be. I'm hoping this fixes it. I'm hoping it's just that top.
That's the
Or maybe sometimes at the street it's clogged because I asked him from the street because I noticed it seemed to do it like just when it rained heavy.
Oh, then then the water is coming from the storm drain back into your line, which means you have a break in your line somewhere. The groundwater is seeping into your break in your line.
Oh, they actually had it backed up. They actually had it backed up.
The same thing happened here to me.
Yeah.
And you know what you gotta do for that? You change
the street.
To fix that, you gotta change the break in the line so no water from the ground gets in. And then if you want to also go further with it in case the storm water or there's a backflow from the sewer system into your house.
That's what it was.
You put a backflow device in, they're like $50. PVC though. And that means you have to cut out the cast iron and put in PVC section to install that. Because it's a PVC device. They don't make that. I
heard of the backflow thing.
Yeah, they're $50. They got them on Amazon. I just put one on.
I don't even know if I could get in there because it's all part of a slab.
Well, you don't do it there. You do it out closer to the street where the backflow would come into your house area.
Oh, so we're talking a lot of money to get to it then, right?
No, it could be your pipe can run in under some grass or something outside.
Yeah, my bathroom is
You're not going to get backflow from your own house and your own pipe in your own yard.
Either way,
you're going to get backflow from the city line coming into your pipe on your yard.
I can't see it backed up there either. It must be in the mount somewhere, but I hope.
If it ever backs up, you could have roots. It could be a number of things. Root kill, and if you use root kill, it's sulfate. What's it? Copper sulfate, and the copper will rust out the cast iron. So
I did come up with a couple different versions for a new kind of mount. If only I had the money to sell it.
How old is the drain line on the house?
It's original. The house is from '66.
Yeah, mine was 100 years old. Put it that way. My drain line that I just replaced was 98 years old.
Yeah. Plus, who knows how much drain cleaner they put down there.
Yeah.
But it was really the inside of the mount was really pitted, but I couldn't find any actual leaks. But either way, I went over it with RTV and tried to fill up all the little pits just in case.
Well,
I wish there was some way I could get on there and pressure test it between there and outside the house. If there's leaks, I can actually find them. Or at least know they're there.
You mean in your drain line, if there's a leak, it's hard to know. I mean, the only way to know is if you keep snaking it and you get the snake ends at the same point. Let's say you had to put a snake in the line and it goes 40 feet every time before you declog it. That's where your break is.
That, and if they had some kind of sleeve in there for that, because
you know what I'm saying? When you put the snake in the line and you go a certain amount of feet every time,
right? Oh yeah.
Break loose the leak, the clog. That's because that's where the break is. It's happening.
Right.
And the dirts and rocks get in from the ground and clog it, or roots from the trees around it. And and there's no getting around that. Your plumber with a camera will tell you where the break is, and just if it's not under your house, then it's an easier to deal with kind of thing.
I know one thing. If this doesn't work, I'm making something custom up here. I already did. I even made my own flange to fit around the existing one, since it had that uneven toilet mount. I cut it out a little bit bigger there, so when it set on the ring here, that it would be a nice flat surface. but it turned out to be like just a hair too tall to sit on the toilet now. But I had it on there, had a bunch of hot glue that I put in there, pressed it on. It was like perfectly stable, and I thought, aha, I got it this time. But it was just like maybe an eighth of an inch too tall to
right.
like, be
And a
able
slight
to-
wiggle, and when you flush the toilet, it leaks. But with this thing, a slight wiggle will not do that.
Yeah. Oh, this. I never got that far, but if that doesn't work, I'm just gonna get a new toilet that doesn't have that little bump thing in there.
You saying the bump is keeping you from putting the flange on there?
I'm thinking the bump is the cause of the leak.
Oh, you have it, unless that it's a ring. You're telling the bump that's shaped like a ring.
This little part that sticks up here is the reason it's not getting a good seal, because that sticks up.
Is that part sticking up higher than the ring is sticking up? The ring next to your finger.
No.
The ring on your where you're putting the finger, you're pointing at the ring on the toilet. You see
No,
the ring
but-
on the toilet? That protrudes
but
outward.
when you put this on it, you put this in.
What I'm
and then
saying
the
is,
other part
Anthony,
that-
the
that
toilet
fits on-
has a ring on it, a ceramic ring.
Right.
The toilet itself has a
The-
ceramic ring.
This part goes after it.
Forget
next
about that.
to
Listen to me. The
Yeah,
toilet.
no, I know
I've
what
been
you're
a
talking about.
landlord manager for 40 years. Listen to me. I've messed with hundreds of toilets. I'm a plumber and I didn't even know it. The flange, forget about that. The toilet itself has a ceramic ring at the bottom where the water comes out the toilet.
Right.
That ceramic
That's what it
ring.
is.
Yes. Is it broken in
No.
any way? No. Is the straight pieces that you're concerned about protruding higher than the ring? Or is the ring protruding higher?
It's not higher, but this
Because
part
the
right
ring
here
should be
prevents
protruding
it
higher
from
than
being
anything
flat
else.
against the body of the toilet.
Yeah, it looks like those two pieces are preventing you from getting a good seal with the
Right.
fur coat. So that means you have to change the toilet that doesn't have that there.
Yeah.
Get another toilet.
Like when this part would sit down.
Yeah,
over that,
I've never seen a toilet like that.
it would be like
That's a
having
de-
like this in between.
That's a
it just
defect
with
in the build of the toilet. They
Little
built
bit.
that toilet wrong. They shouldn't have put any ceramic around that ring to
Yeah.
give you trouble from putting a seal on there.
Yeah, they got both the ceramic and the rating. I guess they just
Yeah.
depended on that.
I think
wax
they put
stuff,
that there
but-
to stabilize the toilet. They're on the ground when it sits down. If it's anywhere close to the ring and it gets in your way from putting a seal over that ceramic ring on your toilet, then just get another toilet that doesn't have that. They're
Yeah,
like
that's what
60
I'm gonna
bucks,
do
dude.
next.
You can get toilets for 60, 80 bucks, brand new.
Lowest one I could find was like 100 and.
Well,
around
you're going to Home
100.
Depot. You got to go to Bond
Yeah.
Plumbing Supply. Bond,
Oh.
B-O-N-D.
That was at Lowe's, but
Find a Bond, B-O-N-D. They're nationwide. You got to have one
Bond?
somewhere. Yeah, yeah.
I've heard of them.
You save 40 bucks on a toilet.
Yeah.
And a lot of stuff's.
Do you have to have a
it's
dealer's
for,
license to buy stuff though?
It's for plumbers. Plumbers buy there, but you can, if you have a company debit card, you can use that to buy there.
Oh, okay.
Bond, B-O-N-D. I'm telling you, don't spend your money on toilets at Home Depot. You're going to be wasting 50 bucks out the window per toilet. They used to be 60 bucks at Bonds, then they raised it to 80, thanks to Home Depot's prices. That's capitalism for you.
Yeah. I looked up Bond. It says there's nothing within 100 miles of me.
Well, try any
But I'm sure
plumbing
there's other
supply
plumbing
store.
places though.
Plumbing supply store, not Home Depot or something. No,
Yeah.
plumbing supply store.
Yeah, I know we've got some of those around here.
Yeah, I don't know other names, but I know Bond is a plumbing supply store. That's all they do is plumbing.
You know, why on earth they don't have like, something where the two can just bolt together and none of this stupid wax stuff?
Because they want plumbers to have jobs.
I think you're right. Job security, as I keep hearing.
Yep.
Yeah, so much stuff like that. I still like my idea better, just having it to where it's a permanently flexible mount.
See, I mean, the toilet built like that in the first place. Yeah, I see what you're saying.
Yeah.
They'll probably end up
It's
doing
not
that.
built for that wax thing. It's like that doesn't make any sense.
That's the free market, I mean, why don't you go ahead and build a toilet like that, patent it, and I guarantee you people are going to buy it. If it's working better than any other toilet and it's easier to install, There's no way you can go wrong.
If I had some money to work with somebody to market it.
That's the only place you can go wrong is in the marketing and getting it.
Yeah, I thought of an idea what I thought would be. I thought was original until I did a patent search on it for like to have an internal vacuum. So no smell would get out of the toilet. And it turns out that already exists. There was like a patent for, I think it was called the Magic Toilet. It's like, why the hell doesn't everybody already have that then?
You mean for the smell?
Yeah.
Like in airplanes?
I haven't seen an airplane toilet, but probably the same.
Yeah, when you flush it in an airplane, it's
well, not just the flush. Just you sit on it and there's a vacuum that, it's mostly sealed in, just a little bit of an air vacuum. Instead of it being in the whole room and then having one little vent in the room, take out some. Take it out. Take the smell out at the source.
Yeah.
Not only
Well,
that,
I mean, that's complicated. You got water down there, and you need electrical devices. You might get electrocuted sitting on the toilet.
No, you could do this easy. Make it a 12-volt source. Not have just have the plumbing. Just have the
voltage
plumbing
is safe. I'm sure electricians will have no problem sitting on that toilet, but everybody else is afraid of electricity is going to say, no way.
Have the fan on the wall, okay? And have a hose going down there. No electrical connection at all. Just the air suction. Right. Doesn't even have to be on the toilet.
Yeah, but it's more expensive to build stuff like that. Manufacturers don't want to go that length.
That would be like
more stuff to go wrong in
a
shipping,
$10-20 add-on to a toilet.
Break, more returns.
I mean, think about it. That'd be like $10-20 add-on to a toilet.
You'd have to design something that's guaranteed not to create issues and returns or anything like that, And then
the way I was going to do it, there wouldn't be any problem like that.
Yeah. You should make a drawing of it.
Like this on the, the squishy rubber stuff like that on like.
You got to draw it out.
On the sides on there and have the vacuum in the back.
When you draw it out and propose the ideas to investors, they might fund your patent, your whole thing. If they like the.
I don't even know if we could get it since I must have found like 20 other patents that were similar to it, but.
For the vacuum sealed toilet.
Yeah, it's like, why doesn't this already exist?
You look on the patent office for that stuff?
What's that?
Where do you look for that stuff? Patents like
Google
that?
patents.
Google patents. Oh.
Yeah, I've spent hours on Google patents finding stuff.
That's where you find all the stuff that's not available in stores, you're saying. Right.
So like here's like Thane Hines. It'll let me send it. There we go. That's the guy that made the bitoroid, which is one of the better inventions I've seen.
It's not popping up.
I think I might have accidentally. Did I just close that by accident? Okay, there it is. Should have came.
That Thane Hines. Ever since I realized how that bitoroidal transformer is actually working with the flux, it's just like a bug in my head now.
Well, it recycles the back EMF. That was another thing I was going to suggest for you. Is instead of doing it electrically, do it magnetically.
Right. Houdini does it electrically. Yeah, and when you use the Thane Hines to do it magnetically, you can. You'd have to probably use it, the magnetic field right away to either use, power something or charge a battery.
Oh yeah, that's
either or. It's still kind of the same thing.
Yeah, but both ways you have to use it then. There's no way around that, but.
It might be more efficient to store the back EMF in iron than into a battery. I mean, in between stages, what I'm saying, before you spend it to a battery.
I would try to get my hands on some cores, but they're not cheap for some of these transformers. Because I'd like to get one. Have you heard of the MEG that Thomas Bearden had?
Would not the back EMF from the coil, if you had that coil wrapped around iron, wouldn't it go into the iron anyway? As back EMF flux? It would go into that core, and then you could then dump it into another coil using the Thane Hines method.
Let me see.
Right.
Oh, here we go. Here's the Canadian version, which is what I like.
Mikey, you gotta stop that. Get off my foot. Stop. Stop.
What the?
Go scratch yourself on something else.
I'm going to show the diagram, but I pulled up the patent and it's missing all the diagrams. What the hell?
The
Never
conspiracy.
seen that before.
They're deleting all the good stuff.
Yeah, I've probably got like at least around 1,000 patents of stuff I've saved. I'm saving everything offline now. I don't trust anything online anymore. That that it's going to be there the next day.
Oh, anything you patent is yours in the patent respect, but it's also available to the public through the patent office more than it is through your own promotional methods.
Yep.
For the very reason why you go to the patent office or the Google patents to see stuff.
I don't know how well this is going to work, but I'm going to try. Let me know if it shows
Most other
up.
people go to the same places to see stuff. They don't look at YouTube or the internet in general. They have to get lucky to find the stuff they're looking for in any other way other than going to the patent office. I've never looked at the patents other than some of this Tesla stuff, but
Is this any of this showing up?
hold on. Yeah. What do we got here?
I don't know why it doesn't show up immediately. Okay, there it goes. We'll see. Okay, yeah, here's
You're gonna have to zoom in.
Oh, I'll pass the yeah, this is the 4K screen, so I didn't know if that'll make it more difficult to see, make it smaller. Oh well, I'll do it afterwards. Let's see. Would have probably helped if, or I'm guessing you're using a 1080 screen, probably, right?
No, I can see. You just zoomed in.
Oh, you
fine.
can? Oh, okay. Let's see. Okay, here's kind of a little.
Should maximize the window you're in, though. Close anything you're not looking at.
Yeah. Let's see. Is that going to let me? Oh, 15 to 18. Let's see if it'll. Okay, this is closer to what I was trying to find. Okay, if the primary field is put in on the left here, okay, it will mainly want to go the easiest route. Magnetically, same as electrically, it mostly picks the easiest route. Doesn't
Right,
mean
it's
doesn't
positive.
mean all.
Its positive is going to reach towards its negative. So yeah, it's going to want to,
Yeah, it tries to, right. It tries to fill the space. But
well,
that
I mean,
doesn't
that coil on
yeah,
the left has a positive and negative.
yeah,
It's going to
some
want to
may
go to its
also-
own negative.
some may also go around here. The other diagram, which is
Right,
the
because
I was trying to find.
because its positive can go around that way also to get back.
Yeah,
into
there's
its
less
negative.
distance for it to travel.
Right.
So when that in magnetic field, the primary here induces to the secondary, which is labeled 1701 in the middle here.
Uh-huh.
If it has a back EMF, since there's already a field there, that makes it easier. Makes it an easier path to travel this way. So a lot more of it will travel to the right side of the transformer.
That's true.
So I thought of a different way of doing it. I've seen other diagrams where it showed the right half as being larger, which makes more sense. That way.
Right, yeah. Well, this diagram is in error. The right half is more matter.
Yeah, I mean, it'll work
More iron.
both ways, but it'll be more efficient if you made the second part of it larger.
With more iron, yes. They made an error here in this drawing, if you ask me.
Yeah, but both will still work. I think this is when he was still testing.
Having more iron gives more room for flux.
Like he shows here, It's because you're not getting the back EMF is now going to the secondary. Normally, you would have the voltage and current through the center here be in phase. Instead, they're 90 degrees out of phase. Which means
it's because of the
0
extra
watts,
iron, right?
Well, it's because it has a second magnetic path.
A second path, also, right? Oh, they're right. The
So
extra iron.
this is primary 1 and secondary 1 and secondary 2.
Yeah, but that secondary 2 is not playing a role here yet. It's just the iron doing all that.
Well, no, both are playing a role.
Well, 1702 is playing a role in that phase shift.
170. Let's just say number 1.
1702. Sorry,
The
1703.
primary
Sorry.
on the left, okay, induces the magnetic field from the power there.
1702, right.
That'll induce into the one in the middle, 1701. And then if that has a load on it, it will make a back EMF field
In the opposite direction.
in the opposite direction, and that will take both paths. But if there's already a field here, that means there's only so many flux lines it could hold. That means it will go over here. I've thought of a different version of this instead of using different magnetic permeabilities on there, putting a different, making one path easier. But but it's still the same result.
1703 coil, that's your loading coil, right? Your draw.
Well, this is the primary, this is secondary 1, and this is secondary 2.
Are both the secondaries your drawing, your load coils?
Yes. The first secondary has to draw power for the secondary for the second secondary to work.
So I guess the second 1703 has less resistance than 1703. Oh, 1701.
Well, it's not the resistance, it's how much power. Let's say you put in 100 volts in 1702. You'll get about 100 volts, minus maybe a few percent for efficiency loss in the 1701. And if this is drawing, if this center is drawing 100 watts, which is its full capacity, then the back EMF, you might get something like 80 watts out on this side, because it's
in the opposite direction.
100 watts in here minus a few percent for efficiency.
Oh, I see.
You might get 95, and then here you might get 95% of what's here. So you might be down to like 85 or 90 watts.
So the coil on the right is just there to
efficiency.
So the coil on the right is just to load off the back EMF from the coil in the center.
Right.
I get it. Which is smart, because you don't want the back EMF building up in the core because it'll run out of room.
Well, it only lasts as long as the signal's on. But
right, but if you're not loading, if the signal's on and you're not draining, it's going to fill up that iron core and the coil as well.
If you look at the patent, though, notice expired.
It's going to saturate to whatever the load is of the primary. The primary has a resistance, so it draws power, right? So that amount of power draw on the primary is going to saturate the core fully, and however long that takes, it may not take very long. But once it's saturated, if you're not draining it, then
there was a better diagram for it. I don't know if you can see that, but
I see it.
And see, so P1, P2, P3. I think this will also, if I can get
Is this the kind of stuff? Is this the core? Was Enki working with? Enki? You seen his stuff?
How do you spell that?
New. He's one of a YouTuber. He's been doing a lot of ZBS.
I've seen one that was called a Kula, AKULA, that has
Kula. Yeah, I know him too. Right.
But I haven't heard that one.
Yeah, the Kula circuit. I know him.
Yeah. This one right here looks standard 3-phase transformer, which I think it might work to do the same thing. Just you're using the wiring you're using it differently than it was intended to be used. Just say it's a three-phase transformer. Really, if you wanted to, you could just put in power here and then take it out here and just use it for an isolation transformer.
What are the
same thing? There's no
what are
reason
the
you can't do that.
coils doing with the less turns? What are they for?
What's that?
What are the coils with less turns on them? What are they doing?
Well, in this application, they would all have the same turns.
Why they look like they have less turns? The ones on the bottom.
Because this is originally, well, it's a three-phase transformer, but normally
three primaries, three secondaries.
They would be about the same, but I think it's just how they felt like drawing it.
It looks like three primaries and three secondaries.
Yeah,
Well,
this right here, for whatever transformer this was designed, I mean, they usually kind of make it as a race show.
looks like they're feeding those three smaller coils with an AC signal, three AC separate AC phases.
Yeah, and getting out the three higher voltages.
And they're stepping up the voltage on the other. Yeah.
But this is just, I think he's just using a standard transformer diagram for that, though, because there isn't like three separate.
Very intriguing method, the figure 8 transformer there.
Yeah, there's different versions of that too, and I've seen all kinds of strange configurations. Excuse me, but for this, just the power in and the power out, you really wouldn't want to do it on the same side here.
Same phase, you mean?
But
you got three legs, three phases. Each smaller coil is receiving an isolated 110 volts from the grid. And so you combine those 310 volts together, you're going to have 330 volts because there are three different source voltages from the grid. The grid has 1,000 volts on it, but it's feeding you three legs of 100 volts.
Well, remember, they're out of phase.
Right, because, if they're out of phase, then
they don't directly add.
Well, they're only out of phase because they're three separate coils feeding you power from the same power source.
No, they're out of phase because that's what the power company provides.
What I'm saying is, if you took one plug from your wall, the hot leg and the neutral leg, and you tied that to all three of those coils, that's one phase, not three phase. You need
but this is
three hot legs from the grid, and the grid gives you three hot legs by giving you three coils that are connected together at one end. The three coils are connected together at one end to the grid coil, which has a much higher voltage. So the three coils that they're sending you in three phases are stepping down the voltage for you at a lower voltage. That's the, what is that, the star? I don't know. I never
Where's the diagram?
Finished learning all that stuff. The delta configuration, star configuration, and
see, like it says here, they're 180 degrees out of phase. That makes the total 360.
Well, that means one 110 volts from the grid is giving you 60 hertz with the plus coming in first, and the other 110 volts from the grid is giving you 60 hertz with the minus coming in first. That's 180 degrees out of phase.
Yes and no.
What do you mean? That's totally yes.
No.
I'll say it again.
Yeah, I know what you're saying, and it's like when you're thinking about it, it looks like that. But what
doesn't it?
What it's actually doing is this.
It is. If it's coming in at the same time at 60 hertz, but the positive half is coming in first on one phase, and the negative half is coming in first at the same time first on the other wire, the other phase.
I'll show you.
That's why the two phases are 180 degrees out of phase, but there's still two separate phases or two separate hot legs.
You see, they're not two separate phases
from the grid. Each phase is a hot leg from the grid, and you could connect as many phases as you want to one return path. You don't need a return path for each one of them. You just need that one return common leg to be thick enough to handle the amperage.
Okay, but that's okay. I'll show you here what's happening.
Zoom in. You could take one phase from the grid, send it into a transformer, and create as many phases as you want.
Now, businesses have 3-phase available. Homeowners don't.
Right.
We might
Homeowners
have
get 2 legs of 110, and businesses get 3 legs of 110 and 240, 220.
Right. We might have the 110 or 240, but I don't know how I got this. How did I get this second?
You're getting a mirror effect here.
There we go. Okay. On the left is 13 kilovolts coming in. That's what it is on my pole. And on
That's
the
13
right,
kilovolts single
you have
phase.
240. Okay.
Center tap, though. What's the center tap for? I forgot. Oh, that's the center tap is the neutral. That's the return. So that's actually 2-phase 13 kilovolts. That's with a single center tap return.
One phase, but it'll mess with your mind the way.
I don't know if it is a single phase coming in at the center tap and it's going out the return out the sides.
Okay. It's 240 across here. And then this is called
right. The center tap is your neutral. The center tap is your return neutral.
So when this is powered here, both sides get power at the same time. If you measure it with your meter or a scope, one side to the other will look out of phase, but the whole thing is actually being energized at the same time. So
at 60 hertz.
Yeah, it's actually, if you have the 240, both will be happening at the same time. This right here, and then for the 240 here will be at the same exact time. See what I mean?
Right. If they look out of phase, though.
Whether you measure it between here for the 120 or here is the 120.
Yeah, but you're talking about AC. You're talking about AC so that that 240 and the two sides of that 240 going into that line, one side is the positive half of the wave and the other side is the negative half. It's AC. So that's how it's going in the line. One side is going in one line at the positive and the other side is going in negative. Because it's AC. You're connected to the drawing shows it clearly. When you connect the grid to that, it's going AC in. So the 2 points in where you connect to that transformer, the positive half of the AC is going into one of those points, and the negative half of the AC.
I didn't draw this very well, but imagine each one of these, let's say 0, 120 volts, or I'm sorry, 120 degrees later, another 120 degrees later. So this is, if I remember the exact number, I think it's 99.3% of.
Well, 120 degrees is because it's 3-phase system. You to get a 360, you need 120. So in a 3-phase system,
I think it was 99.3%. It's been a while since I remember that from school.
Well, hold on. It's a single phase split off into 3-phase. So to split a single phase of 360 degrees cycles into 3 phases, it's going to equal each phase 120 degrees. So when you take a single 1,000 volt source phase, a single 1,000 volt hot leg, and you a single 1,000 volt hot leg, and you split it into 3 chains from there of 3 other legs, that 360 degree single leg has to get split into 3 parts, which is 120 degrees.
Yeah. But you got to remember they're at different times.
No. 120 degrees out of phase.
Phase shift means different times.
Well, right. Different time within the timing of the original phase.
Yeah. Let's say it's 60 hertz. Okay.
Like here. Look. The original phase is going into the 3 phases like this, up and down. But as it goes up 120 degrees into one phase, and then partially down to finish that 120 degrees into that same phase. And then it goes down another 120 degrees before it goes up partially.
Right. That's a time difference.
To the other phase, and it finishes, whatever. You know what I'm saying.
Right.
It has to do
the whole
120
thing-
degrees portions
Yeah.
per a 360-degree cycle.
Right. Well,
into
the whole
each
thing
leg.
is the 160
Nuts.
hertz, one cycle is 16.6 milliseconds. Divide that by 3.
How'd you get that? How'd you figure that out?
1 divided by 60.
Is that, wait, say that again. 1 divided by, 60 hertz, right. You're right.
Yeah, 60 hertz. 1 divided by 60.
It's
60 times.
whatever milliseconds, right? 16.
So that's 16.6 milliseconds.
Huh.
And then
And that's,
divide that by 3 is
that's
5.5 milliseconds. 5.5 repeating.
Wait.
So you know
That's one part. You're saying that's one
phase
part
one
of a
is
60
here,
hertz.
5.5 milliseconds. This one repeats, and then another 5.5 is the third phase. And then you go back again 5.5, and it's phase number 1. So 1, 2, 3, 1, 2, 3, 1, 2, 3.
Well, 16.6 milliseconds.
The whole thing put together is 16.6
milliseconds
Mhm.
is 1/60th of a 60 hertz cycle.
Yes.
So you divide 60 of those 3 times.
1 second divided by 60. And then there's 3 phases out of that, so you divide that by 3.
Yeah, I kind of followed you, but I got lost at the same time.
Well,
but I'm seeing where you're getting out there.
Just think if it's the whole cycle. If it's 3 phases, it's its whole cycle divided by 3. You know,
Which
if
is
they
120
wanted,
degrees.
they could have made it 5 cycles.
You can only divide a cycle into 3 by using 120 3 times.
Well, that's
Or
what 100. That's what
evenly,
120
evenly
is.
anyway. Evenly.
120 is 360 divided by 3.
Yeah, evenly division.
Yeah. Yeah.
So-
now we have power supplies that, since we're not talking about the power line, motherboard power supplies might say like 6-phase power supply.
Right, but they
Or-
start with 1 phase and split it off into 6 parts.
Well,
Using coils
yeah. Well, you have like
or a transformer.
Yeah. Well, you have some of these CPUs.
1 primary, 6 secondaries.
Yeah. Well, the reason is you have some of these CPUs that are like ridiculous now. Some of these CPUs might draw 500 amps at a 1 volt.
When they're at full capacity.
Yeah, when they're at full load. So 500 watts. So instead of just have 1 transistor where you're losing a lot of heat, they might spread that across 6 transistors, and you got 6 transistors that are
Right.
each getting 1/6 as hot, which is a whole lot easier to manage.
You know, I actually did that with capacitors once too.
Yeah, it's called a switch capacitor network. You can do that too.
Yeah, to spread the heat off. I was blowing out a capacitor on a device I made, and I didn't because it was getting too hot. So I created the same value with
Right.
more capacitors. And
Some of these
the
new
heat was the
TVs
heat actually. I checked the heat later, and it actually spread out evenly.
Yep.
And I was so happy. I was like, "This thing's never gonna blow now." It was like a DC power supply I made
Yep.
off of
I've got one of these Hisense TVs that little bitty cap, not only that big, 360 volts, 15 microfarads. And I was like, what the hell? This is like the size of a marble.
360 volts.
Yeah. And it was the
15
size of a little marble. And this is at a Hisense TV, and I looked it up on YouTube, and it was like these things
Well,
blow all
hold
the time.
on.
And I
You
seen
can
it, and I
get-
was like, that value can't be
You can
right.
get,
I read it. Yeah, it's 360 volts. So I went and
you
got
can
a
get
replacement.
400 volt micro capacitors, like 10 microfarads.
Yeah, I didn't even know they would. I mean, I know we had capacitors that high, but not that size. So I went and got one of the surplus store. I got 2 of them that were this big.
The 400 volt
two
capacitors
that were
that I
about the
got,
size of my thumb, like that.
the
And
400 volt capacitors that I got, they hold 10 microfarads, and they're like about an inch tall by a half-inch
right,
wide.
yeah, they're making. It's no wonder the damn thing overheated. And plus,
Right, they're making them smaller, huh?
Yeah, and You know, the TV just went into shutdown. It's like I think
they're trying to save money on parts like that.
Yeah. Well, it went from the originals being 2 little bitty ones to now there's 2. It looks like 2D batteries there instead that sit off to the side of the circuit board.
These new TVs don't have that problem though. They don't draw a lot of power and they use.
This is from a new TV. It's from a Hisense 2019 4K TV.
Oh, 4K does draw power though. I'm talking about like not 4K, like 2K or like.
Yeah. Well, most of the power goes to the LEDs. Not,
right.
I mean, a good deal goes to processing, but most of the power.
The more the resolution, the more light you have to create. So
yeah.
The more power.
Yeah, but you got to remember they're not actually LED TVs. They're LED backlit LCD panels. You know, when you get to the actual LEDs, it's like I'm not sure how much those draw, but personally, I wouldn't get one yet because they still have a problem with burn-in. But
the LED TVs are the light ones, the very light ones.
Yeah, both are. Yeah.
What's the other one?
Well, they call them LED TVs, but
and there's another one.
They're actually like they're like laptops. They're you have your LCD screen.
Oh, LCD, right?
Well, they're both. They're both.
Well, one's an emitting diode and one's a crystal diode.
Well, okay, like here. Okay, on the laptop, you got here. You're looking at the LCD, but on the back of it is a big LED panel lighting that up so you can see through it. If you go back like 12, 15 years, this will have been like fluorescent tubes or electroluminescent panel. If you get like for a laptop, yeah.
You wouldn't be able to see any light. You mean it's just hidden?
Well, it's got like this diffuser thing on it, so you can't tell. Well, I'll put it this way: I can tell. They irritate the hell out of me. But it depends on the quality of them because I got a Westinghouse TV that was a 32-inch LCD. I really like the color on it. Then I got another one that was a 55-inch LG. It was bugging the crap out of me because the colors, instead of being light blue, was light blue. It had like a little bit of a purple shift to it because the LEDs were actually a different color, so they had to mix them differently. I finally got them to come out here and replace the board where they
are the 2K and the 4Ks. Are those LEDs or LCDs or both?
They're both. The ones that say OLEDs are actually just LEDs.
Well, my TV, I've had it for like 5 or 6 years
with
now.
an LCD in front of them.
I'm using I think it's an LCD TV. It's super light. It's a 39-inch. It's no problems, and it's 2K resolution, not 4K, and it uses 60 watts. It's from Sharp. I always shop for the TV that uses the least amount of power because they get hot, and I don't want to heat up my room. I made that mistake with a plasma TV. They use a ton of power.
Yeah, I like that. I like the plasmas better though.
No, the plasma is.
I mean, they do waste a lot of heat. You're right there, but they're the only ones that still use phosphors like the CRTs did.
Yeah,
and they're near instant.
You're saying plasma is still using CRT technology?
Yeah,
I didn't know that.
Well, okay.
Yeah, though I have a plasma still. I tried to sell it.
Use an electron gun that would steer an electron beam, and then here would be the face of it. That would be aimed at red, green, and blue phosphors.
That's how the plasma works?
That's how CRT TV worked.
Okay.
A plasma TV gets rid of the electron gun. It instead puts a little sandwich here that has these little bitty pointy electrodes on it that act just like an electron gun onto a phosphor, just like before. So it's still nice and fast, but it's not really thick. It's still using the red, green, and blue phosphor. That's also the reason why it's so heavy, because the front panel of this, does have a vacuum inside, and fairly thick piece of glass, which also makes them fairly fragile too. But they have a much brighter picture, and when they have black, they are really black. No light coming out of them. Whereas if you got an LCD
I noticed
black,
that.
I'm looking at my
it's
black
not
right
even
now,
off.
but it's really like a
not
really
even
dark
off, but
gray.
it looks like it's off.
Yeah.
No, I mean, I bought a plasma when it came out. I thought it was they didn't have LCD yet.
If it's still working, I'd still be using one. It was really hard to find ones that were even 1080s that they were selling.
My plasma's 1080. I still got it. Still works. I just don't use it because it heats up everything. It's too hot.
Yeah, those other TVs until just recently, the recent ones aren't bothering. Either they're not bothering me as much, or maybe I'm getting used to it. But if you'd see something like a football game or a basketball game where it would keep panning to the right or left, that screen blur would just drive me nuts.
Because you don't have a high motion TV. You need to get the high motion. Yeah.
Well, it was just part of the circuitry. The thing about it is I still had my analog 32-inch CRT TV and the little converter box. When it fed into that, didn't have that problem because the phosphors were way faster. It was the screen problem. It's kind of funny that the little $40 box worked better than the $2,000 inch TVs at the time. But same with the plasma. They refresh it like equivalent to 600 hertz. They're not really 600 hertz, but each section can refresh on its own.
Right. That's how they get the image quality so good, because it's so many refresh rates plus a lot more pixels. It's only 1080 pixels, but
I was trying to find a used plasma, but I never could find one that was at least a 1080.
The 4K is beyond 1080. It's like what 2,000 or 4,000 or pixels per square.
It's equivalent to 4 1080s.
Yeah.
Well, almost.
You can't even appreciate a 2K or a 4K TV unless you have a Blu-ray movie to play through it. Otherwise, you're going to still see everything at 720 or 1080. The Blu-ray movies. No. All the channels, they don't go over 1080. If you buy a Blu-ray movie, it's way over 1080.
Channels don't, but using it as a monitor, it's a big improvement.
I'm saying if you watch regular programming,
the
nothing
TV
is more higher quality than 1080 right now.
Yeah.
Maybe you can stream 2K. I don't know. It's possible you can, but it's
2K and 1080p is the same thing, basically.
No, it's not.
Well, it's 124 versus 2K. It's not a big difference.
1080 is 1080. 1080 is a little less than 2,000 pixels per square.
That's a little bit less, but it's not a big difference.
I don't know what the K means. I guess it's the pixels per square inch.
It's total pixels.
Total pixels. So there's 4,000 pixels per square inch, and then there's 1080 pixels, 1,080 pixels. But if you're playing a 1080 piece of media, you're into a 4,000 pixel TV, you're only going to see 1080 pixels.
Well, this is the difference.
Play a Blu-ray movie that has more than 4,000 pixels per inch.
Here's the 2K difference. 1920 by 1080 is 2,073,600 pixels.
Yeah, but I'm pretty sure 4K is way more than that in pixels per square inch. Yeah, and what I'm saying is all the news programs and all the at Prime Video and Netflix, they're not streaming at anything over 1080. Not that I know
of. I've got it at 4K.
Well, maybe nowadays you can stream at 4K, but yeah, it's fine. But you can also buy a Blu-ray disc and also play the disc at 4K into the TV. Is what I'm saying is if you're just watching cable or something like that.
Okay, yeah. It's
4K TV, you're not going to get the full
4K is
resolution
8.3
anyway.
megs.
Right. If you want to see the full resolution of your TV, put a Blu-ray, play a Blu-ray disc into it. You know?
I'll tell you what else works. Is I actually only had a 1080 screen.
You know, some Blu-ray discs don't have that much data. They don't have that much resolution. Some discs only have 15 gigabytes. Some have 50, 100.
Yeah, but see there's another problem here, whereas the cable companies and the DVDs and everything are compressing the signal instead of giving you the full amount.
That's true. That's why you want to buy the Blu-ray disc.
Yeah.
At the highest possible resolution.
And that's what I've heard from some of the people that were like work in the studios for seeing the original uncompressed 4K signal, like football games. They were like, you would believe the difference.
That's how I watched my movies. I play Terminator or whatever at the highest possible resolution. My 2K TV is pumping out 2K, but the video I'm playing through it can provide more resolution, but it's not. I don't have a 4K.
I'll tell you something else that would work though. This is what I'm doing. I use Media Player Classic.
Yeah,
Media Player Classic Home Cinema, and
DLC is better.
What?
DLC is better.
No, and this, well, it depends on the video. Once in a while, VLC is better, but most of the time, Media Player Classic is for this. What I'm talking about for using, for straight playing both of them, they're pretty much identical. But for when you go to the sharpen function, I use the, let's see, I'll have to look it up here to make sure I'm telling you the right thing. Let's see. Damn, I hate having a... Okay, there we go.
What was that, dude?
Whoops. That is some music. Recognize it now?
Oh yeah, like you can give me a strike with it. Watch out.
Yeah, that's why I cut it out, because I've heard it's like 15 seconds, so I made it like 4 seconds at most.
Who is that again?
It's Ride Captain Ride by Blues Image.
Right, that's I didn't know the name of that band. I know the song though.
It's everything I watch is like nothing after the 80s.
Yeah.
Back when we had way better music.
What's that song?
Okay, here. It's called Shaders, and if you use...
You know this song that goes like this? It goes, hey, yeah. What's the matter with your money? Yeah. That's an Indian band, no? Like Cherokee or whatever. I forgot the name of that band.
I know exactly who you're talking about, but I can't think of the name.
They used that soundtrack for Guardian of the Galaxy, the movie.
Oh, come and get your love.
Come and get your love. Yeah, that one. That's a Cherokee band. They're like Indians.
Yeah.
A lot of people don't know that. I didn't. They sound like Americans. They sound...
Hey, I'm Cherokee, and I didn't know this. I'm actually Cherokee and Hungarian, so can't tell you a thing about them. But
well, you're more American than most of us.
Yeah. Well, if anybody starts this stupid stuff about this colonizer and everything, it's like, nope, I was here first. Get the hell out. But yeah, if you ever
I think it was Earth, Wind, and Fire, or no? I'll look it up.
Which song? Yeah, I'm a big fan.
Redbone. It's from Redbone.
Oh, okay, that's it. Yeah.
Like in the movie, the actor says, "Don't steal me! You stole my Redbone." When he, the first Guardian of the Galaxy movie, when he gets his tape cassette player back, he knocks him out on the floor and grabs his cassette player back before he books and says, "You stole my Redbone."
Yeah, that's got a great soundtrack on it. The whole movies do. So I went and I was like,
yeah, you were bitching about movies earlier and how the modern movies aren't as good as the older movies. I'm saying, well,
not even close. Yeah,
not all of them. Some of the new movies, like from the Marvel, like Stan Lee, and even the DC movies, didn't they make a Superman and Batman movie? That's DC, right? And that's a different. Was that made by a different movie producer or something?
Yeah, they were different movie producers. The whole DC universe.
Because that's not Stan Lee back. You know, it's not too. DC. But Stan
they really messed up that one that was. There's like two completely different versions of the latest one when Superman was supposed to have turned evil.
I heard Stan Lee used to draw for DC or work for DC or something, like DC Comics.
They might have. They used to be all like one huge.
Like a lot of the characters they used were from him.
Yeah. They were competitors, but they were also all fans of the stories back then. So they.
DC was like the first comic book before Marvel.
Yeah, I didn't even know it was like all these things. I didn't know these originally came from the comics book because I never got into that. And then I started looking at
Stan Lee was authoring a lot of those comic books through DC Comics.
Did you ever see what's that one? There's one I can't think of who it is, but it's got the really big blue guy that's basically
Shazam.
like.
Yeah, that's a good movie too. Did you see Shazam? That's another good one.
Yeah, that was pretty good. They just renamed the shit, I can't think of the name of it. But he's got the atom symbol on his head.
There you go, Redbone.
And he basically goes around naked.
I apologize, guys. I need to get reading glasses, so I'm a little slow to read in the comics.
Yeah, me too.
I've been putting off reading glasses for like 6 or 7 years, maybe more.
Get whatever prescription you like and get the opposite. That's what I've been doing, and it's been helping. Because I was looking up the Bates method, and it was basically saying to exercise your eyes because your lenses are muscles. And I started doing that, and I noticed a little help. But when I found the glasses that worked the best, they were like 1.5 magnifying plus 1.5. So they said to get the opposite. So I got minus 1.5, which is what these are. And I'd wear them for like 10 or 15 minutes, and they were just like, it was like really aggravating at first. But if you wear them for like an hour, then you take them off, then all of a sudden everything's in focus like it used to be. But it only lasts for like 15, 20 minutes. But the longer you do that, the more it like makes your eyes go back to the old focus place. And
the thing about
if you know what I mean,
your eye,
it's getting your muscles working again for your lenses.
Right. That's why what they do with the lenses is they further defocus the area that you're having trouble focusing on, so that area of your eye works even harder to focus.
Yeah,
and that strengthens your eye.
Is actually fixing it. Apparently,
but it gives you a headache. That process gives you a headache, and people stop wearing the glasses because it keeps giving them a headache. But if you deal with the headaches long enough, they'll go away, and the muscle will recover in that part of the eye, and then another part of the eye will grow weak, and you have to, update
It's just your muscles keep getting weaker and weaker if you use that instead of rebuilding the lens muscle.
You have to change your prescription to keep your muscles exercising, right?
Well, this is but let's just compare it to like you getting weak over time. I mean, I could probably last 150, 200.
If you look out,
but now I may not be able to do 100. It's like making me lift weights again, so I can get back to my old strength. And then it fix, which may go down if I don't keep it up over time. It's the same thing with your eyes.
I don't know if you looked into that doctor I told you to look into, Nutrition Detective. I don't know if you listen to any of his stuff. But
I listened to it, but I forgot about it.
You should know this. You should know this regarding the eyes, okay? Aldehyde deposition does not just damage your organs and your body. It damages your eyes too, and your brain, and everything else. Plants are full of aldehydes. Dairy.
I did try the other magnesium instead, but it didn't work at all.
is you avoid dairy. The aldehydes get out of your body. Your vision gets better. Take the zinc. I mean, I've been taking zinc. My vision slightly improved because my aldehyde deposition levels are lower. It's just from eating plant materials. The aldehyde come from plants.
I think probably not using the lenses too, because it's like I barely have any activity.
But what I'm saying is what damages the eyes to begin with is the aldehyde deposition in the eye.
Well, hell, it's pretty much impossible to get decent food anymore with all this junk they put in there now.
Meat is very decent food. It's very low in aldehydes, very low, and at such a low level that your liver can handle the enzymes it needs to produce to get them out of you before they deposit in your body, in your eyes, in your brain, and cause Alzheimer's.
Hey, how long does it take for that carnivore diet to start?
I hope I don't get striked for this. This is not medical advice, by the way. This is nutritional advice.
Are we still on the YouTube at the same time?
Yeah.
Oh, okay.
But aldehyde deposition is not good. And it doesn't deposit in one part of the body, although the liver does do a great job of grabbing a hold of plant toxins in general, or toxins in general, including the aldehydes, which is the bulk of the toxins. You got to understand, these aldehydes are many types, and some are worse than others, and they are very hard to break down with enzymes and get out. So, you know, the less you eat them, the better. I mean, and the only way to avoid them is to avoid the plants, because that's where they come from. Meat does not break down into aldehydes. It doesn't ferment, it putrefies. So the fermentation is the aldehydes. It's a hydrogen.
What does putrefied turn into?
I don't know, but there's some very small levels of aldehydes in that.
Putrefied, I'm not sure.
It's a different breakdown process.
Yeah.
Plants and meat break down completely differently. One putrefies, the other ferments.
Right.
I mean, which would you rather have? An alcohol factory in you from plants, or a putrefaction factory from, you know?
I kind of think that's a big part of the aging too, because I noticed.
Well, our liver is designed to produce enzymes. One of them is called the ALDH pathway. That's for the aldehyde dehydrated.
Hey, what is it that moles seem to like so much?
Huh?
I noticed I didn't have any moles for years, and then all of a sudden, in like 2 weeks, I got like 50
moles.
of them.
Yeah, that's your body detoxing through the skin. That happens when your liver is detoxing. It ends up in the skin. That happened to me too on my right arm recently.
Yeah, because
they come off too.
And all of a sudden, there was like a bunch of them.
Yeah, well, some of them will come off, will break off, and that's just your liver detoxing arsenic and lead, and you know, if you take zinc, your skin will start detoxing, because if you're zinc deficient, your body's not going to detox, so you're not going to get any skin issues. All your toxins are going to rest inside your liver, and you're not going to have any issues. You're just going to conk dead one day because your liver can't deal with no more toxins. But if you enable your liver to slowly get them out, which is what it's designed to do through the bile, it's designed to detox your body. You can't take medications to stop the bile flow. You got to take mineral supplements to increase the bile flow, which is obviously going to make you feel worse because the bile is toxic. But if you don't have bile flowing, toxic bile, then you're not going to feel bad because it's sitting in your liver and you don't feel nothing in there. You feel it when it leaves the liver into the body, all those toxicities. And that happens at 3 a.m. when the liver dumps the bile, or whenever the liver decides to dump bile. It could happen any time of day. And if you have an upset stomach, that's probably what's happening. The liver's dumping toxic bile. And at that point in time, you should be drinking some activated charcoal to suck up some of those toxicities right when they dump into the stomach, because shortly after your stomach pains go away, it went back into the liver. And that's why your stomach pain went away, because it went back into the liver. It's no longer in the stomach. The bile could dump into the stomach and go back into the liver all at once. It does this normally. Just keep that in your mind. Take your brain with that, because it'll start to sink in slowly what's really going on, Anthony. And I'm telling you, if you don't support your bile flow and you do anything to stop that, and diarrhea is a signature of bile flow. That means you have excess bile. Bile is the lubricant for the colon, and it will, if you have too much of it, it causes diarrhea. And it's common with men. Men usually have more bile than women. So diarrhea is more common with men than it is with women. But it's not a bad thing. It's a good thing. You're dumping toxic bile. When you have diarrhea, you're dumping toxins from the bile. But you can use activated charcoal. What I'm saying is you can use like binders to bind the toxins. Plant toxins. Taurine binds to
Isn't that already
an
getting rid of the
aldehyde.
toxins?
Huh?
Isn't that the process of getting rid of the toxins what it's already doing?
Well, your liver will, the bile flow system is getting rid of toxins if it's flowing. But if you take something to stop that flow, which is what they give people to feel better. I'm not going to say who. You have to guess who gives it to people to feel better. And what that is that they give people to feel better, what that's called. And you know what that's called because you've probably used it. Things like Tylenol, aspirin. These things just shut down the bile flow and you feel better. Because your bile is toxic and it's flowing into your stomach and into your body. And it causes you to have a fever because it's an acid and it burns like a fire. And that fever can also save your life from a viral infection. For instance, the fire from the bile acids can kill viruses. Or
Yeah, I think it's
bacteria.
kind of dumb to stop fevers.
Huh?
I think it's kind of dumb to stop fevers if it's like your
No,
body's
fevers are
doing-
good. They're caused by I think they're caused by your bile. But the bile doesn't have to be toxic when it gives you a fever. That's what I'm saying. It could be clean bile. It's still going to give you a fever because it's still acids. Like what I was reading Black's Medical Dictionary. I started reading that, and one thing I grabbed out of there that I never seem to forget is that the liver produces acetone. Did you know that? Acetone burns. It creates heat. Just like sodium hydroxide. Or, you know that the body also makes a form of chloride that is super toxic to pathogens and bacteria. It's used to, kill off infections. The body uses the chloride that you get from salt, and it turns that chloride into another form of chloride. I forgot what it's called, but it has a very short lifespan. It's very half-life, but it makes it, it makes it close to the infection area,
Oh, Watchmen. I was trying to remember that name. I just as Ray Carr mentioned it. Watchmen. That was a great movie. I missed when you said that earlier.
Windows. Yeah.
There's a new cartoon version. It's not. It's all right, but the other version was way better.
Yeah, Ray Carr. Linux is.
Sorry, I'm like a kid getting distracted at times.
You use Linux for your, office, and use Windows for your video games and your social stuff.
Yeah, I was looking up some of those while we were talking. I was looking up some of the things at Lowe's from that Franco line. Yeah, they got similar ideas. What I was thinking about doing, like with the clamp, only they did it slightly different. But
No, all that clamp stuff is waste of time. You just the sticky stuff, the glue sticks right in there. The plastic ring.
I
I've
say
never
just
had a
take it with a
problem.
PVC pipe in the first place.
How long you been dealing with that?
About a year now.
Yeah. And
I've
how
been
many
pulling
times
off
have
the
you messed
past
with it?
week.
How many times did you change the seal down there?
This will be like the 8th time.
Yeah. And you've never used that thing I showed you?
I use that better than wax, like
No, that's garbage. But you never. What I'm saying is, have you ever used that thing I showed you?
No, that one I've never seen. Lowe's didn't carry that.
Okay, try that before you go the expensive
Yeah,
route.
that's what I was looking for online to find it because Lowe's doesn't have it, so I might
It's
have
not
to.
worth spending a bunch of money fixing.
Home Depot is discontinued,
like
so I was trying to find if it might still exist somewhere, but I don't.
Home Depot.
Oh, Home Depot says it's discontinued.
Oh, hold on. Yeah, you can find it. Hold on. It's wax-free. What I do is I look for the part number and then search that in the search engine. And then you see all the other vendors.
Similar idea, though. You know, if anything, instead of that glue just at top, just, have something that permanently fits on the toilet.
It's $4. It's $5. Holy crap. How is it no longer available? Maybe you're searching in Ohio. That's why, in your area.
Oh, yeah, you're right. I thought it would show shipping, but yeah, I didn't think about that. You're probably right. Yeah, mine's just showing for Springfield, Ohio, so.
See where it says product details? The button. And then you can see the model number. You see the model number under product information?
Right.
Search that model number and it'll bring up a bunch of other vendors and places that sell it.
Oh, okay. Yeah,
that's what I do when I can't find something at a particular store. I find the model number from that the store has for the part.
Idea.
Look, Supply House has it. Amazon has it. Fernco.com has it. Quality Plumbing Supply has it. And Manuals Live. A few other places have it. When you search by that model number, you're going to find a bunch of links. Oh, Walmart has it too.
Really?
Yeah. Yeah, Walmart has it. Oh, they want $14, not $5 like Home Depot.
Okay, yeah.
I don't know. Here, see if this link works for Walmart. Yeah, I'm good at sourcing stuff like this.
Okay. So for the trouble, it's definitely worth it.
Yeah, no. It's $15, $20 at the most. If you go any other route trying to fix this one last time, giving it one last shot before you spend a lot of money on it, spend 20 or 10, 20 bucks on this thing before you spend 500 or more, or even more than that, a couple thousand. You don't know where it's going to end up.
Yeah, I do know my original bolts on the toilet too that I thought were on there good and felt on there good, but I noticed.
What I'm saying is this Fernco device will keep it sealed even without the bolts on your toilet. It's just that good.
Oh, really? Okay.
Yeah, I'm telling you. I'm using a toilet right now with the bolts are loose. I never bothered fixing it because I'm going to change the toilet. But it has that device on there. I put it on there a few years ago. It's still working.
Yeah,
and that toilet that I'm using now was leaking.
either. I prefer the older toilet instead of low flow. It seems like it's asking for trouble if you could have less water flowing through there.
Nah.
I've heard a few plumbers say the same thing.
What, more water than less?
You know, that they've seen a whole lot more stopped up sewer lines since then.
I'm not saying anything like that. It's if you have a stopped up sewer line, that's roots or a break in the line.
Well, no, it might flush good, but if you have a whole lot more solids versus liquids, you know, that just makes sense.
There's this thing called mainline cleaner. It uses enzymes, and that's good for that.
Yeah, I was thinking about I think I used some of those a while back. I'm not sure. But I think it was only for septic tanks, though, but I tried it anyway.
No, it works for both main line cleaner. It's not sodium hydroxide.
Yeah, it's some kind of bacteria enzyme thing.
It eats away with enzymes, not heat or nothing. Right, although the sodium hydroxide is pretty useful.
If only we had the like nanobot things already.
Now this you just pour down, and you just wait for the enzymes to eat away at the stuff, and you don't use the line for a few days or a day or two. You know, you give the enzymes a good 24 hours of eating away at the stuff inside the drain.
Oh shit! I just thought of a great idea.
Oh, it's called Green Gobbler. There it is. Look up Green Gobbler enzyme drain cleaner.
Hey, I just thought of a great idea. You know those dung beetles?
This is good stuff.
Push 1,000 of those down.
Yeah, they won't live long. And then underwater.
Yeah, well, you just do it and don't flush for like a day or two.
Well, yeah, drain all the water out of there. They'll go in there all by themselves because it'll start smelling. They know the smell.
I wonder if that's even a thing in the U.S. I don't know.
Look at that link I put in the private chat. That's the stuff.
Yeah, I already got it pulled up. By Surrend, whoever that is.
But if you pour it down there, and it's okay to flush once or twice once you pour it down there, but don't keep flushing, and because the more water you add to it, the less enzymes. You're going to flush out your enzymes.
Yeah, I know what you mean.
You got to let the enzymes sit inside the pipe for as long as you can. And I like to pour the whole gallon in there, even though they say to pour a portion of it.
I thought about putting some compressed air on there. If the water's in there, it's like, okay, I'll give it 50 psi, see what happens. But
that stuff also
I've heard
gets rid of.
That's broken some sewer pipes. So
that stuff also gets rid of the smell inside your line. It cleans up the line. The smell.
Oh, even better. What was that called again?
Green Gobbler.
Green Gobbler. Okay.
It's cheap. It's like $20 for a gallon, but that's cheap. It's the same price as sodium hydroxide. And you don't damage your pipe or nothing. And it actually, it doesn't work as fast, but it works better if you give it the time.
Okay. Yeah, I haven't seen that before.
Sodium hydroxide will damage your pipe, no matter what kind of pipe it is. The heat build up. But it works fast.
I had to replace a few of mine when I first moved in. Heck, the shower, it was like, it was working good, but then it wouldn't go down much. And I finally got in there, the little part where it goes,
you're not willing to pull
it goes like that, the bottom of it was missing.
If you're not willing to pull the hair out of the drain or the stuff down there and take the P-trap out and clean it, then just pour some of that in there and don't use it for a day or two. Let that let the enzyme liquid sit in there for a day or two, at least 48 hours, but don't run any water in there.
I wonder how PVC stands up to that, the hydroxide, compared to the metal.
It'll eat away at it, just like the chloride.
It'll eat it too?
Mm-hmm.
Oh, okay.
It eats away at iron too. It causes the cast iron to rust sooner than later. The heat and the corrosive.
It wouldn't hurt it.
It's corrosive.
Right.
I just spent a bunch of money changing my line, but it's never going to have to be spent again because it's PVC, and I'm not going to be pouring no corrosive stuff down there. You could pour copper sulfide. That's not going to damage the PVC, I don't think. But it will eat at the roots that get in there. I don't think, it's not hot. It doesn't get hot, copper sulfide. It does have a irritating release of fumes of some kind, though, when it makes contact with the water. Maybe that's the sulfides. So, you take molybdenum supplement to get the sulfides out of your body because they slow down your aldehyde detox. The sulfides do.
Right.
So eating onions and cruciferous vegetables will slow down your detox of aldehydes. And taking niacin will support the detox of aldehydes. It has to be nicotinic acid, flush type niacin. Zinc supports it, selenium, molybdenum.
Try some PEMF too. The magnetic field. See how that works?
Yeah, that's all heavy metals, man. If magnetic fields bother you, you have heavy metals.
No. I'm saying to help.
It won't help if you have heavy metals. No kind of EMF will help you if you have heavy metals.
Yeah, I definitely don't use it like on a long-term thing, but short-term it might charge the cells. That's what I've heard. I don't know. I haven't tried it.
No, the cells charge just fine as soon as you get the heavy metals and the toxins flowing out, and that's done with zinc. Zinc will get the cadmium out, the mercury, the lead, the arsenic. It's just too handy. I'm sorry. That's the majority of all the heavy metals we're dealing with anyway. And zinc handles them all.
What do you think about technetium?
Selenium gets a lot out too. Selenium will stop viral replication. If you're deficient in selenium, you'll have viral replication.
Yeah.
If you're not, you won't have viral replication.
Yeah, I've got something left over from a heart test, a stress test thing they did on me.
Got what left over?
Injected me with technetium, and oh man, like unbelievable joint pain. But ever since then,
What is that?
Like,
describe what it is.
it's a radioactive isotope.
To what? Read
Contrast material.
to see inside you better?
Yep. See circulation, blood circulation. Yeah, they said it wasn't really that bad, but then they said turn on the machine, and I'm like 6 feet away, and the whole thing is like lighting up like a Christmas tree. It's from single SPECT, SPECT, single photon emission.
I don't know. Most of these toxins,
tomography.
Most of the toxins bind on to heavy metals.
Whatever it was, I took that in 2016, and my hair on my body is still almost all gone. I lost I would say nearly half the hair on my head.
Boron. I know boron.
All the hair on my legs. I only got like a tiny bit of hair on my legs now. I look like the nicest shaped legs you ever see.
I know boron absorbs
my arms, it's like still nothing. And I used to have really hairy arms.
Boron absorbs radiation. You can take that. But the thing about boron is it also causes sterility. So it's only temporary sterility, though. So you can stop the boron and
I don't have to worry about that. Ain't getting in anyway.
Yeah, but if you have copper toxicity, you're going to be sterile permanently until you get the copper out. And the only way to do that is with zinc. So that's another heavy metal that zinc gets rid of. And you got to imagine all these other toxins, including whatever they gave you at the hospital, is binding to the copper in you and all the other heavy metals that are in you. And as soon as you take the zinc and get those out, what comes along with it? Everything else. It's just they go together, man. Yeah. All these toxins are not isolated from each other. You know, zinc is not a toxin. Unless you have too much zinc in you, then it's not a toxin. But we don't eat foods that are high in zinc like that. In fact, most of the foods we have don't have any zinc, but they have plenty of copper. And copper pushes out your zinc. And you need zinc to repair DNA. You need zinc to make cartilage. You need zinc to convert protein into collagen, which is the body's #1 protein. And the body requires protein over all other things to detox itself. So the more collagen you have, the more detoxability you have. The more zinc you have, the more collagen you have. Does that make sense?
Yep. Kind of showing we should be more meat eaters.
Basically, if you're taking supplements of zinc, you're going to find yourself wanting to eat more protein. Why? Because you have the zinc to then turn that protein into the body's most useful, friendly, and appreciated and preferred protein known as collagen. The zinc will convert any protein you eat into collagen because that's what the body wants. Collagen is the protein the body wants and needs more than anything else. And it uses collagen to detox. And you can't make collagen unless you eat meat, which has protein, and have enough zinc to convert that protein into collagen. Because the protein you're eating is not already collagen. It's a different type of protein, and it's not collagen protein. You see, some of the meat you're eating, meat or protein, some of it's collagen, but very little. Depends on, I guess, maybe fish has more collagen. But the downside to eating seafood is it's full of copper. And you keep pushing out your zinc by eating seafood. And now your collagen production goes down. Once the dots are connected, a few of them, more and more keep getting connected. And it becomes more and more obvious.
I've always sucked at biology, so they never bothered to teach.
I never even studied biology. I just been researching, I have a hereditary kidney disease. So I've been researching this since I was a kid to how to live my life so I don't end up needing a transplant,
Yeah, no kidding.
Like
my
my dad.
Have definitely gone way downhill.
Huh?
So doctors have definitely gone way downhill. They used to be way better.
Well, they're relying on the pharmaceuticals to provide for their answers instead of
that too.
Instead of the diet, instead of changing the diet. This is not medical advice. This is not medical advice.
Yeah.
Just trying to keep
only a drug can cure or treat a disease. So all that thing about vitamin C and scurvy, that couldn't be true.
What? Vitamin C is produced by the body. The body produces vitamin C. You don't need to take it. The body does not produce vitamin C when it's not in ketosis. When the body is burning carbs, it's not producing vitamin C. When the body's in ketosis, it's producing vitamin C from the fat burning that you're doing from the ketosis. It's fat burning. That process produces vitamin C. The body also produces its own sugar. It's called glycine, which turns into glucose. From glycine to glucose. The body produces an amino acid called glycine, and it makes this glycine from usually taurine. And it makes it from taurine because you can turn taurine into any other amino acid. And glycine is an amino acid. So taurine can be converted to glycine from the meat you're eating, because meat has taurine and plants do not have taurine or zinc. So you can eat meat, take the taurine from the meat, convert it to glycine, convert the glycine to glucose, and you don't need carbs to have glucose. Not only that, the stomach has carnitine receptors. Carnitine is primarily found in meat. Plants do not provide carnitine.
Hey, where were you at again? I was just thinking about
South Florida, Miami.
Oh, okay. I was just thinking about for getting parts.
What electronic parts?
Yeah.
Well,
Yeah, I don't know. I know if you was in Silicon Valley, you'd have a hold of one you ever wanted probably, but in Florida, I don't know.
What are you looking for?
Oh no, I was just wondering for you. 'Cause around here, that
I rely on.
I'm in the Dayton, Ohio area. We used to have a lot of different electronic parts places. Now they're like barely exist anymore.
Oh no, there was a parts place up here in Griffin Road West near University. I forgot what it's called. Alpha Electronics. That place is probably still there. It's a small store. Very unknown. There's an Alpha Electronics. I went there once. It's like a room full of, drawers on the walls. And you can't find anything. You got to have the guy that works there get you anything you need.
Yeah, there's one around here called Midwest Surplus. They're pretty good, but
Alpha Electronics is around me. They have all the, transistors you need and everything you can find. I don't even know if they're, whenever you can find all this stuff online now. So I don't know how these.
I actually got some fiber optic cables from there.
Huh?
I got some fiber optic cables from there. I asked him, the guy that's there, I said, is there any chance you guys got fiber optic cables? And I was thinking, yeah, there's not a chance in hell they'd have that. He's like, oh, yeah, sure, over there.
Yeah, but even that you can find online now.
Oh, yeah, I could have found it new, but for something from Surplus, wouldn't have to wait or anything like that. It was new in the bag. It was like, hell. I got, the reason I got it was for isolating my computer because I got hit by, actually my cable modem got hit by lightning and it passed it on to my computer, through the cable line. And I thought, okay,
the cable modem would fry out before that happened.
You would think, but it didn't. When I called the cable company and they were like, yeah, everything's right fine. But wasn't anything showing up on the network. And for some reason, my computer actually worked for a few minutes, but it just kept getting more and more crashing more for like several minutes, and then it wouldn't even boot.
Oh,
I don't
modem.
know.
Yeah, that could be lightning, right?
But yeah, so I got what was called a media converter, which basically takes the network
Stan
cable
Dale,
and
right?
Converts it to fiber.
Have you heard of Stan Dale?
Oh yeah.
He made a lightning suppressing device that you attach to
I seen that.
panel.
Yeah, I seen that.
I'm thinking of getting one of those things. Because, even if lightning don't hit your house and it hits far away and some of that high voltage does go into your house and doesn't seem to damage anything, if you have like sensitive electronics that it hit, like your router, for instance, it did damage it, just not permanently,
Yeah.
Or it did damage it permanently, but not suddenly. Just the damage shows up later. It's a slow effect.
Mine is basically you can hit a direct lightning strike and it'd be fine, but then you'd also need to isolate the power. So yeah, that would be good for the power side of it. Personally, I want to get a couple of motor generators and connect them with like.
I'm curious how that device he made is actually absorbing the lightning strike. What is he using? I mean, a dump load? How do you even tie that to your panel without draining power?
Oh, it just feeds through the.
He could use a high.
No, it doesn't absorb it. It helps direct it, but it will. For like things that aren't big, yeah, I can absorb it. For any like real lightning strike, it's going to be toast.
Yeah, even if you use a dump load that can handle millions of watts, it's still not enough for a lightning strike.
Yeah, well, basically nothing is.
But his device is not for a lightning strike. It's an EMP protection device. It stops EMP, not lightning.
Well, they're very closely related.
Yeah, but it's not a lightning. It's an electromagnetic pulse. It's not the lightning.
Yeah, well, he has a surge suppressor, and the surge suppressor is the same thing as for lightning. Only built faster. It would help. I'll put it that way. Something else that would help if I can find this for you. Shit! I don't see it. There's a thing called isobar, ISOBAR. They were originally surge suppressors. They're hard to find now because people buying these useless power strips that say they have a built-in. In reality, they don't really help. But if you ever see the isobars, they work really good. Same for the if you get the UPSs.
You know, a ground
really
rod
heavy.
outside your house is not going to stop an EMP. It'll redirect a lightning strike, but it won't stop an EMP.
Right.
So how is Stan Deo's EMP device attached to your main panel stopping the EMP from hitting your circuits plugged into your network?
Because it's not the EMP itself that causes the problems mostly.
You mean so when the EMP hits your panel and then the
It's when
Sandeo device blocks the EMP, and let's say it's not there and the EMP goes through your panel into all your other devices, what's going on? If it's not flyback,
okay.
it's EMP, right?
Well, let's compare to this. Let's say
An electromagnetic pulse coming from the sun or whatever, you know?
Well, size is the difference. Let's say
Or the grid, or both.
Well, let's say lightning struck the pole behind your house, okay?
But that's not an EMP. That's something
Yes,
else.
it is.
Well,
it's both.
Is it?
You would get.
Well, you're right. It's an
a very
electromagnetic
high voltage
pulse. You're right.
pulse, and that was just a unbelievable amount of current, which makes a magnetic field pulse through there. Okay, most likely the stuff in your house would survive. Sometimes they are damaged by the EMP. By the voltage, there's a good chance they'll get fried. Okay, now combine, let's say that struck like a block away. The voltage is going to be way more distributed and way less chance of you getting damaged. Still, there's a chance, but it's way less. But the magnetic field, if you have a lot stronger, that induces a voltage into that line, can still travel down there and damage you. And the EMP makes a much stronger magnetic field than lightning does. I mean, it may be like 20, 30 times stronger than a lightning strike, and that will induce a high voltage pulse down the line, just like lightning would. Only, you have the power company was set up with miles of wire to catch this magnetic field. So, it may send you a couple 100,000 volts down your line. Whereas, and the lightning suppressors are going to help and the transformers are going to help. But, they can only help so much. That's what the difference is. But they're, the one makes the other. So, what are those things? They're very similar. If you see what I mean.
I think the ground rod is the really only way.
Well, the ground rod is what you do with the pulse. You're throwing it into the ground. But it doesn't get rid of everything. It just gets rid of most of it, hopefully.
Gets rid of the amps. It pulls out all the amps.
Yeah, like my house. But like I said, the cable companies gave me 75 volts AC, and I kept getting shocked in here. My ground rod was supposed to work, but didn't. I don't even know where it's supposed to be at in this house, but I did find it connected to my plumbing, but that was disconnected.
The plug that you got the shock from wasn't properly grounded.
But even if it was,
if it was, you wouldn't have gotten shocked unless you were touching that ground.
Well,
or you were touching another ground.
Yeah, but what happens if you have
to touch the hot? You have to touch the hot with one hand, and another part of your body has to touch the ground.
Well, yeah. Well, one thing you're missing here, though. Let's say you have a copper rod in the ground, and you keep feeding that for 100 volts for like a few years. What's that going to do to that grounding rod? It's going to destroy it through electrolysis.
Yeah.
So after a while, you're going to have a grounding rod sticking out, but it's not going to be effective. You're just going to think it is. It is going to do that same.
No, but there is no voltage on the ground rod. It's got no voltage. It's
Yeah,
not
there
connected to the hot leg.
Yeah, there is.
It's only connected to the hot leg when you're drawing power through it. But the ground rod is never taking power. It's going through the common, not the ground. The ground rod is only there in case there's any voltage over the grid voltage coming
Right,
into
that's
the
what I'm
grid.
saying. That's what I said. If you had 100 volts going to there, you had a short somewhere for a long period of time.
Yeah, but you never do. You have a 1 or 2 volts because there's always a few volts coming into the ground over the grid.
Okay. You're following now.
The rest of the volts is going through the common line, not the ground.
Hold on.
It only goes to the ground when there's anything over the grid
most of
voltage.
that diverted. It's you have the ground and you have the neutral. You got most of that diverted. It's supposed to be.
The voltage you're giving the line is going out the neutral, not the ground.
Hold on, though. Most of it's supposed to be coming from there. That doesn't mean it always is. You could have an unbalanced transformer and it will do it. That voltage over years going through the ground rod is going to destroy the ground rod. You're not going to know. You're going to have like the 2 volts, like you said, for a long time. Then one day that ground rod's going to break because you've been feeding it 100 volts. So that's been doing electrolysis through the moisture in the ground for years. So then what happens? All of a sudden,
the only reason the ground rod would get 100 volts is if you didn't have a common or a return, and you were using the ground to drain the source.
No, you could just have a bad appliance in the house.
Right, but it's not running all the time.
In this case, my bad appliance was the cable company.
What?
In this case, the bad appliance was my cable company feeding 75 volts AC into the ground.
Oh. Because they're...
I can't even fix it.
That
refused to fix
happened because the neutral leg got disconnected. From the ground was somehow...
I don't know why it happened from them. All I know is it's there. Because
Bad
at first I thought my neutral was wrong. I thought like you did.
Maybe
until I traced it back.
It's a router from the cable company. Maybe they're trying to use the ground to get rid of any unwanted signals on the data line. That's why they did it like that.
They didn't even have a ground on it when they were sent into my house. There wasn't even a ground.
No, I mean inside the box they had connected the ground with the common with some kind of
Yeah, well they didn't even have that. They just said it was just a 2-wire circuit. But somewhere along the line, there's a short that gives me 75 volts through there.
To ground.
My neutral is at 75 volts. Oh no! Let me take it back. My neutral is where it's supposed to be at 0. My ground is at 75 volts AC.
You got cross wiring going on.
No, it's from the cable company.
Where are you taking this measurement? From the router box or the plug in your wall? Because it makes a difference.
From the plug-in to the neutral to the ground.
So you're not measuring this voltage
from the ground.
You're not measuring this voltage from the cable box. You're measuring this voltage from the plug in the wall.
Every place I measured, I got the same result.
And you're getting from the hot leg to the common leg. You're getting what?
That was like 60 something.
So your
common almost the exact same.
So your common leg is not it's got a bad connection to the panel. It's not getting. You're supposed to get 120 volts from your hot to your common. You're supposed to get 120 volts.
Supposed to.
If you're getting 60, the way to make sure that your hot is giving you the full.
I'm not getting this on my hot. I'm getting this on my ground.
And you've got 2 probes on your voltmeter on AC setting. Where is the one probe and where is the other?
Ground, the cable line.
What part of the cable line?
The coax.
Which part of the coax?
Yeah, I unplugged the outer coax.
The outer part or the inner part?
The outer part. That's supposed to be ground.
The inner part is not ground. The inner part is the
data.
I said
the outer part that's supposed to be ground.
The outer part is the ground. Yes.
Yeah, and it's not.
And you're measuring from there to
the 76 volts.
You're measuring from your hot leg.
If I unplug my cable TV, problem goes away.
But you measured this voltage from the coaxial ground side to the hot leg of your grid?
No. My ground and my neutral.
Oh, your ground to the neutral of what?
Hold on.
The
My
coaxial
ground,
does not have a neutral, Anthony. It
I
has a
didn't say it
ground
did.
shielding and a
hold on,
center
hold on,
data
hold
line.
on. You're misunderstanding this. I didn't say that. I said where I measured it. My ground, my earth ground to the cable line, 75 volts.
To the ground of the
My
cable line.
neutral to the cable
There's no
line.
neutral here, though. What you
75
described does
volts.
not involve a neutral.
Yes, there is. That's the center tap of your transformer. 240 volts, center tap.
Your ground line is not the
120.
neutral. It's a separate line.
Yeah, there's 3 wires.
Yes, but the neutral and the ground are not the same.
Yes, I know that. But they're merged in the electrical box.
But at the pole, they're separated with a resistor.
Right. That's not where the voltage is coming from. The voltage is coming
That
from the cable
resistor
line.
makes sure at the pole, that resistor connected to the
Right.
neutral
Right.
makes sure that no more than 110 volts gets through.
Right.
And anything over that goes through the ground. That's why they're connected.
Right.
together.
It's not over it.
And you're
75
measuring
volts
from
is
the
less than
and you
120.
measured from the coaxial outer shielding, one side of your probe to the
So did my power company.
to the ground of your what? Of your grid of your panel? And you got 70 volts.
Ground.
You measured from the coaxial outer shielding to the ground of your panel? Or the neutral of your panel? Or the hot of your panel? Because you have 3 wires. You have ground, neutral, hot. Which one did you...
Hold on, listen. When it is unplugged, when my
That doesn't
cable
matter.
is unplugged,
I'll figure that out later. Where did you put the probes? One on the outer shielding of the coaxial, and where is the other one?
earth ground.
Of your panel, earth ground. Right.
Yes.
Gotcha. Okay. So what
And
do
I
you
get the same measurement from
And you
neutral
got
because they're
60
connected in
volts
my
there.
box.
And you got 60 volts there. When
Between
it's
60
plugged
and
in.
75 most of the time.
When
Sometimes
it's-
it's a little more, sometimes a little less.
When it's plugged in.
That's what it's
Plugged in.
That's when it's pulled apart. But
When
when I
it's
measure
plugged
the
in,
neutral,
what I'm saying is when it's plugged in, you get the 60 volts. Yes or no? And when you unplug it, you don't get the 60 volts, correct?
if cable's not connected to the house, okay.
You
I'm
got to first
measuring it.
answer my question. I
Yeah,
can't
no, I am.
debate
But,
you if you don't
hold
answer
on,
the question.
hold on. There's 2 different situations there. When the cable is disconnected from the house,
You already told
my
me when you
ground is
unplug
ground.
it, it stops, right?
Right.
Okay, so when it's plugged in, you get the 60 volts at those 2 points. From the earth shielding of the coaxial to the ground of your panel.
To neutral, yeah.
Oh, not the ground now. Now it's to neutral. You changed it on
No,
me
it's a
now.
voltage differential from ground
Which
to neutral.
one is it, the ground or the neutral? Because they're not
It's
the
a,
same.
it's a voltage differential.
Yes, but I'm asking a question here, and a direct question. Which one is it, the ground or the neutral? Because if you touch the neutral,
All voltage is relative.
if you touch the neutral, there is no resistance going. There is resistance going back to the grid for you. If you touch the ground, there is no resistance going to the ground for you and your meter and that reading. You're not following me.
Power companies
You have
still
that you when you touch the neutral and the outer shielding of your coaxial, the neutral is going to regulate how much your reading is going to be because it won't let more than a certain amount through that path because the neutral has a resistor on it. The ground does not. So it matters where you're touching, the neutral or the ground.
Yeah.
Which one is it? Don't
They
switch
read
it
the
on me
same.
in the middle of a conversation. You earlier
they
told
read the
me
same.
it was the ground. Now you're telling me it's the neutral.
The cable line connected to the ground. So they're the
Okay,
same
so
voltage
you just
potential.
told me it's the neutral now. You flipped it. to the
No,
neutral.
I said it was a voltage differential.
That's a different conversation.
You can't.
Which
you can't
one are
take
you
a meter and
connected
put
to
it
is
on
all
one
I need to
plug
know.
and leave the other one to nothing and expect to
Okay,
get a
you can
measurement.
debate me separately on that later. What's the difference between
No,
the
I
neutral
told
and the
you the power
ground? But
companies
right now, I
verified
just
what
need
I
to
said.
know where you're touching the probes of the meter to give you an efficient
To
answer.
the cable coax.
I'm processing it in my head. I know where you connected it already. You connected it from the
Yeah.
coaxial ground to
Here's the
the
cable
ground of
coax.
your panel, not the neutral.
Here's the ground to neutral.
But you
If
might
it's-
have connected to the neutral because the only way you would get voltage from the neutral to your coaxial ground is for the hot trying to find another way out because it can't get through the neutral.
There's
Some
a
other
problem
hot.
there's a
Some
problem
other hot
in one
egg.
of their things at the poles, or maybe somebody else's house. I don't know which. But
Well, if you got
somebody
power
else-
going from the neutral line into the ground of your coaxial, that means that
there's a problem.
they are connected. First of all, they're connected somewhere in your circuit, which is normal because you can do that. That's how you filter out radiation signals that could interfere with the
a few volts, yes.
signal.
A few volts, yes.
So it's normal.
75
It's
volts
normal
AC.
to connect the shielding of a coaxial to ground, but not normal to the neutral.
Usually, getting about 69 volts is usually when you're looking at the average of the AC signal.
You should not have power coming from the neutral to the ground of your coaxial line,
right?
Unless
something's wrong.
Unless the device that is sending power that way is properly grounded. If it's not, it's going to find another ground, and it found it. Where? On the shielding of your coaxial line.
That's what I've been saying.
Your shit's not properly grounded. That device is not grounded.
Right.
It's grounded. It's grounded, but it's got one ground, and it's using the shielding of your coaxial. It's not using a second ground.
It's a
should have two
defective
grounds.
circuit connected to
It
that.
should have one ground to your panel, the router. When you should have 3 prongs on that plug,
No.
not 2.
Only 2.
I know. That's the problem.
No, I mean that's what the cable modem design
You
does.
can
Only 2.
filter out unwanted signals by having 2 grounds, one earth and
Right.
one.
That's what I'm saying. The cable company
shielding of your
screwed it up.
coaxial.
Yeah, that's what I'm saying. The cable company screwed it up.
What I meant is the earth, the copper stake in the ground, earth ground, is one ground, and the other ground is the neutral. We call it the neutral. It's not a ground. It's just another return path. But
just
the
another
ground is
path,
not
yeah.
supposed to be used as a return path, but it can be.
Yeah.
It cannot be used as a return path. It can be used as
It's
a
not
path.
supposed to be. Yeah.
A path to have a.
That's what I'm saying.
path.
Yet the cable company insists that's normal.
Yeah, it's normal because they're using they're using their coaxial ground to channel the energy in the router that the router's using
I
away
know what
from
happens
the router.
somewhere. I'm pretty sure I know what happens. Or this is my best guess. Whenever you have a full wave bridge in a circuit and the full wave bridge is connected to the neutral, instead of being isolated like they should be, that
They're
gives
doing
you
it
about.
like that because they're trying to throw the energy
Hold on,
away from the
That's
router.
what I'm saying here. Whenever you have this, like the old I hate this that they're doing this with new TVs. The old TVs, the power used to come in, go through a transformer, and then the rest of the circuits would be electrically isolated. The newer TVs don't do that. The newer TVs use a full wave bridge rectifier, and then what would be the negative terminal of that is connected to the
They
neutral.
don't use a transformer. How are they keeping the AC?
They have switching power supplies now.
Oh, they make AC again from DC? Or what do they
Yeah,
need
the
AC
problem is-
for? What do they need
Yeah,
AC
the
for anyway?
problem is a lot of them are so cheap, the magnetics don't isolate it.
What does
Okay?
TVs use AC signals for anyway? What is it used for in TV? AC.
To change voltages, to change impedance,
And to make the image?
to get your RF signal in.
I mean, I never looked into TV to define
that's the whole-
details on that. But
Yeah, the old ones, that's what you used to, you'd have one volt that was like 6.3 volts for the filament. You might have like 200 and something volts for the tube. You might have, and so on for the old TVs. But now
and it's
they
just
don't-
quicker. So you're saying it's quicker with AC to do voltage conversions than DC?
Yeah, that's the whole thing with AC. That's,
So
that's
why are
what
they
they're
using
worried about
DC
AC.
then? If it's harder and slower to convert voltage with DC. So you could use capacitors to
That's
convert
much more
voltage.
difficult with DC.
Yeah, what do they use to convert voltage with DC? Is it capacitors?
Switching power supply,
Switching-
maybe a resistor network. Sometimes
Boost-
I
buck
like
boost?
using a diode network myself sometimes. The The voltage regulator, dropping it down isn't hard. Raising it up is a lot harder. But it's still, with switching power supply is not that hard.
It sounds like a slower process than using AC.
It's more involved.
It also, even though it's slower, it sounds like it can be more accurate, though. I don't know. Maybe because AC is you can't really change the
usually it is. Yeah.
How do you change? You can't change the frequency of AC that easy. How do you do that? I mean, like a DC, you could just change it all day long from one stage to the next. You could change the pulse rate.
You can change the frequency, but it's not an easy thing. There's things called like variable frequency drive where you can take a normal induction motor.
What are they using? Capacitor, variable capacitors to do that?
No, that usually takes the AC, converts it into DC, and then converts it back into AC.
Oh, that's how they convert the frequency of AC, like that. That's crazy.
That's one way. You can also have it.
I thought there was a much easier way without converting the AC at all and keeping the AC, running it into a coil somehow to change the frequency or somehow.
Well, you can change the phase that way, but not the frequency.
Not the frequency. Yeah, I know you can't change the frequency, but I thought there might be a way.
That's one of the ways, like
with wrappings.
Yeah, well, that's one of the things they do for three-phase motors when you only have a single phase. Is you connect the other phase with a capacitor on there, so it delays it. Same thing for like your start motor.
You could use wrappings to create a phase shift.
Yeah, it's a fake third phase.
To create a phase shift that generates you the frequency you want, right?
Yeah. You could also use like motor generator combinations.
Well,
all different kinds of ways of doing it.
When you phase shift two signals, right, it simulates a double frequency, doesn't it? Doubling the frequency.
No, you're thinking of heterodyning.
If you take two AC signals, delay one so that it
if you delay one, you will get one with the phase difference between the two. If you take two different
right, but the phase difference doesn't matter. I'm talking about trying to take a 60 hertz signal and manipulate the frequency of that without. And I've done this with capacitors and a diodes, a rectifier. But I can't do anything more than double the frequency. I can't do anything more than that with that system.
Yeah, doubling it's easy. Just put it through a full-length bridge.
Right, but you're not doubling
you're getting
AC.
120 hertz.
You're not doubling AC. You're not doubling the AC frequency. You're doubling the frequency, and in the process of doing that, you're converting it to DC. I'm talking about changing the AC frequency without converting it.
You're making it 120 hertz ripple, basically.
DC from AC, which
but then you connect the capacitor to it, and it's back to AC again. But it's a really horrible waveform.
You saying you can connect a pulse DC signal to a capacitor and it becomes AC? I didn't know that. How the hell did I not know that?
Yeah.
How do you do that?
Just put it in series.
Wait, you hook the pulse DC positive signal to one end of the capacitor. What kind of capacitor? A run capacitor, AC capacitor?
Just regular electrolytic.
Electrolytic, because electrolytic it only takes. DC.
Yeah, I mean, if you're using a lot of power, you might want to use a run capacitor.
So wait, you hook up the positive pulse DC to one end to the plus of the capacitor, and the negative to the negative of the capacitor. And out of that capacitor, you're expecting it to give you AC?
Yeah.
It's just going to turn the pulse DC into constant DC. It's not going to create AC.
No.
You need a little bit more than just a capacitor there.
No. That's if you're hooking it in parallel. If you hook it in parallel, it'll filter it out.
Parallel, that's what I described.
Series, it'll change its DC reference.
Okay, so series, you have the
DC
plus.
reference is the same as making it AC.
Let's hook it up series now. You have the positive DC hooked up to one end of the capacitor, the positive end of the capacitor. Where's the negative end of the capacitor hooked up to now?
It's in series with the signal.
With the negative side of the AC? I'm sorry, the negative
Either-
side of the DC
Yeah.
pulse.
Well, either way.
That's still parallel. Again, it's parallel.
No. In series, like in between there to.
Do you have a photo editor? You know how to use a photo editor or an art program in the computer to draw stuff?
I was just looking up. Just look up level shifter.
Keep it simple.
Yeah, this is like you go back. Well, figure it gave me the.
I forgot. An electrolytic. The long lead is the positive, right?
Well, don't worry about the polarity of it. This is usually a small amount. The polarity only matters when if you're using electrolytics, which is polarized, and you're using a decent amount of power.
Electrolytic polarized, decent amount of power.
Thing about it is, well.
Here, I got this. Look. You're going to instruct me on how to do this. 'Cause I got to know how to convert
Let's see.
to AC like that.
Well, you know what in series means, right?
Yes. So here,
Yeah,
tell me what to
you
do
put
here.
The catheter in series.
Tell me what to do here.
And you want it like a little bit of bleeder capacitor, otherwise it'll charge up and then it'll just once
Do
you
you
charge
see the
it up, it
screen?
won't connect. But
Look at the screen. What do we
you ever
got?
see one of these books? Malvino?
Yeah, well,
Guy
let's draw something in that book that you're talking about just right
this is
now.
the best one I've ever seen for
I want to
teaching
do
electronics.
this. I want to convert DC pulses. You know, you could pulse DC and simulate AC, but it's not going to create AC. It's not going to create AC.
Okay.
That's
do you
pulse
think,
DC will create.
what do you think?
You
is
know
the
this
difference
right here.
between
You know,
DC and AC.
that's pulse DC.
Show me what you think the difference is between DC and AC.
This is your pulse DC simulation of AC.
Where's zero?
Zero is, I can't draw straight, but it's right there somewhere.
Okay, so is that a DC or an AC signal?
That's their spike signal from a flyback from a DC pulse hitting a coil, and that can run AC devices because the voltage is high enough, and it has a negative portion, and it has a positive portion.
So does that make it a DC or an AC signal?
That makes it an AC signal.
Okay, great. Now, add 50 volts to that. Let's say it was a 100-volt signal. Add 50 volts to that.
This signal here?
Yeah, let's just say the last one was 50 volts or 100 volts peak to peak. Add 50 volts to that.
That's your general looks of a spike signal from a DC pulse, which will run AC, right? But it's not going to look like this, Anthony. That's your pure AC. That's your perfect AC. I mean, I don't draw perfect, but you know what I'm saying. It's the AC that we use to do everything. But you can use this signal also to run AC devices. And it's been done.
Yeah, this will work both with a signal or something that draws power. It's just a matter of how much capacitance you
So
have.
if you take this signal that you're talking about, which is a DC flyback signal, it's not the actual positive DC forward signal, it's the reverse signal. The positive DC forward signal is going to, let's say it's a square wave. Well, that's the portion that you're talking about connecting to the positive terminal of the capacitor, right? And
just where
if that's the case, then you're just creating DC constant. You're just using the capacitor to smooth out the DC. then that won't create any AC from this signal here. That's the forward DC signal. That's not the reverse flyback AC signal that is resulted from your DC pulse. So your DC pulse going into the coil looks like that, and it flies back like this, which is definitely has more characteristics of AC than this guy does. Because this guy does not have this. I know you saw that. So, yes, you're right. If you're talking about the flyback spike to do AC, that's how they do it. That's the only way I know.
Well, there's two different ways to change that. You can add a voltage to the signal, or you can use a different reference.
Right, I've heard about that. You mentioned that before too.
Let's say you were using ground between ground and your signal there.
Add a voltage to which signal? Which signal? This one?
Let's say that went up to 100 volts.
Well, first of all, I don't know which signal you're talking about here. Which one? There's two. There's two here. There's this one.
It'll work for all of them.
Oh. Well, you choose one because I can't think like that.
Let's just say your spike for the first one.
Okay.
So since that looks like it's a clear, there's a clear zero right there. Okay, and that did go up to 100 volts, and it went negative by 50. Let's just say 50.
Yeah.
Simple. So let's add 50 volts to it.
On the top side?
So now it goes up to 150 volts and it goes down to zero.
Well, hold up. No, it's not going to go from, because you already have 100 volts here, right? Mm-hmm. How is 50 volts going to get you any higher? 50 volts is going to bring you here again. You need 150 volts, not 50, to add 50. You're already got 100 up here. If you add 50, your 50 is going to meet up with the 50 that already exists right here. So your 50 that you add could look like that, depends on the duty cycle. If it's a square wave at 50, then yeah, it'll look like that added to this. But if it's a square wave at 150, then it will completely surpass this signal. And if the duty cycle's more than this signal, of course, it'll consume it all. And you probably won't even see the spike. It won't be, I don't know, maybe it will be part of it, of the consolidated energy. I don't know. You can't just add 50 to a 100 volt signal and expect it to go up to another 150, to go up to 150, because your 50 is a lower potential than 100. I got to stop you on that one.
That's not right.
You know that's the case though, right? You can't reach a higher potential with a lower potential.
We're not putting a word on it.
No matter what your amps are behind it, you can't reach a higher potential with a lower potential.
Really?
Even if the higher potential has a less amps than your lower potential with more amps, it's still not going to, top the higher potential with the less amps. That higher voltage is going to stay there. It's not going to go anywhere until it's loaded or used or diverted. But let's go with the, instead of adding 50, let's say we added 110 or 105 volts to this 100 volt signal, then you're going to get an extra 5 volts now on top of the 100. And that's just my opinion. The only thing that's going to come into play here is the duty cycle within there, and that's where all the amps is sitting, all the energy.
Okay, to keep things simple, let's say I give you a 9 volt battery. What's the most voltage you can get out of that?
9 volts.
Now I give you 3 of them.
Then you put them in series and you get your thing, yeah. Your 27.
You just added those together.
Right, but how do you put...
That's what I'm talking about.
How do you put a 50 volt signal in series? Usually it's parallel. How do you get them in series? 2 signals. I mean, one signal has to be ahead of the other for it to be in series. So that's your phasing, I guess. Maybe you have to send one signal at an earlier, and then the next signal a little later, and that would be series.
Can't believe I can't even find like a basic diagram for this. This is like something that was like really old.
Yeah,
But
you can bring it up just to present it.
Yeah. Weird how sometimes some of this stuff like that's like so simple but won't show up.
Now, if you phased your 50 volt signal ahead of the 100 volt signal, you would have a 50 volt and then a 100 volt, and then a 50, then a 100, then a 50, then a 100.
Oh, for one,
that would simulate another form of AC also.
For one, let me see. I'll see if I can find it here because this is really. They didn't mess around back then. That way you can see it's not just me saying it. What do you call it? Yeah, I don't see it. No, seriously.
There's so many ways you can pulse a coil. You can literally pulse a coil once with AC, then DC following that, and then a different signal after that. If you have the equipment to do it.
Okay, well, let's see. I might get this slightly wrong, but the principle is right because I'm pretty tired. But I will try to show you anyway. Let's see where.
Check out the program GIMP. It's a free photo editor. It's the one I'm using. It's simple to use.
Oh, you're using Linux.
It'll really be helping me out understand what you're trying to explain. And everybody else is trying to explain stuff. They should use this thing because.
Okay, here, if this will work for us. I don't know if it will.
I mean, just look at that.
Nope, didn't show up.
You hit Control Z anytime you want to remove something you did, and Control Y to put it back. It's pretty effective.
Says I'm sharing, so you think it would.
Check this out. Look.
I'm sharing the window.
Z, all gone. Control Y, it all comes back. It's just too handy. Too handy to use this thing. There it is. All right. Oh, you have one.
Oh, it finally showed.
Yeah.
It took like 15 seconds to
now
show.
We're talking, man. I was hoping you'd get through to doing something like this eventually, because you know what you're talking about, but you can't get it out effectively.
Yeah, especially when I'm tired. Okay. Let's say this is 0. Let's say this is. Forget the technical definition of ground, but let's just say this is 0. Which is what ground should be. Okay? And your waveform here.
I think you're right on that one.
Your waveform here. If I can get this to
That's the surface ground. Anything below 0 is below ground. Kind of weird to think of it like that, but
okay. Shit. Trying to make it 2 different colors, but doesn't want to co-op. What am I doing wrong?
Yeah, it's a learning curve. I got really good at.
Oh, okay, there we go. I don't know what I was doing wrong, but okay. Let's just say I'll just do the same kind of thing as your example, but just keep things easy.
There's a setting where you could make it so it doesn't draw straight lines.
Yes.
It's a button. I think it's called Snap to Grid.
Okay, I think that's a little bit bigger than I need.
No, just use the draw it on there. 100. You can use the brush tool. It's quicker, easier. You're gonna need the brush tool anyway.
There we go. 100 volts. And here's minus 50. And then the red line
Zero.
is 0. Okay. Now, before we were measuring here, this is, whoops. This is our first test lead. Here's our second test lead. Okay. Measuring 100 volts there. Now, if I measure that just with a scope, I'm going to see 100 volt pulses, and I'm going to see it here. If I measure it just on this side, let's say it's rectified, I'm just going to measure 50 volts between here and here, or 100 volts if it's rectified between here and here, depending on which way I have the diode.
Yeah.
Or I can come up with a new power supply. Why even stop there?
You mean add another source to the signal?
Yep. So
a negative source. Looks like you're.
Yeah, I can do a negative source here.
You want to enhance the negative portion of the signal.
And this signal here that I would have been measuring here previously would now be whatever this voltage is here. And let's say I made this minus 200. Well, you get the point.
Then you should end up with a minus 150 in total.
Instead of 0, whatever voltage I would have read here, say minus 200. So if it was 100, it's now measuring at 100.
No, it's not what it was 50. It's 50 right now, negative 50.
Well, that's the bottom sign would have been negative 50 too. The whole signal is going to look different because I'm looking at it from a different perspective. Same thing with okay, I'm going to draw transformers the way they used to draw them. This is really a heating element, but it's close enough. Some people draw it this way. I don't like it, but I'm picky. So, yeah, that's how the heating element, the resistors look. But some people draw them this way. But I'll just for the purposes of explaining, this will be a transformer.
Start learning to use GIMP. It's way easier, way easier. More stuff you can do in there too.
I forgot I had freehand in here. Oh,
I'm gonna send you a link in the private chat.
I had freehand in here somewhere, but I don't remember where it's at.
GIMP is free for Windows and Linux and Mac.
I tried it, but it ran really slow on my computer for some reason. But I need to try it again.
GIMP?
Yeah.
You tried it? You sure?
Yeah, in the preview where it used to show the pictures on the preview, for some reason that would run like extremely slow. I think it was like something with a weird driver or something. But get myself back here. Okay, but like we had the power company before, 13 kilovolts this side, okay, 240 this side. If I measured here to here, I would get 120. But if I moved that voltage from here to here, I would get 240.
Right.
Because
you're combining the two phases.
Yeah, that's the same thing we're doing here.
Yeah, but it's one wire.
We're changing the reference. It's the same principle everywhere.
But you have two references there, not one. You have either a 120 reference or a 240 reference.
That works everywhere.
You have three references. You have two references of 120 at two phases, and you have one reference at 240 at one phase. You have three references there. on the right side, as you have it drawn now. So you're adding another reference. You added another reference. Is that what you did?
Yep, another winding.
So now you have.
Now, let's say it reads from here
You
to
added
here.
another phase. So
Let's say it reads 480. That's not another phase. That's still in phase.
Well, it can be.
But now reading from here to here is now 480 volts.
At one phase, right?
Yep.
And you have two other phases there.
If I go here, I'll just measure 120 still.
Right,
Here,
but that's a separate
40,
phase.
Here, 480. If I come back here and
Is that
measure
a separate
here to
phase?
here, instead of having 480, I'll have 360. It all depends on what in between what.
Where's your return line? One of those has to be your return.
There isn't. It's AC.
No.
Don't think source and return. Okay.
Right, I got you. But
Now
let's
this
say we have to
here
point
may
out
be
one of them as a return.
This over here may be connected to ground. Okay. But that doesn't mean it's actually going through the ground.
Right, because you also have
the
a
main
common
lines,
connector
they
there.
frequently do that. Sometimes they don't. Sometimes
Right, but that's
they're
the
running
common
two wires.
layer.
But personally, I don't like them using the ground myself. Yes, it works. But let's say you're in the desert and you do that same thing sticking in the ground's not going to be as conductive. It's still going to work.
Right, because the positive.
But it's more resistive. Just because it's ground doesn't mean it's 0 ohms.
Well, that's because whatever positive you're giving you have likes to meet up with its own negative, not another negative. And every positive has its own negative already. And that's the negative it prefers to go to, not a separate lesser potential than its own lesser potential, even though it can go to a separate lesser potential than its own.
Okay, you're bringing up something that's going to get you more confused, but I'll say it anyway.
It's a single wire potential, not two wires. One wire.
Yeah, but you see how this all works here. There is no earth connection anywhere in this circuit. I never connected them.
The earth is just there for the lightning strike.
The earth is on this side for connection to, which may be 10 miles down the road. On this side, this is how the regular transformers work. I may add a resistor to ground.
If we were to tell people that the common line switches between a hot and a common every time the signal flips, they'll never understand anything.
There isn't just a source and a destination. It's all compared to how you look at it.
Right.
So, it's not really this is supplying it and this is supplying it. It's really divided across the whole. Whole area is making voltage.
Well,
okay?
for half the way, the top line.
It's not just like one point. The whole thing is making voltage.
For half the sine wave, the top line is the supply. And during that half, the bottom line is doing the negative. But when it flips,
it's not the supply.
No, it's the positive. Sorry, it's not the supply.
Right.
It's the positive.
Yeah, right. It
but
may be
when
the positive and
while the positive is influencing the top line, it's the negative of the AC is simultaneously influencing the bottom line. And then the AC has no polarity. So the next cycle, the polarity flips. And now the top line is being influenced by the negative portion of the AC. And the bottom line is being influenced by the positive portion. So, yeah, that's why you don't need a return with AC. But because the return keeps bouncing from one end to the other, from one wire to the other, it's AC. Yeah, I get where you're going at here. I understand that, but to think like that and to explain like that,
that's how the circuits work.
That's how the circuits work. But what I'm saying is to think like that and to explain like that is super rough.
It's all relative. Think of that for everything.
Well, you can think like that. If you're at that level with this stuff, but people that are not at this level cannot think like that. They have to think the way we were taught to think.
Just think if we were on the highway. I see you on the highway.
Before they think like that, like the AC. Like this is AC. This is AC.
This
plus
is actually
minus, minus plus, plus minus, minus plus, plus minus, minus plus, all day long. It just flips polarity all day long. So those two lines are never going to be plus. All one of those wires is not going to always be a plus. It's going to be a plus and a minus back and forth.
Yeah, this. Well,
that's not no way to teach because it'll just confuse everybody.
Well, this is
no
also,
way to learn either.
Yeah, hold on, but this is also makes it easier everywhere.
Confuse yourself thinking like that.
But think of it like on the highway. I see you on the highway. I pull up next to you. We're both going 75 miles an hour.
We're trained to look for ins and outs.
Yeah.
Thinking like this is not an in and out. This is a vibrational thought. Not an in and an out.
But hold on. Think of it this way. We're both on the highway. I pull up next to you at 70 miles an hour. We're both going 70. So there's zero difference between us. I could hand you a beer, or you could hand me back a beer. Wouldn't matter. We're still going just the same together.
Right.
That's the same as voltage or potential difference. We're both at the same place, so there's nothing between us. Now, if I go 10 miles an hour faster at 80, I'm going 10 miles an hour faster. We can't do that anymore. It'll be harder. We might be able to do it for
Right, we have to battle
we have to battle
a 10-volt potential difference.
Yeah, it's the same way with voltage. If you change where you're referencing this.
Yes, I totally get that, and I am on the page with you on that when you're explaining to me, but anybody else listening is not going to follow you. I don't think. I mean, unless they understand AC that way and can follow that way. It's not easy to follow that way. Even if you know AC and you understand it, it's not so easy to follow that way.
Well, if you just remember that the basic definition, a potential difference. It's not an absolute difference. If
the only way to follow that way is to see the line is vibrating onto the other line, not reversing polarity back and forth.
Zero?
And if you look at it as reversing polarity back and forth, it's going to appear to you as a vibration.
Well, it is. It is.
It is. It totally is. And if it doesn't appear to you as a vibration, then you're just going to get confused.
Well, until there's one other thing about this too, which might mess you up
because DC is not vibrating in the oscillating fashion. It's vibrating in the on and off pulsing fashion, and in that way you can simulate.
You can have a DC vibration. Or an AC pulse.
What's that?
You can have a DC or an AC pulse.
Right. Yeah.
That pulse that you had, like, that went like this. If this is ground, that's 5 volts. Well, I didn't draw very well, but that's the 5 volt level there. Mm-hmm. That's all the time in logic signals.
Right.
But you're only going positive. You're not going negative.
Why? Because you can send the base of a transistor a negative signal. It's not going to read it, or is it? I don't think it will, unless it's a PNP or an NPN.
If that's an NPN, you will turn on the transistor for that pulse. If you send a negative voltage to it, it'll just be reversed biased, and it will do nothing.
Do nothing. But if you send a negative 5 volts to the emitter of a PNP, it will trigger it. As long as you're positive 5. I'm sorry. If you send a positive 5 volts to the emitter of a PNP and you put your negative on the base, it triggers. Not like the NPN. The NPN requires the positive 5 volts on the base.
Not the emitter, the base.
On an NPN, you put 5 volts on the base, positive 5 volts, and negative 5 volts on the emitter. On a PNP, you put negative 5 volts on the base and positive 5 volts on the emitter. That's how you trigger those two different. One gets triggered with a positive at the base. The other gets triggered with a negative at the base. It's the biasing.
What you just mentioned there is the same.
Right. It's the PNP is reverse biased at the emitter.
I don't mean that. I mean you how you reference the voltages. You compared the voltages from two different places. That's the same as here. You compared to the base to the emitter. That's the same here. That's the same in all the other circuits. You're comparing two different places.
With AC, the emitter position keeps changing back and forth every time the cycle flips.
Didn't matter if it was AC or not.
If you're using AC, the negative is going to flip from one place to the other, and so is the positive. So if you're using AC to trigger a transistor, an NPN at the base,
a DC circuit.
if you're using positive 5 volt AC at the base of a transistor, NPN, it will trigger it for half the AC wave, the positive half. The negative half will be touching the emitter of that same transistor to trigger it. But as soon as the AC flips and puts as soon as the AC flips and puts the negative half at the base, that's not going to trigger the transistor. That portion of the AC will not trigger the transistor. Assuming it's a 5 volt AC and not more than 5 volts, and you don't blow your transistor.
Yeah, you can have this negative at minus 50 volts if you want, or you could have it at positive 50 volts.
Right, but as long as the positive is no more than 5, the transistor won't blow.
Yeah, you'd have to worry.
I don't know what the base emitter voltage is. On most of them, it's 5, right?
The voltages that it's rated at, but yeah.
Right. I think it's 5 or 10 usually, right?
Well, most transistors, if you go above 30 or 40 volts, this thing is going to be.
You're talking about base emitter?
Magic smoke.
Yeah, you blow it.
But if
you don't even want to go over 5, you don't need to go over 5 to trigger it.
Yeah, if you've got like a horizontal output, you might be able to put 1200 volts across there.
I'm not familiar with what that is, horizontal output.
All the old.
I know that you have horizontal TV chips for the horizontal lines. Has it got something to do with the chips from the TV, the horizontal chips and the vertical chips?
Back when TVs used to have fly volt transformers in them.
Uh-huh.
This is what would drive the flyback, the horizontal output transistor. In a TO3 container. They just happen to have more than a few laying around because they're really good transistors.
Horizontal output. I mean, what does that mean, though, horizontal output?
It's the output of the horizontal sweep signal, which drives the flyback transformer to make the high voltage, and it makes the other voltages in the TV also. It drive when you drive the flyback, you're actually making several different voltages in it. And you're also making the 30 kilovolts, 25 to 30 for the CRT also. It actually derives several voltages from there. It just has what's called a standby circuit that gives it a little bit voltages just to bias it in the first place. But
yeah, all I know about these horizontal transistors is that they do the horizontal projection on the TV somehow. And there's a vertical transistor.
It's just what they used when they were designing power supplies because it was a nice 15384 kilohertz signal. Man, I am rusty. I used to know all these by heart.
Yeah, it's not easy to stay. It's not easy to stay, lubed up with electronics. It's so much to know,
Yeah, I was just talking to the guy at the Old Man Builds, and he'd mentioned something on the output. I said, "Where's the diode?" And he's like, "Well, there's none in there." I said, "You sure?" Because usually it was in the molded package, but yeah, some of them didn't. And I just remembered back when the old tubes that said 6LQ6, it was the equivalent of that transistor there. That
that's a tube diode you're talking about, right?
Yeah, then that went into another place that said, warning X-ray. That was the high voltage rectifier, which was the diode before they had the high voltage diodes. So
yeah, the vacuum tube.
By the way, if you touch that, it really hurts.
Yeah, vacuum tube diode. The vacuum tube diode, right?
Yeah, I'm talking about the 6LQ6 anode. It was about that 1200 volts.
Yeah.
Yeah, it would let you know not to touch it again.
That's the kind of stuff they put in like amplifier, guitar amps, and heavy duty.
Yeah, you'll see the same TO3 transistors in all kinds of amplifiers, all kind of servos. And just basically, that's a power NPN transistor.
But you could also use a tube transistor, which has light in it somehow. Has light in it.
The tube transistors is just a filament so that it puts off more electrons.
And it's a diode filament, I guess. It's a diode filament.
The simplest one is it's used as a diode rectifier. Same thing.
Why does it emit light?
The filament puts off electrons, and then the
is there gas in those tubes?
As little as possible.
That's not what's creating the light.
They made it with high vacuum back then. It was with high vacuum.
It's like a light bulb. A light bulb.
The filament was the cathode. The other side was the plate. Was the anode. Which, if you look at some old diagrams, you'll see the diodes will say A and K. That's where the diode, anode, and cathode came from.
And so, why is it making light? It's not an LED.
Because it's a filament. It's a light bulb inside.
The light bulb is acting like a diode, or it's just a light bulb in there. What the hell do they need a light bulb in there for?
Because it puts off more electrons when it's heated up.
So they heat up the tube to
make
it work better.
It's heating up the wire that matters.
Heating up the wire.
Heating up the wire makes it put off more electrons. Way more electrons. I mean, I don't know the number, but I think it's something like 100,000 or million to one, something like that.
Those vacuum tubes are an interesting device for a transistor, or I guess a diode. Is it a switching diode, or those tubes switching? Are they switching?
Diode, as it only allows power to flow one direction.
Well, so it's just sending the amplified signal as clean as possible.
Yeah, the signal, or it could be used for power supply, turning it into DC.
Or whatever you want to use it for. It's just a way of channeling a lot of energy and keeping it clean, I guess.
Right.
From distortion. Because they do produce a high quality audio signal. I know that.
Actually, they're lower quality. People think they're higher, but they're actually lower quality. They sound good to us because they add distortion. Really? They give it that like warm quality. That's actually like adding distortion.
Maybe, but it's such a subtle.
That's what my instructors told me, and that's what I've seen. And there's even been circuits that made that way.
I admit I have played through transistor, not tube transistors, but your standard transistor amplifier, and those did sound awfully clean as well. But they didn't have that enough. They couldn't put out a louder signal without as loud of a signal as a tube amp could.
Yeah, there's a thing called microphonics, which basically means, trying to remember the physics of this. It's been a while, but basically,
I've heard the term. I don't know anything about it though.
Well, I'll look up the words because
microphones.
Yes. That's
just a coil attached to a diaphragm to pick up the
where
moving
it
air.
transforms mechanical vibrations into undesirable electrical signal noise.
Into undesirable.
That's the Google definition for it.
In the case of a microphone, it's transmitting desirable signals.
Basically, if this was a tube and you went like this, you'd hear that on the amplifier.
Oh, so that's what that's okay. So you're saying the tube transistors basically have microphone properties and they pick up external sounds. Yes,
and they make vibrations because there's current traveling through them, and that in itself causes harmonics. In other words, a little bit of distortion, which people like the sound of. Not a lot of distortion; it's just a little bit.
Yeah, give it that little touch of earthiness to it.
Yeah.
Like a Fender twin reverb, that's the tube amp I have, and it's the twin reverb model. But the other Fenders, they're not tubes. But
have you ever
heard they have a reverb coil in there? It's just a coil,
Did you ever hear the analog delay lines, the reverbs? Basically, where they send a signal down like a guitar wire and then pick it up later on, you can hear the whole thing vibrate in there.
I didn't know that's how
Very
they do
similar effect. You ever heard the reverbs? That's what, the reverbs that aren't all digital.
it.
The analog reverbs, that's what they were. They were just guitar wires.
So that's why they use a
You know
coil in the back of these amps to just delay the signal through that coil. That's what they're doing.
That was
I was trying to figure that out.
I mean, they do have digital now, but yeah, was how they did it, like in the 70s.
That's slick. And now they do it
Thing with
digital.
like the guitar pickups, it's just a coil with a few magnets in it, and then when the guitar strings vibrate, it vibrates the magnetic field, and that reinduces.
I think when the guitar strings move, when the strings move over the magnet of the pickup coil,
yeah,
it's
the same as a guitar pickup. Just
it interferes with the magnetic field of that magnet,
right?
And that changes the voltage on the coil wrapped around it to then translate that signal into the amp.
Yep.
I think that's what's going on because the string moves left and right or up and down.
Yeah, it's almost an identical idea. It's just a little bit different way of doing it.
But it's funny because you don't have anything on the other side of that string to reflect the magnetic field.
You want to hear something really interesting? They use that to make calculators.
Used what to make calculators?
That delay line. They would send a signal down it and store numbers in that somehow.
You got to explain that one to me. That sounds impossible.
Yeah.
How the hell you do that? You store data in a coil? How so? I mean, and you're saying by the time the data comes out the other end, what? It's still there. It's still the data, right? Why?
Yeah,
So you could store it in the coil and wait to take that data out of the coil by loading it later? So you could charge up the coil, put the data in there, don't load the coil, and the data sits in there? That's hard to believe.
I don't know exactly how long the signal.
It sounds possible, but I don't know how you would do that. But that sounds possible.
I've seen it on one of the videos on there, and I was like, "No way!"
You're talking about digital packets into the coil.
I don't know if they were digital or an analog signal.
Analog, you can put it in the coil.
Well, it wasn't digital as I don't think it was digital as in the sense of like now. It was more like digital turned into something, an analog signal, and then
even a digital signal simulating analog, the coil will still, interpret that as vibrations, and those vibrations will sit in the coil as long as you don't load the coil and remove the vibrations. But how long they vibrate within the coil without being loaded is a question that I don't know.
Yeah, the one I seen was like an early 1970s.
You can store data in the form of vibrations.
Oh, I owe somebody one. I found somebody that like labeled this like nearly the exact title of calculator delay line, but it's like some stupid simulation.
I gotta run to McDonald's.
But
it's 2 a.m. I gotta go get some food. McDonald's is about to take forever to get food over there. It's amazing. Everybody goes there at 2 a.m. I don't get it. You go to McDonald's at 10 or 9 p.m. and it's quick. you get there at 11, 12, 1, 2. It takes forever.
Everybody had the same idea. Check this out. Can you see that?
Hold on. Yeah.
Yeah, that's the memory.
This one?
That's a delay line.
I'm not seeing it. It's not popping up.
You're not?
You're sharing something already. You got to stop that one first. Right? You have one share open
I think
already.
it takes like 15 seconds to start. I have no idea why. I thought it would. I forgot I was still sharing. So let's see. Did I share by window or did I thought I shared by window? Oh, I selected a different window at the time. I didn't select the screen. That's why it's not working. Let's see. Stop screen. Now it should be working. Any luck yet?
Oh, there it is. Delay line memory from the 19th. What the fuck?
Yeah.
Where do you find this stuff? Where did you find this?
I had some of that too for a while. I wish I could find it. They did that by hand. All the little cores in there, they actually wound those by hand.
I believe it. It looks like it too.
Yeah, this was just.
Crazy. They were trying to store digital data, or what kind of data was it? In a coil.
Did it's very successful for a while.
In a coil. Now let me just make sure I'm getting this right. In a coil, right? Or wrapping.
Yep. And the vibration of it was in a long wire that would vibrate.
How did it keep the vibration going? Was it a tank circuit or what? Did it give it power or what?
They would keep repeating it over and over.
The data packet.
Except there was an analog signal then, but yes.
They were repeating the analog signal, which is what they were using to turn back into the data that they wanted to store.
If you know the way your reverb worked with the analog delay line, this is the same thing.
Huh? Yeah, I know. It's storing the signal from the instrument into the coil.
When you had it reverb forever, this is the same thing.
That's how they went to the moon. With this thing. Storing the data.
I guess you could call this RAM.
This is the space shuttle.
No, RAM isn't the right name because RAM's random access. This is serial access memory.
You know, I had no idea that this even was a concept.
Yeah, this is before they had random access.
This is before they were storing. They're storing magnetic memory in the coil instead of on a magnetic surface.
A magnetic to mechanically vibrate it, and it mechanically travels through the coil, and then it's picked up magnetically again.
So they weren't storing the data, they were transmitting it.
They were storing it for a short period of time.
Before it got transmitted?
Basically, think of it this way. You've got this mile piece of wire. And, you know, like the old two thing with two cans, and you talk into it, you know, it takes 10 seconds to get to the other line, and you pick it up. Only difference is this is in a coil.
Right. So however long it took for the signal to get from one end of the coil is how long it could store the data. Pretty much.
And then they just repeated it.
And that was your threshold of storage capacity, and then you had to send it out after that. It's like the grid.
Yeah.
It's like the power grid does it. Same thing. It's storing the AC signal in a transformer before it sends it out to the next transformer. I mean, it builds up the AC signal in one transformer, and then it sends it through the wire. It builds up the signal in the next transformer, sends it through the wire, builds up the signal in the next transformer, until all the transformers are saturated with the signal.
It's basically sound memory.
Well, electricity is a form of sound. We just can't hear it.
Through the wire that's storing the information.
You can't hear 60 hertz. Anthony, you cannot hear 60 hertz. It's below your audio ability.
Yeah, you can. I hear it. It drives me nuts. I can hear down to about, I don't know, 25, 30 hertz at least.
Hold up.
Maybe 10 hertz or 5 hertz if it's a whole lot louder. You can. It's more than feeling then.
Human hearing bandwidth. No. You may be able to hear 60 hertz. I'm not sure. I don't want to.
First of all, that's
Hearing
not
range.
actually the human limits. That's the average human limits. When I was young, and they came to school and did the the hearing and the eye
Holy
test.
crap!
I asked them to go higher in frequency, and I got up to 23 kilohertz before they just stopped the test. They were like, no, I was just having fun with it because I was just curious. But I was up to 23 kilohertz, and I can still hear great.
You're not going to believe the chart I just found, dear. Look at this thing.
Oh, here's something for you. Did you know you can hear ultrasonic sounds, but not consciously? Look up ultrasonic hearing. That's a real thing.
Ultrasound
I was conscious of it.
That's ultra low frequency or
Ultrasonic, as in bats.
ultra high? Okay.
Yeah, although what the ultra low is called infrasonic, and yes, somewhat. I think that's why. You know how animals freak out before an earthquake? I think that's why.
Can you see this? This is the hearing range of all the animals that they are able to know the hearing range of, and humans are in this range. We can hear. Can you see that?
Yeah, that's average people. If I was like 12 years old and I can hear to 23,000 hertz, I'm sure I'm not the only one.
Humans can hear from 31 hertz to 19 kilohertz. So that means we can hear 60 hertz. You're correct.
Yeah, maybe a little higher, maybe a little lower.
But below 31 hertz,
because this
we
is based
cannot
on
hear.
averages. Get kind of like your 20/20 vision. That's what the average person can see. It's not what the limits.
We can hear higher frequencies than elephants can.
Yeah, I can see a lot better than average too. When I was growing up and up until I was about 45, I had 520 vision. In other words, I could see at 20 feet what most people can only see at 5.
The little brown bat can hear 115 kilohertz high frequency. We can hear
a horse at 335, or is that 33.5?
19 kilohertz is our high frequency ability. The horse is 55 hertz to 33 kilohertz.
What's cat?
The horse can hear higher frequencies than we can, so it's kind of like the dog,
Yeah, I think most animals can hear a lot higher than us. At least I thought.
Not the elephant. But the elephant uses its trunk to transmit ultra low frequencies, and it communicates for many hundreds of miles like that.
I don't see cat on the. Oh, there's cat. 77 kilohertz, 55 to 77.
That's a lot higher frequency than we could hear.
Yep.
We've got to wonder what they're hearing.
Some people have said they act weird around gas leaks too. Sometimes gas leaks will put out ultrasonic signals.
Interesting chart. So yeah, I guess we can hear 60 hertz. I didn't think we could hear that low.
I think most people can hear 60 hertz, although just most people just kind of ignore it.
But all the frequencies are audible to. They're audible.
If you ever hear it like on a amp, most people can hear that. But just regular transformers, they can't hear it. Mine, my little bitty transformer in my furnace, because it's connected to the sheet metal, vibrates that 60 hertz through there. And even though this is a relatively low signal, I'm 20-something feet away, it just irritates the hell out of me sometimes. And I finally took the transformer off, and I put a bunch of rubber washers in between, but just threw it back in.
What I heard from doctors about being irritated by frequencies is that's heavy metals. So, and that happens to everybody.
I'm talking audio signal, not the 60 hertz voltage, the current. I'm talking an audio signal.
Well, audio signal is a higher frequency, isn't it?
It can be higher or lower.
All right, it doesn't matter if you're getting irritated by frequencies.
There can be like 100 megahertz sound.
You have too much reception in your body to these frequencies through the heavy metal deposits. That's why. And copper is a big one.
I don't know how that part of it works. I just know that it can exist.
Well, if you eat nuts, you got a lot of copper in you. So you like peanuts and cashews, then you're taking in copper. Copper conducts, and it becomes toxic. It becomes too much. If you eat chocolate, you're going to get a lot of copper in you.
You think I'm in trouble?
What is that?
I said, do you think I'm in trouble?
Yeah, I eat them too. I love them.
I just ate one that was twice this big.
I love them. They're delicious. But you know what? And nuts will also make you feel better. You know why? Because it shuts down your bile flow, and your bile is probably toxic. And nuts have copper, and copper shuts down your bile flow. It also shuts down your sterility, your fertility.
Somehow I wouldn't have associated copper with nuts.
Yeah, well, nuts are brown. If you look at a copper pipe, it's brown. And when the copper oxidizes, it turns blue-green, just like the grass and the plants. Because plants have copper oxide, and they have chlorophyll too, which also makes them green. But copper oxide also gives them the blue-green color too. Just like a piece of copper that oxidizes on the floor, it turns blue-green. Or Bernai is doing the GANs with copper. You see how it turns blue-green. That's the color in plants. That's because plants have copper. They get the copper from the ground. That's how they get that color, because the earth has copper. The soil has arsenic.
I've seen this thing that was from like the 1950s that said the soil is really depleted of most of the minerals.
Not copper and not arsenic. In Florida, the whole state has arsenic. Some parts of the state have more arsenic than others. It's completely natural.
Hey, what's the
other states have other toxins in the ground, like copper, or if it's not arsenic, it's something else. This is from asteroids and comets and space debris.
Yeah. I just noticed, and there was one in there that says 17 hertz to 10.5, and a couple of them going down to 20. Oh, a ferret is 16 hertz. Man, that's a wide range. 16 to 44 kilohertz.
It can hear low and pretty high. But look at the.
I would have thought the smaller the animal, the higher the frequency.
The porpoise has the widest range. And the beetle-nosed dolphin.
Of course, they're in water, so the sound travels faster. That's got to change the way things work.
Sea lion. That's amazing. I don't even know how they figure this stuff out. They must have took all these animals and tested their reactions to different frequency.
Yeah, I always wonder, because of stuff like that, how they determine that, whether they like dissect one of them and see how their ears work, or they just see if the animal does anything. Then probably a little bit of both.
The only way is to blast a tone at their ear and look for a reaction.
Oh man, all the beached whales and all these things. Some of the sonar from some of the ships now put out 500,000 watts of sound. And then they wonder why they're beaching themselves.
Yeah, that's no mystery anymore.
Yeah, it's anyway. That would be bad
They're
enough
covering it up.
Air, but water conducts the sound much better. That would be like.
That's the Navy.
Yeah,
they were testing they're testing out their new equipment under there, and it's killing the damn whales.
Yeah, that's got to be like an unbelievable, painful amount of sound.
They got these huge pineal glands, the whales, or they pick up all that stuff real easy.
Oh yeah, probably that too, in their lungs too.
Well, it's the pineal gland that receives sonar, not the lungs. But
no, the lungs, because it's an air cavity.
It might play a role, but it's
Yeah,
the major organ that does the sonar is.
Do you know what LRAD is? The acoustic weapon?
I've heard of it. I don't know what it stands
You
for.
know, LRAD's what they use for like the crowd control.
Oh, right. Yeah.
Yeah, one of the things mentioned in that was it causing more damage in the lungs and the other areas of the body with air cavities in it because it would resonate more in those cavities.
Yeah, these frequencies and cymatics and resonances are both able to create life and destroy it.
Yep.
I can say
Oh,
that.
come to think of
1,000
it, your
times.
sinuses too. So
if you don't know what you're doing, they can harm you. These frequencies, and they can also heal you if you know what you're doing. You know, you got to know which frequencies to use, what amplitude, and all that. It's a very sensitive science. The using frequency for healing anyway. That's a very sensitive science.
yeah, I've heard it with the cats around 40 hertz.
Right. I mean, you know, but how
there's
many
not
cats?
something-
How many cats that had to get sick before they figured that out? You don't want to. You don't want to be that guinea pig. You know.
Well, they said it was helping heal people too.
Right, and I'm sure some people got
Might be a
sick because they
psychological
tried other
component to that
frequencies
too,
before
but-
they learned that as well.
Yeah.
And you don't want to be that person either. That's what I'm saying.
I kind of wonder if that might be true to help.
It's unfortunate with these sciences that you gotta, you know, there's these casualties along the way. Always, there's got to be a smarter way to do these things.
Yeah, too much science that cares. Just
Look at
money.
the atomic bomb. You know, they didn't create it to avoid casualties. they created it to create casualties.
Yeah.
And along the way of creating it, there was plenty of casualties.
So that's the reason some of the stuff that I've thought of, I will never talk about. Because I've thought a few things that was some minor changes that.
I got to throw an idea at you and go off air on this because it's too good, and I don't want it to spread out there.
Good.
But hang on, I'm gonna end the stream and we'll go another 5 minutes. I'll relay this idea to you. And
oh yeah, I forgot about that.